No, no, sir.
Oh, then
Yes.
Time is 9:45.
Yeah,
So,
yeah. I have
one time
already.
is 2:30.
okay, then 9:45 right?
Yes, sir. Already we are in live. Whatever time we are able to, you can see also in YouTube, sir. Already it's
The
live.
screen that we will.
No, no, we are talking many things. Don't link it to YouTube now. When the program will start, that time only.
Sir, it's just for the demonstration. You can see in our YouTube channel it's already live.
No, no, it's not.
वन आ रहे तो यहाँ तो आ रहा है, यहाँ लाइव हो गया ना। अरे ये तो लाइव हो गया ना, देखिए ना 9:45 वाला, 26 का 9:45 इट्स ऑलरेडी लाइव।
So we have to be very careful while speaking.
Yes.
All of you very careful while speaking because YouTube channel is on.
সেটা এই মিটিং
গরম কোড়া
আমরা কথা বলছি কেন ভিডিও দেখা দিব কিন্তু মিউট করতে পারবে।
We can't hear anything.
With this contentment, I, Swati Patnaik, research scholar of this department, welcome you all to VISHLESHAN 2022, the Doctoral, Colloquium and Research Scholars Day, jointly organized by Department of Industrial and Systems Engineering and University Chapter of Institute of Industrial and Systems Engineers. I would like to welcome and thank all our sponsors, that is Aarti Steels and Limited, Mr. Shantanu Bhoi, Mr. Sandeep Pal, and Mr. Valerian from Indian Iron and Steel Sector Skill Council, Mr. Saptrishi Das, Mr. Avik Das, Mr. Samik Gupta from Electrometer Corporation, Mr. Amit Singh Gwal, Mr. Govind Narayan Saxena, Mr. Dinesh Kumar and Mr. Ravi Ranjan from Central Coalfields Limited for supporting us. Now I would request our HOD sir, Professor J. Maiti, and our Professor J. Maiti and Professor Mamta Jenamani, the research scholar coordinator, and our senior professor, Professor Biswajit Mohanty, to come on the dais.
Welcome.
Now I would request Professor Mamta Jenamani, Research Scholar Coordinator, to deliver the welcome speech.
Thank you, Swati. Professor J. Maiti, Head of the Department, Professor Mohanty, our Senior Professor, all my colleagues, and my dear research scholars, and all the industry participants from our who are come from our sponsors. I welcome you all to this August occasion, and this Research Scholars Day is something. It's an occasion through which we demonstrate all our scholars' skills and the achievements that they have made throughout the year. And since past 2 years, because of COVID, we were not able to do it physically, but still we continued our effort in a virtual mode. This time we are mostly having all our activities offline, but we are also at the same time we are trying to have some kind of hybrid mode so that others who are not present in the campus are able to attend it. So having said this, so let us just have a look at what all activities, research activities are going on in this department. This specifically for our friends who have come from the industry. This is extremely important to know that whatever is shown in terms of posters or in terms of presentations that they are going to attend, beyond that also we do a number of things. So now if we try summarizing everything, if I try summarizing everything now, it may not be possible, but we basically touch the dimensions such as work system design, quality, ergonomics and human factors, and information systems, and so on. So these are some of the areas in which our scholars do their work. To name few of the very important projects that is going on in our department, the scholars basically come from two sources to this department. They come from regular students as appointed by, as selected through our research channel, or they can also be sponsored from various projects. So now the projects which are coming from the projects again are of two types. The projects which are coming from the sponsors like research sponsors like DST, etc., DST, MHRD, ACRB, etc. And there are other channels like from industry directly, they also come. So now when they join this department, the selection procedure, we follow a rigorous selection procedure, and they have to go through certain written tests followed by interviews, and through which they get selected. And after this rigorous process, they are supposed to carry out their research in the field of common interest, which is common to their supervisor as well as their personal interest. And for the knowledge of our industry friends, we also have a scheme for getting scholars who are working in the industry. So for industry scholars, there are little relaxation in the sense, even if they are, they have not completed their master's degree, they can also join the research if they qualify our minimum selection criteria. Of course, they also have to go through our written and interview phase, but there is a new channel through which they can they can avoid staying here for long, but they can still continue their research. Now, coming to the various achievements of our scholars. Our scholars present themselves not only through this particular avenue, that is our Research Scholars Day. They also present our activities in various international conferences and other avenues. And we also have our scholars working on practical industry problems, for which they also regularly visit various organizations, and they get the practical problems and they give a research dimension to it. So at the same time, when they are solving an industry problem, they also equally contribute to the academics. And this time, for the first time, we have our master students joining this team. Our master students, though, are this current batch of the master students, though they are here very recently, because most of their coursework they did staying at home because of COVID, and after joining with a short notice, they have also tried presenting their skill set through posters. So with this, once again, I welcome you all to this August occasion, and I thank our head for, in the very last moment, we tried really, I was really not hoping that we'll be doing it in this great scale, because in the very last moment, we were thinking that we'll be doing it in the first, in online mode, then hybrid mode, and finally most of the events are happening online. I'm really thankful to Professor Maiti for making this happen and getting sponsorship in the last moment, and encouraging our students once again to come out of their stagnant online mode and being active in this occasion. Thank you so much.
Thank you, ma'am. Now I would request our head of the department, Professor J. Maiti, to address the gathering.
Okay, very good morning, Professor Mahanti, Professor Janamani, the faculty members and research scholars and sponsor for different companies, as well as MTech students, staff, other members of the ISC department, as well as from others department. Very hearty welcome to all of you. Today's program has two different, I can say, section. One, in the first half, basically we are doing the RS Day events along with this welcome session. And in the afternoon session, primarily on the doctoral colloquium perspective, there will be inauguration as well as the keynote speeches by high eminent personalities of I can say of global standards like Professor Shankar Kumar Pal, ex-director Padma Shri, as well as probably the best known person in the subcomputing area in the entire world. He will be presenting in the next session, as well as there are two keynotes, one from industry in the morning session and another one will be in the afternoon session. So, so that way, basically, we have framed this today's entire day program. So, on the morning half, RS Day events are primarily being held. Afternoon session, that doctoral colloquium portion will be covered. But both the, I can say, the events are very, very important. We have combined in one day, but it is very difficult to do in one day. We need probably 2 days. Next time we will do in 2 days. Today, 1 day, because of what Professor Mohanty already mentioned, Professor Janamani already mentioned that we thought that we will be doing online because of the pandemic issues. And then things get easy for us after this some kind of improvement in the COVID situation. And we thought that let us do in the physical mode. And in fact, I can tell you, this is wonderful to see that so many research scholars and as well as the MTech students, they join hand together and now they have made it wonderful. And I think probably around 10 days, all of us work together and that has happened. So very big hands to all the research scholars and MTech students. So I will not extend that talk in this short period of time. What I want to tell you that Madam Janamani has highlighted some of the research areas of our department, but our department is really very, very good in supply chain management, operation research, data science and data analytics, and system thinking, systems modeling, and then e-business, e-commerce, as well as the other areas like human factors and safety engineering, productions and product design. So you can see that in any areas, whatever you have seen in industry, everything is basically some way or other connected with our department. And I'm telling you, the best thing of ISC department is if you are an engineer and you have done some education in industrial and systems engineering, you are perfect engineer. That is the great things, because what you do in your different branches of engineering, that is not sufficient. It will become complete when you will go through the industrial and systems engineering subjects. Tell me the performance that functions, productivity, quality, reliability, safety, comfortability, sustainability, even profitability, whatever you coin from the industry perspective, your business point of view, everything is some way or other way connected with this department. And we teach tools, techniques, approaches, management principles, engineering principles, applications, all those areas. And that's why our department is probably the best sought after department in the world. Particularly what I understand in USA, probably this is after computer science, people prefer industrial and systems engineering. It has a lot of potential. So we, within short span of time, Professor Sri Krishna Kumar is there, Professor Janamani and Gaurav, Ranit, and other students, research scholar team, they work very hard and brought so many sponsors, as well as basically you all from industry came here and you are supporting us. We'll again go to you, we'll reach out to you frequently and in a way that you find value. Not that just we'll go and tell, okay, give some answer. That kind of era has gone. It is no a free lunch session. Every time it is basically you have to provide your value addition. If we do not give value to you, you will not come next time. So that is the message I want to give to all of you, that yes, this is a department which creates value in your all business functions. So any problem you face, come to us. If we cannot solve, then nobody can solve. Although it looks very arrogant in saying, but that is the stature of this department. And research scholars, you did a wonderful job. Professor Mohanty is there. He will be highlighting some of the points. So thank you all for coming here. Thank you so much.
Thank you, sir. Now may I request Professor Biswajit Mohanty, Senior Professor of our department, to address the audience.
Right. First of all, a very good warm welcome to all who are present here. And I also, very much what you call enjoying the company of our head, Professor J. Maiti, Professor M. Jenamoni, all my colleagues, the research scholars, other students, and the industry participants. Now, on the auspicious day of the research scholars, in my mind, two very interesting thoughts are coming. You see, and these two thoughts are not really going together. They are going in two different directions, and that is what is interesting. The first thing is that after globalization in the 90s, the world is becoming more and more connected, is it not? People are talking about that, if two completely different persons in the world are sitting in two different sides of the world, and you just try connections between them, probably only by a few connections, 6 or 7 connections, you can connect one to the other. Is it all right? So we are all in social media. You know your friends, but do you know your friends' friends? You may not know. Who knows? You may be too connected with somebody whom you cannot even think that, he is your friend's friend. So that is the power of networking. That is the power of connectivity. And, it gives us a false thinking or a false feeling that we are increasingly becoming more and more and more connected. That is the first dimension. Now, before I proceed any further, let me tell you, the kind of things I'm telling you now is not true maybe generally, but it's definitely very, very much true for the research scholars, right? Particularly the person who is doing research here. That is the second thing. When you come to the research, something very peculiar is happening. All the, like if I give a very simple example from an industry point of view, all the low-hanging fruits are already eaten. If there is a tree and academic or research work or industry problems, low-hanging fruits are not there anymore. You just cannot discover P equal to MF and B Newton. Not possible anymore, right? So not only P equal to MF, where it is not P equal to MF and all the things have already been discovered. So where will you go? You go deeper and deeper and deeper. There is no end to these, going deeper and deeper and deeper. So when you go deeper and deeper, you go to a compartmentalized, a highly focused area. What is happening? When you go very deep, you are alone. You don't find anybody near you. Your friend with the same teacher, same professor is working. He is not working in your area. he is working in a slightly different area. Let me give a practical example. Let's consider the topic whom we all discuss, supply chain management. If you see supply chain management, the basic idea of supply chain management is, combining all those concepts which were earlier very, very much relevant in industry perspective, the purchasing, the inventory management, material requirement planning, MRP, MRP2, bill of material, all those things, have been combined and really focus on what? Focus on the integration between the raw materials on one side, the raw material suppliers on one side, the industry in the middle, and the customers on the other side. Idea is that if I combine all of them, if I concentrate on a bigger system, we can get certain additional benefits which can never be obtained by system inward thoughts. Then people took it further. They thought, if we have raw material suppliers, why not suppliers to suppliers? Why not customers to customers? Let's go more and more integration. And this integration has come to such a level that people are now talking about integrated countries. Integrating European Union, very, very big supply chain, global supply chains. This is going on one side. That's the integration part. That's the networking part. But when a research scholar comes here to do research, they are doing research on last mile logistics. What is last mile logistics? Working on a topic which is, earlier probably it was not there. People are living in small buildings. Now people are living in large buildings. Very, very long, lot of stories in a particular building. A person comes to supply material, maybe Amazon or Flipkart supplier. When he comes there, he has to supply or she has to supply not only to one flat, maybe multiple flats. And cannot be said as, one delivery or multiple deliveries. If you call it one delivery, it takes very long time. If you call it multiple deliveries, then also a lot of integration is possible within that itself. So people are doing research there. And that is very compartmentalized. Now tell me, if each of the research scholars, each of the academic persons are working on, compartmentalized areas, how will they come together? How will they become networked? And if they do not become networked, what will happen? What will happen is, world is not going to end after they get their PhD degree. World will continue. Their life will continue. They have to find places in the real industry, in the real academic world, where they have to guide students, they have to teach subjects, they have to interact with UG and PG and different kinds of students. They have to really increase the diversity. They have to grow in breadth, not just in depth. And this breadth, how will it come if you do research on compartmentalized areas? Think about it, all research scholars, please think about it. If you do not think about it, if you do not really increase your horizon, if you do not think beyond your specific area of focus, if you do not create an integrated mindset, if you do not create a systemic viewpoint, a systemic thinking, you are not going to do very well in real world. And Research Scholars Day in one such opportunity to come together, to share ideas, to talk with each other, and to become integrated. With this thought, I think all of you will be ready to enjoy the day and enjoy all the very, very interesting programs which our head has already narrated. Thank you very much.
Thank you, sir. Let us have a break for the photo session now and then proceed towards the tea arranged outside. Let us meet again at 10:45 a.m. Thank you.
ये वाला
एक तो अभी करा देंगे, एक का 2 से Ensure proposition करवाना
इनकी कमी से हमारा विकास प्रभावित होता है। झारखंड के दुर्गम क्षेत्रों में बसने वाले गांवों में भी यह सुविधा सुलभ नहीं है। सीसीएल के खनन क्षेत्रों के आसपास भी ऐसे कई गांव हैं। अतः सीसीएल ने कोयला मंत्रालय के मार्गदर्शन में अपने सीएसआर कार्यक्रम के अंतर्गत सन 2020 में ऐसे गांवों को सोलर ऊर्जा से पेयजल तथा रोशनी पहुंचाने की पहल की है और चंद महीनों में ही यहाँ के लोगों के चेहरों पर आ गई अनूठी चमक।
इसमें लाइट का बहुत दिक्कत था हमारे गांव में, तो 1500 सोलर पैनल के साथ पंखा और बैटरी और 2 बल्ब ग्रामीणों को दिया गया है।
दरअसल चतरा जिले के टंडवा प्रखंड में स्थित सीसीएल के आम्रपाली, ओसीपी तथा चंद्रगुप्त परियोजना क्षेत्रों में परियोजना प्रभावित कई गांव हैं। इनमें से होन्हे, कुमरंग खुर्द, कोयाड बिरहो
So we will continue in few minutes.
No problem.
इनकी कमी से हमारा विकास प्रभावित होता है। झारखंड के दुर्गम क्षेत्रों में बसने वाले गांवों में भी यह सुविधा सुलभ नहीं है। सीसीएल के खनन क्षेत्रों के आसपास भी ऐसे कई गांव हैं। अतः सीसीएल ने कोयला मंत्रालय के मार्गदर्शन में अपनी सीएसआर कार्यक्रम के अंतर्गत सन 2020 में ऐसे गांवों को सोलर ऊर्जा से पेयजल तथा रोशनी पहुंचाने की पहल की है और चंद महीनों में ही यहाँ के लोगों के चेहरों पर आ गई अनूठी चमक।
इसमें लाइट का बहुत दिक्कत था हमारे गांव में, तो 1500 सोलर पैनल के साथ पंखा और बैटरी और 2 बल्ब ग्रामीणों को दिया गया है।
दरअसल चतरा जिले के टंडवा प्रखंड में स्थित सीसीएल के आम्रपाली, ओसीपी तथा चंद्रगुप्त परियोजना क्षेत्रों में परियोजना प्रभावित कई गांव हैं। इनमें से होन्हे, कुमरन खुर्द, पोयाड बिरहो,
So we will continue in few minutes.
No problem.
विकास प्रभावित होता है। झारखंड के दुर्गम क्षेत्रों में बसने वाले गांवों में भी यह सुविधा सुलभ नहीं है। सीसीएल के खनन क्षेत्रों के आसपास भी ऐसे कई गांव हैं। अतः सीसीएल ने कोयला मंत्रालय के मार्गदर्शन में अपने CSR कार्यक्रम के अंतर्गत सन 2020 में ऐसे गांवों को सोलर ऊर्जा से पेयजल तथा रोशनी पहुंचाने की पहल की है और चंद महीनों में ही यहाँ के लोगों के चेहरों पर आ गई अनूठी चमक।
इसमें लाइट का बहुत दिक्कत था हमारे गांव में, तो 1500 सोलर पैनल के साथ पंखा, बैटरी, 2 बल्ब ग्रामीणों को दिया गया है।
दरअसल चतरा जिले के टंडवा प्रखंड में स्थित सीसीएल के आम्रपाली, OCP तथा चंद्रगुप्त परियोजना क्षेत्रों में परियोजना प्रभावित कई गांव हैं। इनमें से होनही, कुमरन खुर्द, कोयाड बिरहुल,
So we will continue in few minutes.
It doesn't look good. He's just there and we are doing nothing.
We are
Hello, good morning. Ma'am? Where? Oh, here.
At the desk.
Oh.
Yeah.
sir, ma'am wants to continue.
Good morning.
You are muted.
You are muted, Arvindan.
You are muted. One minute.
Good morning, ma'am. How are you?
Hello, how are you?
I'm very nice, very
No,
good, ma'am.
still you are
Thank
not audible.
We're still not audible?
Still you are not audible. Just
Okay. Is it audible now, ma'am? Is it better?
no. He is still not audible.
Oh, okay.
No, how? I mean, you have speakers. So why he is not audible then?
He is audible a few minutes ago.
He was not.
That was the problem from their side.
Then how everybody will hear him? Here.
Lag bhi aa raha hai? Lag.
No, lag is fine. Lag is fine, but we should be able to hear him.
Yes. Ma'am, can you hear me now?
मेरा माइक ऑन करो. उनको प्रेजेंटर बना.
Am I audible
Was
now?
he audible before some time?
Yes, ma'am.
Am I audible now?
ऑडियो देखो ठीक है सिस्टम का ऑडियो देखो तो
Am I audible now?
सिस्टम नहीं यू हैव कनेक्टेड थ्रू दिस लैपटॉप कौन सा कहां से कनेक्टेड है ऑडियो देखो म्यूटेड है वहां पे यस
Hello.
देखो तो वॉइस थोड़ा तो है फुल है ठीक है
Hello, can you speak once again?
Yes, ma'am. I am able to hear you clearly.
No.
I'm able to hear clearly, but the voice is not coming through. Let me check from another device.
I believe the audio system is connected, na?
Yeah. It's connected, but not able to hear.
Only we have to increase the volume. करो volume बढ़ाओ.
Ma'am, now
Now?
Is
No.
it better?
No,
Hello.
are everybody going to hear from that laptop? Then, but why not?
Are you able to hear me now?
Yes, it's coming, na?
No, he is coming, but he is coming through that laptop speaker. That is what is not our purpose. So we should have.
Then we can put some mic there and probably that will work.
Am I audible now?
Yes, system का mic दे रहा हूँ. डालिए वहाँ पे.
Hello.
ये कलर मैक यहाँ पे. बस किस तो वही करिए आप कलर मैक को डाल दीजिए ताकि चलेगा फिर.
हाँ.
वहाँ पे कलर मैक को वहाँ पे.
वो कर सकते हैं लेकिन इको होगा बहुत.
नहीं होगा.
I'm able to hear you.
Yes.
We are able to hear, but the thing is now we are able to hear you through that laptop. But we have a large gathering over here, so everybody we will be making.
Okay.
Sound is from the speaker.
मैम आपका भी आ रहा है और स्पीकर में भी आ रहा है. आप एक बार रिस्पॉन्स करने बोलिए. आप लोग देखिएगा नोटिस आपको साउंड आएगा.
Can you please speak once again?
बैठने को कैसे आएगा?
Yeah. Am I audible now, ma'am?
Yeah. Now it is perfect.
Okay, right. Thank you.
उनको पुलिस नहीं होगा वो. डॉट पिन. भाई पुलिस इनको हटाना
Why he is appearing in two places?
Okay. I know why. I just joined from another mobile just to make sure things are not going wrong from my side.
Make it full screen.
So, Swati, you can now.
Full screen.
Shall I start?
ठीक है, it's okay. ठीक है.
Welcome back. Before moving to our next session, that is keynote session, I would first like to felicitate our sponsors. For that, I would request Professor Mamta Jainamani, Research Scholar Coordinator, to come upon the dais. I would request all the members of Indian Iron and Steel Sector Skill Council to come forward for felicitation.
Make it large screen.
Thank you so much. Next, I would request all the members of Electrometer Corporation to come forward. All of us should be visible together. Next, I would request all the members of Central Coalfield Limited to come forward. You can join, sir. He is already taking photographs. Please come.
Now moving towards our first keynote speech. It's my great pleasure as a Gaurav Kumar, IIC University Chapter 660 President, welcome a distinguished personality in our first keynote speaker, Mr. Arvindan Srinivasan, who is currently working as Head Asia Pacific Manufacturing Engineering Supply Chain MOG. Mr. Arvindan Srinivasan is a manufacturing leader with 25 years of experience delivering best-in-class manufacturing engineering capabilities in factory and supply chain environments. In his career spanning over 2.5 decades, he has worked in various engineering roles, which includes driving manufacturing technology as CTO of IAMPL, a Rolls-Royce Hindustan Aeronautics joint venture, developing manufacturing supply chain across India, Southeast Asia and UK for Rolls-Royce jet engines, and working hands-on in assembly and machining of automotive, aerospace, and medical equipment for HAL, GE, Indian Railways, and Bosch. He is currently the head of manufacturing engineering for MOG's Asia Pacific supply chain. Mr. Srinivasan holds an MTech in Industrial Engineering Management from Indian Institute of Technology, Kharagpur. His research interest includes application of digital-based technologies in manufacturing engineering. Now I request you, sir, to kindly start the session.
Thank you, everyone, and thank you for the introduction. I would really want to, convey my thanks for the department to give me this opportunity to have a conversation with a wider audience here. It's my honor. So thank you very much for that opportunity. Let me share the screen. And can someone confirm if you can see the presentation now?
Yes, sir.
Thank you. So I would like to take this opportunity to have the conversation about theory versus practice. For a very long time, we keep having these conversations, right? Oh, that is theory, this is practice. And that's an ongoing saga. And whenever we have a conversation in an academic environment, and certain practitioners would come in and say, oh, that's all okay for theory, but in practice, we have a different challenge. So I want to have a take, and I do have an important take from my viewpoint on the theory versus practice, which is what I would like to discuss, have a put my viewpoint to the team here. So very often we do get memes, right? I mean, these are the kind of memes we tend to see. Exam in theory is different, practice is different, and theory and practice never work together. Theory and practice, you take the theory into the factory environment and things don't work out, and nobody knows why. All this kind of memes keep coming out, and a lot of discussions happen. And to a great extent, sometimes we agree wholeheartedly, and sometimes we agree reluctantly, right? And depends on which side of the story you are. This agreement problem Somewhere down the heart, I completely disagree with this. Theory and practice is different. And that's where this entire conversation from my side comes. So here I am today to give an alternative viewpoint, an alternate voice on this theory versus practice story. I personally believe theory and practice are not different. It's just that we are poor at connecting the dots. And I would like to place some examples from my experience in the industry to make my case to say theory and practice are not different. It's purely the connection of the dot which is the problem. So I would like to go through these sessions with a couple of examples. The examples may be small, but it tries to establish a point about why there is no difference. The first one I want to talk about is ANOVA, and as members in industrial and systems engineering, you would not be strange to a statistical model on ANOVA. But there is another term, GRR, gauge R&R, which is used in industry. So, of course, I don't have to speak about ANOVA to any one of you. Many of you would already know it, and if not, they would already be on your way to getting to know it. It's a statistical method for estimation of variations. But when you look at the industry part of the world, inspection errors and its causes and prevention is a big challenge. Okay. Statistical estimation of this inspection error is an important problem in industry. And on the right side, you have an image of an entire book from the international standard around measurement system analysis, and it talks about gauge R&R and its use of ANOVA. But when we look at the ground reality, so on one side, we are all taught ANOVA in our classes. We have applied in our research. We have used ANOVAs. We know the formulas. That's an academic part of the world. But when it comes to the industry, in industry, whenever an engineer joins into my team, I don't want to go wider industry also the same story. When an engineer joins into my team, we give training to the engineers on running gauge R&R analysis. And the worst part of it is we train them to enter the data into Excel sheets or some industry standard softwares like Minitab, click buttons, get reports, and say whether it's good or bad. The unfortunate situation on the ground is when we train the engineers who join our workforce, we don't talk about ANOVA, we talk about gauge R&R, and when things are taught in university, you're talking about ANOVA. We just don't connect the dot, but they are exactly the same. And the unfortunate situation with this is, oh, we need to teach the students about gauge R&R. No, actually they learned everything about gauge R&R, but just in a different name in the university. That's where my point is, that we are just not connecting the dots. If we connect the dots, I don't have to train the engineers joining the profession because they already know it. I just have to say, here's your data, complete your ANOVA and come back. And they should be able to do it. And that way we could have a different results. So that's where when engineers start recognizing that the industry tool and the academic model are one and the same, they'll start making sense out of the numbers. Now that leads to superior problem solving. It's a very simple example, but it's a serious example because a typical gauge R&R training in industry is a 2-hour training. Now, we train somebody for 2 hours, they'll go and analyze and come back with a number, but we are still not solving the problem. So, but if we don't have to train, if we just join the parameter, join the dots, we just explain to them, oh, you learned variable, here the 2 variables are human and the equipment. Can we just do the analysis? We have superior outcomes out of that conversation. So it's all about that joining the dots that I want to emphasize. This is another example, and I would say a severely expensive example, stress modeling. Now, when we type in machining stress modeling in Google, and this is results as on yesterday, for the last 5 years, 17,100 articles on machining stress modeling. That's how much research and publication happening on stress modeling. machining stress modeling to be very precise. Now, on the right side, there is an image. It's a part which I happen to have a luxury of developing in India for a high-powered jet engine. Now, each one of those parts cost about close to 8-9 lakh rupees. And when developing the part, I had the gut-wrenching effect of having scrapped 5 of them. I had to answer my bosses. It was mess. Okay. Manufacturing process-induced stress causes millions of dollars worth of scrap in high-value machine parts. This is a reality in the industry. So, but when you look at the ground reality, every mechanical engineer is learning stress analysis, right? They do modeling on modeling softwares. We do lab. We have stress strain curves that we develop. We do machining stress analysis in our laboratories. The students learn this in depth in the university. But the number of components that was stress modeled prior to machining in my last 20+ years of machining is that big 0 on the right. Now, it may sound odd, but that's a fact. I am talking about thousands of different varieties of products, probably a few thousand machining hours, 0 product that has been stress modeled. That's an unfortunate reality on the ground. But with that is the opportunity, right? The opportunity of using this concept of stress modeling in the machining environments. So once we start using it, it improves quality, it reduces scrap, and significantly reduces scrap. And the bottom left is one such example of where I was not involved. It was done. This is a part that was machined in UK. This was for Rolls-Royce, and the Advanced Manufacturing Research Center in Sheffield collaborated with them to machine this. It was completely stress modeled, analyzed, all kinds of optimizations applied. And Rolls-Royce saved millions of dollars on this turbine case machining. So that's the opportunity when we take a technology, not even technology, a thorough theoretical concept, apply into practical scenario, not give up when it is challenging, but rather persist to solve it, to make it usable. That's the kind of opportunity that exists if we do that. I want to take up another interesting subject on another interesting example here. So production planning and control. None of us would be new to production planning and control. As systems engineering, I loved this subject. I studied through it, complete passion, right? Having said that, I go into the factories, not just my factories, not just the factories which I was accountable for the supply chain, right? And I work with extensive supply chains across the Asia Pacific region. The first meeting in the morning is production meeting, and there is 0 production meeting that goes out without an argument about inventory. We always have a situation where either we are having excess inventory or we are having shortage of parts. This is every day. It's not, if not every shift, challenge in industry. So what's happening here? We study so much. We have so many models. So in ground reality, students learn lots of inventory models, right? So we do complex calculations. We do the economic batch quantity, the ordering frequencies. We do so much of it, and all of it is perfectly valid. But as soon as an engineer comes into an industry, the unfortunate reality is production engineers are using Excel sheets to manage orders. So there's one random on the right side. Your part numbers, when you're ordering, what's your stock. In some cases, they go for ERPs. Now, when ERP gets complicated, they take a download of ERP and start using Excel. Okay. Now, it may sound odd, but that's a fact. Now, the data that is used for setting this table is questionable. I had an interesting question that came through about a week back. Oh, we need to do some testing around here. what is the quantity you want to produce? And somebody picks up and says, let's make 3. It's like, why 3? Just like that. So people come up with numbers without applying the theoretical concepts that has been learned, taught, and validated in the academic environment. That leads to suboptimal results. So the challenge or the opportunity of connecting the dot here is, if engineers start applying models, validating the gaps, questioning the assumptions, right? Now, I have a favorite one on questioning the assumptions. So cycle time. We all validate cycle times. We do modeling on cycle time. We do arena modeling. Now, when you go to the industry, we go and ask them, oh, and this happened to me. I just want to give a practical example of what happened. So we had a part which we were always late to plan in delivering to customers. So I asked my production head, saying, what is your lead time to make the part? So he said, I need 45 days to make this part, start to end. That's okay. That's your average. What's your standard deviation on that? He just looked at me blank, and because on an average we take 45 days. That was great answer. What is the standard deviation? He was like, not sure what you mean. I said, okay, let's go and calculate. So we calculated back and said, every part we ever made before on that particular part number, 45 days, he was absolutely right. It takes about 45 days. It was like 46 days or something. Is the average lead time to make the part. Great. The standard deviation was about 10 days. So I asked him, okay, standard deviation is 10 days, 45 days to make the part. When are you launching the part? Oh, we launch 45 days before the delivery. Funny enough, essentially he has set himself not to deliver on time, only 50% to deliver on time, because 50% of the parts took less than 45, 50% of the parts took more than 45 days. So he set himself up for a 50% failure just by the way he did the planning, right? So ideally, if you want 100%, you would say average plus 3 standard deviation. That's where you set your launch. But why is it 45 days? Can we apply lean techniques to reduce it? That's the second question. But it's purely how we fail to even use something as simple as a standard deviation in the industry to improve our performances. Now, the irony here is, in today's e-commerce, shipment starts before even order the part. Forget ordering the part. You start browsing for something, the companies start moving the part stock to the nearest warehouse. But in such a advanced age, in conventional industry, production planners are arguing about, why did we not place the order on time? That's the argument that keeps happening day in and day out in the shop floor. So my case here is, academic theories and models have the solution. They have the solution. Are we willing to connect the dots is the challenge that we face. Now, while I'm telling the story, I'm just saying, okay, right, this is all very basic stuff. Where does the research scholars fit in? Where does deep research fit in? Right? So I want to go back to something which Professor Mohanty said just when I was joining and he was speaking, and his words caught my attention. He mentioned about all the low-hanging fruits are gone. We need to go deeper into challenging problems, and challenging is lonely. Now, and he also spoke about the integrated research. So the question is, where does this research fit within the the industrial problem solving, right? On the left side, you have a typical, what we call the problem solving pyramid. So if you have a problem, just ask, oh, is it a simple problem? Just do it, JDI, just do it, solve it. Sometimes we have a problem, we know the solution, we just have to go implement it, rapid problem solving. Sometimes we have a little more structured tools like A3 problem solving. And when we have a bigger issue, we try to use Six Sigma problem solving. Some companies have slightly more elevated processes where they have their own defined processes. But the point we are missing here is, above that Six Sigma, there is an opportunity to solve problems with research, right? It has a potential to create this innovative tools for industry The low-hanging fruits are gone on the left side, but you have the opportunity to create some deeper tools and solutions for us. Now, he also spoke about the integrated research, and that's the challenge, because what is it that the research scholars, the researchers can bring to the industry? The industry doesn't know, right? Now, having said that, there are few organizations, few large organizations who have benefited immensely from having researchers on board and research mindset within the organization. I want to give an example of GE. GE has a lot of researchers in their organization. So here in Bangalore, GE has a research group who solves problems. So they go around solving problems for GE factories. And when they do have an innovative tool to solve the problem, they take that tool and they commercialize it. So there's a group who commercializes it and tries to sell it to the other customers, right? And it makes a difference. So the kind of problems that research group in GE solves is beyond Six Sigma. I mean, we don't have to teach Six Sigma to GE. They pretty much made it the tool of choice. But then research is adding that layer. So if GE was happy with Six Sigma, they did not have a research group. So there is a big opportunity in companies like GE has realized it. I also showed the example of Rolls-Royce machining, right? And that was just machining. And that group has people who are PhDs in technologies related technologies. So industry is kind of ingesting and integrating researchers into their fold, and it's happening larger than we think. I want to even give an example that when I worked in my previous company in Rolls-Royce, the director of manufacturing engineering, the head of manufacturing engineering, my chief of manufacturing engineering, all three of them were PhDs. And I went to them and asked them, saying, to grow to your role in Rolls-Royce, do I need to have a PhD? And their answer was, and this is, I'm going to quote a person called Mike Percival, who was the director for manufacturing engineering at that time. He said, Arvind, a PhD is a way of life. It gives you a way of thinking. And that thinking is what gets you to the higher levels. That it's not the actual PhD itself, it's that way of life, the thinking, the mindset. So the reason I'm mentioning this is, while research scholars see conventional route of going into teaching, which is important, and I'll come to that, industry needs you. And we have some challenges, why it is not very familiar. We'll talk about it later, but industry needs you. On the other hand, I also want to kind of make a call for action with the research community to teach the students. We need you to teach the kind of things that we discussed. You teach the right things. We need you to help the students connect the dots. And we have some challenges around it. We'll discuss it. Now, as I said, academic versus industry. So where is the disconnect? So what's the disconnect? How can we address it? So let me go ahead with what I believe is some of the disconnects. And I think I have a confidence in saying this because in every place that I worked previously, I have managed to have significantly better industry academia interfaces because I was able to do some of this or mitigate some of these risks. So first one, industry leaders may not know the opportunity. I think it's very clear. Leaders don't know it all, because of which the tapping of the academic potential, the research potential for the industrial problem solving is quite limited. So that's one challenge where there is a disconnect. The second one is an interesting one. I'm using the word, we speak different languages. So the academicians and industry, unfortunately, we speak different languages. Okay, so what do I mean by that? It's the first example that I gave. You'll speak ANOVA, I'll speak Gejaranda. And as long as we don't connect it, we are going to keep speaking different languages. That's a challenge that we need to find and or that's a disconnect that we need to kind of find a way to remove, and we'll see how we could do that. The other one on the bottom left, failing. For all that lecture that industry gives, industry members in industry, the leaders, the managers who engage with academics in industry, they are having a fear of failure to try new things. That's the reality. People are afraid of trying new things, particularly because of failure. And the reason is simple. Failure can be seen as career limiting in industry. Not all organizations, but many organizations today who encourage people to fail fast. But still, we have a huge conventional industry where failure can be career limiting. So that's one challenge where, as an organization, industry has to get away from the fear of failure. Encourage people more and more to try and fail rather than not try. That would open up opportunities for better use of the research opportunities in industry. Another one is an important one, short-term versus long-term. So investing the time and effort for the long-term versus the short-term, day-to-day firefighting that industry is on. It's a real challenge. And so if you have a researcher who wants to do a trial on a machine and it's 26th of March, forget getting it, because by 31st of March, whatever we bill is annual revenue. So there is this short-term and long-term challenge. While academics need to understand the short-term challenges of the business and try to work around, industry needs to recognize the long-term benefit and try and invest it. We need to treat this as investment, not as an expenditure. So that's a challenge. Another one is ineffective internship, and this is one of my favorites. And the reason I say favorites is when an intern walks into the factory, for industry, I have heard managers say, "Oh, we now have an intern. We'll get him to do this. We'll get him to do that." Managers in industry think interns are free labor. Wrong, big time. And it's for the leadership in the business to stop that from happening. It's not the students, it's not academics, it's for the industry leaders to stop it. On the other hand, when the challenges, the students do come in for internship, there's a level of engagement, there is a level of connection, and there's a level of conversational language, influencing skills, which could really help in that transformation. So as industry, as academics, we need to transform the way internships are run for industry to better benefit from academia on research. And the last one is important for me. I call this the lack of people who make the connections, right? So not trying to pat my own back, I have a reasonable ability to speak both the languages. Now that helps because that means that we introduced AI in the factory. Because if the AI guy was speaking to my CEO, he would have looked at it and said, what the hell is happening? But since I was able to translate the benefits between the researcher and the business leader, we were able to make business cases. We were able to go ahead and run the business or run the project. And we were successful in that. We were first failing and then we were successful. So we need more people who can make that connection between academia and industry. So what is the way forward? So we saw the problems, we saw the challenges. What's the way forward? Do we have a way forward? We do. We need more and more researchers embedded within industry. This improves the opportunity identification because when researchers are within industry, they find opportunities to solve the problems, which industry is still only thinking maybe at that Six Sigma level or Six Sigma tools. We can say, oh, hold on a minute, we can bring in the research tools. There is opportunity here to solve it better. So we need that embedded researchers in industry. It's a step to be taken by industry and researchers. Now, of course, there's going to be a natural drift. So new age organizations, right? So we were having a conversation about e-commerce organizations moving inventory long before anybody decides to even place an order. Okay, that success will naturally drift established industries. Some fast, some are early movers, some will be late movers, but eventually people will drift towards more academic collaboration because they see that that would become a competitive disadvantage if they don't do it. So that will be market forces that will drive. The last one is there's big opportunity in having industrial experienced collaborators with research interest embedded in academic institutions. Now, so just like the first point where we need researchers within industry, we would benefit having industrial personnel with a bit of a research inclination embedded in the academic institutions, because that also helps improve opportunity identifications, communication. So these are some of the way forwards. So I would like to close my words with Leonardo da Vinci's words. Practice without theory is like a sailor without getting in a ship without a rudder. So and never knows where he may cast. So with this, I would like to make a strong case for all of you that academics, theory, research, they are extremely important for industry. We have some disconnects. Not all industries, some industries. We have opportunities to bridge it and mutually benefit significantly. With that, I would like to stop. Thank you for the opportunity, and any questions, I'm open for it.
We can now take questions from the audience.
Anybody having any question? No.
I'll ask through the Teams window.
Okay. Yeah, I think I'm not sure if I can see chat window. I don't think I am enabled on the chat because of maybe an external to the Teams environment.
So are we audible from this end?
Yes, very clear.
Okay. So my question is, when we solve theoretical concepts or derive some formulas, we make certain assumptions.
Mm-hmm.
So how to relax those assumptions when we are dealing with practical problems?
Okay. So the challenge would be always the validity of that assumption. It increases the complexity. But I want to bring in something which is very basic back, Pareto principle. So when you are making assumptions, the vital few and trivial many, there is too much noise in the industry, but there are only vital few that really matters, where assumptions will be, your models would be sensitive to that assumptions. So where the variables are sensitive to your assumptions, let us find ways to control. So, and when I say control, industry relies on control, right? Be it you see the terms that industry has: statistical process control, quality control. You name it. We like the word control. We are control freaks in industry. Okay, so if you have certain assumptions, then understanding those assumptions and placing controls on that assumptions so that the assumptions stay in a band is a way to work that solution. But unfortunately, if we don't know what your assumption is and how sensitive your model is to the assumption, we can't implement that control. So my take would always be, when you have an assumption, ask, what is your control plan for that assumption? How are we going to control? What is the band in which you want to control it? And industry likes to go and control it, to be frank. We are control freaks, as I mentioned. Hope that helps.
Yes, sir. So, but then there stays a certain gap in the decisions, which like human are the ultimate decision makers. So we'll have certain skill set to make such decisions, including those gaps.
Yep. That's perfectly fair. And I want to bring up an example, right? So something very, very small. For those of you, I'm not sure if the statistical quality control, multivariate quality control classes still run, but you have SPC, all right? So you have one variable. It could be just power consumption on the machine. So if power consumption peaks, tool is worn out. Okay. Yes, you're right. There is a human element that the person has to change the tool. But we have control chart. We have instructions to the operator to change the tool when he sees an alarm or when he sees a red point, right? So once we understand the need for the controls, we tend to create processes to put that control in place. So it's not going to be about people. So industry is not about people making decisions. Industry is about processes making decision and people establishing those processes. So I want to repeat that, because in industry, we say people make decisions. No, that is not. That is the enduring aim of industry is not to make people make decision, but processes should make decision. So people follow the process makes the decision. That's what industry wants to do. It may be happening 60-70% of the time, some very successful industries 80-90% of the time. So once we know your sensitive parameter that you have made an assumption to control, industry will work into your procedures and processes, train people to weave that control in. The challenge is, if we don't do that, then your model fails. But it's not your model who failed, it's the control that failed.
All right, thank you, sir.
Okay.
So, hello, Ravindan, this is Sri Krishna.
Hello, hi Krishna.
Yeah, just one question from my side. It's like, as an academician, I know what are the drawbacks from our side to convince any industry to go for any change for the process or the technology. But as an industry person, can you tell me that why industries in India especially are lacking to adopt new things, forget about the new technology, but well-known things just cannot fit for them, but still they are not willing to accept that one, maybe because of fear or...
Okay, I want to take that in with a bit of a structure of the industry, right? So it's a multifaceted challenge. So first, let me come with this type of industries. So if I can break up into large Indian industries, MNCs in India, and small scale and medium scale enterprises. So I'll put it in 3 buckets. So each one has a different reason for not doing that interface better. Okay. So if you go to the large industries, the slide that we had, which is on the challenges, you're talking about leaders may not know, right? So I had multiple challenges I had listed. I don't know. Leaders may not know. In large Indian industry. So let me say, if I go for a public sector company, and there's not a disrespect to people, it's just the situation that I have seen in general. So the top man in that industry graduated 55 years back. So 35 years back, and he has not been interfacing. Not many of them interface with academics frequently. The challenge would be he won't be able to appreciate the need for integration or what new has come in. A very small example I want to give: cutting tool technology. Anybody who had studied cutting tools, drill bit, point angles, I'm talking 20 years back, would say, what is the point angle of a drill bit? 118 to 120 degrees. You wake me from sleep, I used to tell that, right? But today, if you go to any of these cutting tool manufacturers, you would find that the standard cutting to drill bit point angle is 140 degrees. So you go to any of these manufacturers, Sandvik, Comet, Seco, any one of them, the standard cutting tool drill bit point angle is 140 degrees. I would bet my salary on, if you go for a survey for anybody who completed their graduation 15 years back or even 10 years back, and ask them what is the point angle of a drill bit, they'll say 118 to 120 degrees. So while the latest cutting edge research on cutting tool changed, the mindset of the industry didn't change because we were not connected to the root. That's the challenge with large Indian industries. When we go for as MNCs, the unfortunate reality is we tend to look for everything with West. So, the hub is in UK. They are working on this research project. We'll wait until they've given us the solution. There is a general mindset of the Indian part of the business looking up to the Western business, unless they have been in existence for a very long time. GE is one of them. They have been in existence in India for over 25 years. They have their own research groups in India, but it's not the case with companies where that long presence in India has not been there. Small and medium scale enterprises, it's that bushfire, day to day, short term versus long term. So each industry has a different challenge. So when we approach for solution, we need to look at their challenge, not solution. When we approach with an opportunity, we need to address their challenge with the opportunity. Then we have a better chance of success. That would be my key take.
Thank you. Thank you very much.
So any more question?
Am I audible?
Very faintly, give it a try.
Okay, I'll come to my question is regarding the disconnect that you talked about between the academia and the industry. So my question is regarding the access to data. Now, we here, when we are trying to develop models, whether statistical models or machine learning models, we have a difficulty in getting real-time industry data, which industry is reluctant to give for obvious reasons we do understand. But if we do not get the data and we make a model, then that model testing, validation is definitely going to be a challenge. And so that model may not be acceptable to the industry. It may not even be solving an industry problem. So how do we reconcile this? I understand industry is reluctant to give data. On the other hand, we cannot develop a model which suits and solves industry problems without getting data. So how do you propose we solve this?
Fantastic. I'm going to, if my suggestions sound silly, I'm really sorry. But we all have had census people coming in and taking census with us in our family, right? So we all know the importance of census. The entire story is known. We are all aware of it. But how many of us give the actual earnings data to census? We don't. Reality, we don't. And the reason we don't, we have our own reasons. We don't want government to snoop us on tax, or we don't want to, demonstrate that this is what I earn to the world, whatever. So on the other hand, when somebody goes on, I'm not sure how many of you have seen the website called glassdoor.com. Okay, so glassdoor.com is a website where you can go in, you can look at what is the industry salary trends. Okay, now the only take here is you can look at industry salary trends provided you submit the details of your salary, albeit anonymously. And I can bet you 80-90% of the people would key in their salary anonymously, give in their data, collect their information back. It's a give and take. So we see something, by giving away something, we get something back. That's it. And we hesitate sharing information in census, but we don't hesitate sharing information on Facebook. So what I'm trying to bring here is the power of familiarity and the power of getting something in return to what I give. And lastly, becoming the power of not distinguishing or becoming part of it. So I'll call it the change management. So Facebook is today part of your world. LinkedIn is today part of your world. You don't see it as something very fishy or anything. It has woven itself into your world, which means that you're more comfortable exchanging the data. When I was talking about embedded researchers in the organization, when I was talking about embedded industrial people in the academic institution, that's the first step, or that would be the steps towards that data sharing, transparent data sharing. Because if let's be frank, if IIT Kharagpur sends in one person for collecting data from me, I'll be skeptical. But if I have a researcher from IIT Kharagpur who is employed in my organization, who is thinking of that way, I would happily share every data, because we have all the covers, NDAs, and more importantly, it's a feeling of comfort. Okay, we need to make industry comfortable to part with their data, addressing their concerns. It's not easy, but that's one. The second one is, have you ever thought whether industry actually have the data, or what is it going to take for them to dig the data out? Okay, something as simple as if somebody is asking, let us say, image recognition for defects. If you ask me image data of all the defects that has happened in the factory, I know I would have scrapped 5,000 pieces for defects that is visual, but I may not have a single photograph. I have to collect data. It's going to put time and effort in. So the challenges have to be individually addressed, make it more comfortable for people to share, and people will start sharing. And more equally important is, I think, with the world of IoTs and the technology moving, you will see lower and lower challenges on that, because data retrieval is going to become easier. Help them make it easy. They will come to you. It's not going to be an easy challenge. This is standard. The last one is, ask yourself, do you really need so much data? And the reason I'm asking is, image recognition, machine learning model. I spoke to one person. He said he needs minimum 300 pieces data. Okay. I went to another company in, actually we were dealing with a company in Japan and one in California. They said, give me 10 images and I'll get you the result. So, and I'm looking at it saying, somebody is giving me 200, somebody is asking me for 10 images. What is the reality? But probably because the guy with the 10 images has already done some pre-learning on the models or something like that. So transfer learning, transfer use of data, making it comfortable, embedded people. This would be the ways where I would try to solve the problem. It's challenging. I don't deny that. But think of it like census versus Facebook. I think that's what I will keep saying whenever you are looking for data. Census versus Facebook. What is Facebook getting right and census getting wrong?
Next question. You can post your queries on the chat box. I hope our speaker will respond later.
So actually, I don't have access to the chat box. Looks like it's a Teams stuff. But if people can post and somebody can read it out also, it would help.
Thank you so much, sir, for your enlightening speech. The key points discussed were very insightful. The slides on connecting dots between theory and reality practice, problem-solving pyramid, can make recognizable improvisation to country. So I believe that our audience will definitely be benefited by it. Thank you again, sir. Now I request Professor Sri Krishna, sir, ISC faculty advisor, to propose a vote of thanks to our keynote speaker.
Thank you.
Thank you, Gaurav. Thank you, Aravindan, Mr. Aravindan. When a research scholar came to me and asked me about they are looking for a keynote speaker, then the first name came into mind was yours, and I called you. And thank you that without a pause, you agreed to address this one. Unfortunately, we had this session online, but next time we will try to meet physically so that we will be benefited from there. All those presentation which you talked about connecting the dots between academic and industry. I hope our research scholar will be benefited from it, from this one. Especially to all the research scholar, the two things are very important: visibility and focus. The focus on which you are working, and visibility to look around what is happening, what all things can also be included, not during your PhD, but beyond that one. Because once you have done your PhD, you have set a different kind of thinking skill in your habit, and that will continue till till you work or till you die. One more interesting thing I want to talk about, Mr. Ravindan, is that all explicit information is available on LinkedIn, but he is such a kind of person who does not look for an opportunity, but rather he creates an opportunity. So that is what I was very impressed from him. Last time when we met in UK, he told me that he's still carrying his PPIC notes, and most of the work, and especially inventory related problems which is coming in the Rolls Royce, he's just tweaking some of those concepts and being able to solve that one. So thank you, Aravindan, once again. So we'll meet maybe next year someday. Thank you.
Thank you. It's my pleasure.
Thank you, Krishna sir. So, thank you, sir.
Thank you.
Now moving to our next event. It's time for oral paper presentation and poster presentation. Both will be conducted parallelly. The students who are presenting their posters kindly move towards your respective posters. And I would also request the judges of panel 1, Professor Saik Rai Chaudhary sir and Professor Jacob sir, and panel 2, Professor Abhishek Sharma sir and Professor Menon sir, for poster presentation evaluation. So please kindly proceed to corridor for poster evaluation. And for oral paper presentation, I request all the participants of panel 1 to be ready. We will start presentation slot for panel 1. I request jury of panel 1, Professor Akhilesh Kumar sir and Professor Gautam Sen sir, to come for evaluation. All the participants will be given 8 minutes for their presentation and 2 minutes for question answer session.
show the hand, like 1 minute left. 2 minutes. So, thank you, Gaurav. Today I'm going to present my topic, optimal dynamic pricing and preservation technology investment for a centralized supply chain considering carbon emission. I'm Anand Rangan and working under the supervision of Professor J.K. Shankar. So the contents of my presentation are introduction. I will discuss introduction, literature review, model formulation, results and analysis, and conclusion. So coming on to the introduction of dynamic pricing. Dynamic pricing is determining optimal selling prices of products or services in an environment where prices can easily and frequently be adjusted. Some of the application of dynamic pricing are in the field of transportation, event ticketing, energy sector, and perishable products. So we will discuss more about perishable products industry here. So perishable products undergo deterioration. So as per V 1997, deterioration is decreased usefulness of product due to decay, obsolescence, and loss of utility. Deterioration can be decelerated also because deterioration is ultimately causing losses. So as per Dye and Young 2016, deterioration is an inexorable phenomenon but might be decelerated by the use of specialized equipments or processes. But these equipments or processes has drawbacks also. So like a Global Responsibility Report 2018, they say that at Walmart, 30 to 40% of the total energy consumption comes from refrigeration and air cooling equipments, and thus they contribute highest to the carbon emission. There are benefits from dynamic pricing also. Like in this example, we can see that if we will price rightly in the ripening bananas, then we can have higher revenues by setting the price at the right time. This is a study and that says that using dynamic pricing, we can reduce the wastage by 39%. We can increase the net margin by 1.2%, and the revenue can be increased by 110%. So these are the literature review on dynamic pricing. So here we can see that very few works have been done in preservation technology investment, and in inventory models, carbon emission factor has not been considered by anyone. While we come on to the literature review on dynamic pricing in supply chain models, we can see that here the demand is basically selling price and reference price dependent. The deterioration is either fixed, like they have a fixed lifetime. There is quantity deterioration or quality deterioration. Some of the authors like Dye and Young and Chen et al. Have considered preservation technology investment, but carbon emission is missing. So based on these literature gaps, we have found the following research gaps: that no dynamic pricing model considered carbon emission due to preservation technology investment and production for a deteriorating product. Also, no supply chain model exists with dynamic pricing for deteriorating products having price, freshness, and stock sensitive demand. So based on that, we have formalized our objective as to derive optimal dynamic pricing strategies for a perishable product with preservation technology investment and carbon emission considering price, quality, and stock dependent demand in a supply chain. The key issues in the literature are as classified as this diagram. Like the dynamic pricing can be of for products or services. In products, based on the deterioration, we can have perishable and non-perishable products. In the implementation sector, that can be implemented for inventory management and supply chain. And in environmental consideration, they might consider the carbon emission generated, or they may not consider the carbon emission generated. So based on that, we have formulated the model as we consider a two-echelon supply chain comprising of one manufacturer and a retailer dealing with a single deteriorating product over an infinite number of periods. There is a maximum shelf life of the product, after which it cannot be repaired or replaced. At the end of the cycle, the remaining inventory is going to be salvaged, and both retailer and manufacturer's inventory deteriorate at a constant rate, and both of them invest in preservation technology investment to reduce the deterioration rate.
So in the centralized supply chain model, the profit function is we consider is nothing but the sum of the retailer's profit and manufacturer's profit. So let PIC denotes the discounted total profit of the centralized supply chain. Then our objective is to maximize the total discounted supply chain profit, which are subject to these constraints. Where the first constraint is the constraint on maximum available sales price. Second is on the constraint on retail price. Third is on the cycle time, and fourth is the non-negativity constraint. So, given the provided these data, we have found the optimal long-term equilibrium results as summarized in table 1. Coming on to the resultant analysis, we see that that in this figure that convergence of retail price and reference price is there. Like with the increase in the number of periods, the retail price and reference price converges to a long-term equilibrium value. Similarly, in this figure, we see that the total discounted supply chain profit function with and without preservation technology investment. So here the red marker is for supply chain function that is without preservation technology investment, and the black one is the with preservation technology investment. So we can see that with preservation technology investment, we can improve our profits. In this figure, we can see the changes in the optimal preservation technology investment with respect to the change in deterioration rate and preservation technology efficiency. Like theta is the deterioration rate. So with an increase in the deterioration rate, we can see that the preservation technology investment is increasing. Whereas we can see that if the gamma, that is the efficiency of preservation technology, if that is increasing, then the preservation technology investment cost is going to be decreased. Coming on to the sensitivity analysis, we can see that with respect to the demand scale parameter, that how much demand we can generate. So the higher the demand scale parameter, the profit manufacturer and profit retailer both are increasing. Now coming on to the demand sensitivity of current inventory level. So more number of products there are on the inventory, then or that is available on the stock, more customers will be coming to buy the product, and so the profit retailer is increasing, whereas profit manufacturer is also increasing, but it's not increasing up to that extent. Third is the demand sensitivity to retail price. So if the demand is much sensitive to the price, then we can say that the profit of both manufacturer and retailer is decreasing. Similarly, unit carbon emission in warehousing. So if there are more carbon emission, then both manufacturer and retailer's profit will decrease. So coming on to the conclusion, we find that a slower degradation rate in freshness leads to a lower salvage quantity and requires a longer cycle time to achieve higher profits. We have a higher demand sensitivity to price leads to a lower or zero end of inventory level and vice versa. And the last one is that for a higher initial reference price, a high initial retail price can capture maximum benefits from sales. However, if that is not possible, a retailer can start with a lower retail price and increase it in a span of time till product generates its space in the market. These are the references. Thank you.
Can you go to your first slide, introduction? Okay, so you say perishable product. Ideally, the idea of dynamic pricing actually came from pricing and revenue management.
Yes.
To start from the American Airlines study. Why you are keeping transportation, even keeping energy sector outside perishable? Once the flight has taken off, the seat becomes perishable.
Yes, sir. So basically, we are considering focusing on the products that are deteriorating. So those who are whose value is
that I have understood. But the moment if you look it from dynamic perspective, pricing perspective, the whole idea works because it is perishable. Like movie tickets. If someone does not occupy that seat, it's perished, right? So I don't know if this representation is right. Otherwise, you have to put, deteriorating products or something like that. Okay, first thing. Second thing, go to your formulation. Okay, so where exactly you have taken the carbon thing?
So carbon is in the cost, the cost structure that function, the profit function is in there. We have considered.
So one thing, whenever you are presenting something like this, you should make a small box on the top showing what are these PI, QI, PI, PI. Otherwise it is difficult to understand. I cannot see carbon here. That's why I was concerned. Where is carbon? You have emphasized so much on carbon.
Yes.
So where is carbon?
So it is in the profit function that we have considered that the amount of inventory.
Suppose if I remove the carbon term and do this analysis, what happens?
So the we will not consider the cost that is going to be generated from the preservation technology investment, the carbon emission that is going to be generated from the preservation technology.
So have you done this analysis? Suppose
Yes,
I
sir.
do not do any carbon.
Yes, sir. It is present in that figure.
Okay. Third thing, you have not talked about your objective function. Is it convex, concave, what it is?
So it is a concave function.
So, okay. If I look at that, if you go to the next slide, I would expect some non-linearity somewhere. So I would like you to look at it. I would expect some non-linearity because your profit function is a not linear, I believe. It is a non-linear function. So I'm not sure because I have not heard in look at it, but at least look at it. Can you tell me why everything is linear?
So these are the parameters, like how if we are varying the parameters, how the our profit is going to be.
So all of them are linear.
So on parameters they are linear.
That means it is not constrained enough. Maybe so you need to look at that.
Okay, sir.
Okay, that's it.
Okay, so can you go to your problem definition where you are talking about the gaps in the literature? Yes, yes. So here you are saying basically you are considering some this carbon emission, right? And this price freshness stuff which are not considered earlier in the literature. Now, see, there can be two things. One is that maybe with respect to these perishable products, you know, they may not be that much relevant first of all. Okay. Or second thing, they, you know, because of the complexity issues, they might not have considered. So what is the case?
Actually, the case is that in dynamic pricing literature, so most of the works have been done in perishable industry, but perishable industry can also be classified into deteriorating product and non-deteriorating product. For example, if we consider the seats on a flight, so the value of the seats on the flight is not going to be decreased in the whole cycle, its cycle time. But if we consider that we are pricing a banana or a fruit, then its value is also decreasing with respect to time. So the second portion, that fruit and food sector, we have considered that thing. So based on that, we have that because we have price, freshness, and stock is there. So those things we have considered. So in that field, very few literature is there, and we are working on that.
Okay, I see. And going to your object, how did you formulate your objective function? Where did you get it? Because you're saying it is concave, but who gave you this objective? What is the basis? This objective function, although you have not properly written the objective function, right?
Yes, sir.
So what kind of function it is, and what is the mathematical basis of choosing that function?
So mathematical basis that we have summed up all the functions, we have summed up the different costs that is coming into that, like preservation technology cost, carbon emission cost, and the inventory handling cost, holding cost. All the costs we have summed up, and then we have sales revenue, and based on that we have formulated our retailer's profit function. Then again we have formulated similarly our manufacturer's profit function. And then we have considered a centralized supply chain, and then the sum of those two we have considered as the sum of the that is a centralized supply chain. It's complete centralization.
And what is the meaning of this overall cost function being concave? Can you, you know, in the context of your problem,
yes,
right? Your cost function is coming out to be concave. So what is the meaning?
So the Hessian matrix that is with respect to the TI, QI, PI in values are the variables. That Hessian matrix is a negative semi-definite. So
no, not mathematical. You know, the physical interpretation. So that when your objective function is concave with respect to your problem. So what is the physical or economic interpretation?
Like economic interpretation is basically we are talking about price. So if the function is concave in price, then we can see that that this price is the optimal price where our profit is maximum. If the function is if we are just considering price, and at this price the profit is maximum. So in that period we are going to keep that this is the optimal price we are having. Then for the next period we can have similarly we can have the optimal preservation technology investment. That concave function is there. We have a tip that at that point our the maximum is going to be that.
And going to your results, you know, sensitivity analysis. So just you know, the last slide. Okay. these insights that you are presenting here. No, the last one, yes, it's conclusion. Yes, conclusion. Now, if you do not do those analysis, all this formulation, results, and all these things, what is there which is not common or obvious?
So, like, if we start from the end, that this initial reference price thing, the initial reference price thing is not available in data rating product in literature. Like, initial reference price is basically what customers think that price has to be of the product. So if we can set that, we can set the initial reference price before the selling of the product. So if we can say that if the initial reference price is high, then a high initial retail price can capture maximum benefits from the sale. We can increase the cost of that product. Similarly, if that is not possible and the initial reference price is low, then we have to increase it in a span of time by decreasing it in the first time.
But you see, I mean, you are trying to say that this is not a common sense.
Yeah.
That if your initial reference price is high, then the conclusion that you are getting, you cannot tell it from common sense. Because I was expecting that in your conclusion section you should present something that is not, that you have found, new discovery.
Yes,
In terms of some quantitative way, right?
Actually, the presentation time was not
okay. Fine. Okay. Thank you.
Thank you.
आपको फोकस पे रहना है, ठीक है?
So good afternoon, sir. I'm presenting my seminar on preemptive scheduling of unrelated parallel machine to determine the max spend with optimal WIP buffer. So the overview of this presentation is introduction, methodology, result, conclusion, future scope, and references. So introducing scheduling problem. Scheduling is basically assigning and sequencing the jobs in different machines on a given period of time. So scheduling problem is classified as multi-factory and single-factory. Further, it's classified as single-agent and multi-agent, and then single machine, parallel machine, flow shop, job shop, and open shop. So actually, we are focusing on the parallel machine scheduling. So the parallel machine scheduling. The parallel machine scheduling is further classified as identical parallel machine, uniform, and unrelated. So unrelated parallel machine is most complex than the uniform and identical. So we are focusing on unrelated parallel machine. If you build a model on unrelated, it can be easily converted into identical and uniform. So now, what is unrelated parallel machine scheduling? Why we choose that one? In real life manufacturing world, the unrelated parallel machine scheduling is more important because the workstation and the multiple machines with different speed for different jobs. Also, unrelated parallel machine can be generalized into identical and uniform parallel machines. The sequence dependent setup time, resource ability, and release date of machine eligibility parameters are there, which we can, which are the factors that unrelated parallel machine can consider to make it more realistic, and it merges with the batch processing problem to make the parallel machine scheduling problem as a more industrial, point of view. And then it's said that the resource constraint parallel machine scheduling problem is complex than the simple parallel machine scheduling problem. So we are considering the buffer inventory problem. So WIP buffer is a special kind of inventory buffer cited by Gonzalez et al. Then buffer allocation problem is the combinatorial NP hard problem. So now we optimize the process WIP, minimize the buffer inventory, and the position of the buffer in the entire scheduling problem is the important factor. So we try to optimize the buffer inventory with respective of their position. So these are the motivation behind our problem. Now going towards the problem, this is our process flow diagram where we have different kind of buffer before the workstation, and there is multiple number of multiple number of machines in each of the workstation. So based on this, we formulate that what are the buffers required before each of the workstation. So this is the mathematical formation and the state indices and the parameters. So going to the parameters directly, alpha and beta are the penalty for the earliness and tardiness of the job, and then WK is the weight for the buffer, at workstation, we are giving priority to the workstation, that whether it should be the buffer amount should be more at which point of time, and then PIK is the processing time, the MK is the number of parallel machine in the each of the workstation, the MCK is the machine eligibility parameter, NIK is the preemption constraint, and EI and TI is the earliness and tardiness of the job. So the SIK is the starting time, CI is the completion time, and EI and TI is the earliness and tardiness of the job, and these are the binary variables. So going to the formulation, we form. So this is the weighted buffer WIP factor. Then this is the tardiness and earliness penalty. This is the preemption penalty. This is the holding cost. So going to the constraint. This is the either produced from the machine or we take it from the buffer. Then second one is the earliness constraint. Third one is tardiness constraint. Fourth one is either that should be fourth one is that each of the machines should produce one of the jobs. Then fifth one is the parallel machine constraint. Sixth one is the completion time constraint. Then second one is the starting time constraint. Since it is a preemption constraint, so second one is consider multi of the factors, and third one is the batch constraint. So these are the non-negativity constraint. These are the machine constraint and then non-negativity constraint. So going to the heuristic method applied, it will solved by the both exact method and heuristic method. So remaining available processing time. Then second one is the remaining processing time, and third one is the remaining slack. So based on this, a decisive ratio is calculated, and then the jobs are arranged on the descending order of the decisive ratios. So the result are this. This is the completion time of the respective job, and this is the buffer location. The job 1 buffer is on the 5th operation. Job 2 buffer will be needed on the 4th operation. No buffer for the job 3. Job 4 buffer will be required on the 2nd and 4th operation, and job 5th buffer will be required on the 5th operation. So this is the difference of the comparison of heuristic and exact method, difference in the time for the comparison of heuristic and exact method, where we have taken the number of job of 5, 10 and 15 instances. So concluding our presentation, current research evolved that MILP and heuristic method solves the preemptive unrelated parameters scheduling with WIP buffer. We have taken the machine eligibility constraint, due date and earliness and tardiness penalty. Proposed MILP model can solve small set of data in reasonable time. So we used heuristic method to solving a large set of data, and because it will become computational algorithm, we are using heuristic method. The result is utilized for the parallel machine scheduling problem in the identical case or uniform case also, and then the future further it can be expanded to stochastic processing time to make it more realistic and industrial approach. So these are the references, and I conclude my presentation by saying that the key is not to the priority what's on your schedule, but to schedule your priorities by stepping COVID. Thank you.
Abhishek, I understand that you have been reading or analyzing, but your slides you can see. If you have a very small time, do not use animation. It is for everyone. Because animation takes time. So if you have very small time presentation, try to avoid animation. That is one thing. Now, if you can go to your formulation. So, is your formulation MILP?
Yes, sir.
Because I can see there is mod, there is XIK into SIK. I believe SIK is also a decision variable.
Which one, sir?
The last one.
Yeah. The last two, SIK is the starting time.
So that is a decision variable.
Yes, sir.
XIK
No, yeah, that is a decision variable.
They are being multiplied, so it becomes binary. Quadratic. Although it is multiplied with the binary. So have you done anything to linearize all this?
Yeah, actually, I have linearized this model to by some constraints.
Maybe present, maybe in future also when we have more time to prepare. At least talk about those.
Yes, sir.
So that is kind of a contribution you are making. Now coming to heuristic, which heuristic you have used among RAT, RST? This is why you should not use.
Yeah, yes, sir. So actually, I have used RAT, then RPT, then calculate the of RAT and RPT to make RS. Then we sum RPT and RS and find the decisive ratio. And then after getting the decisive ratio, I arrange this all the data of
Now come to the comparison.
Yes, sir. Okay, sir.
Okay, just go back. So if you look at 5, 10, and 15, and 22 second and 1792 second, if you are going for a paper or something, these are very small.
Yeah, sir.
Instances.
Yeah.
So they do not, tell anything. So you have to, so if you really, you have to make more instances, medium size, large size, and then show the comparison, not only the seconds, the solution quality. Solution quality, have you shown anything?
No.
You have to talk about solution quality. You do not know heuristic what solution it is doing. Maybe in 0.05 it is giving the most inferior solution. So it cannot be just based on the computational time, it has to be on solution quality here. These things here, that's all.
Okay, so I'm just wondering, because in the formulation you have listed so many constraints, right? And the heuristic seems to be very straightforward, So how do you handle those constraints in the heuristic? Because in heuristic you may come up with some solution that may violate one of those constraints, right?
Yes.
Okay. So in the heuristic, what is your mechanism to handle the constraints that you are presenting in your formulation?
Okay, sir. So actually in heuristic, what we did, we applied this in MATLAB, and we applied this formula and calculate for each of the instances, that is 5, 10, and 15. And based on the
in heuristic, you are only using this get variable and very basic.
No, actually, this is signifies that only the particular instance. But if we calculate each step, then it will cover, and then we put this solution to the objective function to get the original answer, means original result, and then we arrange this on. Means after arranging this on in the descending order, we get put in the objective function and get the result and compare the result. What is the result we get?
But you have to see the way you have written the heuristic. It may happen that the heuristic may give you a solution.
Yes, sir.
But it may become actually infeasible with respect to your formulation.
Yeah.
Okay. So that you have to check that whether it is satisfying all the constraints, or what is the way some constraints can be handled in the heuristic. That is one thing. Another thing in your formulation, as Akhilesh has also pointed out, I can also see some non-linearity. Not only in the objective function, but also in the constraints also. You go to the constraints, you have this minimum function, maximum function.
Yes, sir. So that is linearized. The minimum function and maximum function are linearized using the constraints, using it adding additional binary variables.
I see. So that you should mention.
Yeah. It's already linearized.
So in terms of your problem statement, what is new?
So actually,
the scheduling problem that you are considering, what is new?
So first thing is that till now the paper considered do not consider batch processing with the parallel machine scheduling. So this one is new. And second one is the going to the preemptive case. No one of the paper till now consider the buffer inventory in between the jobs to make the process going smoothly, because sometimes there is a delay of processing a job. So in between the delay, we are using the buffer which is stored earlier, and then the job will be going. So none of the successive job will hamper due to the delay of the previous job. It will be taken from the buffer. So we are considering this factor.
Okay, but that will increase your cost also, right?
Yeah, so we had added some holding cost in the objective function.
Yes.
Yeah.
So you are saying this concept of buffer is not there in this preemptive.
Preemptive, yeah. Till now the paper is not
considered. Properly checked, because this.
What?
Very well researched area.
Very old research area, and lot of people have done lot of. You check. Huh?
Yeah.
I am saying that because I have not done.
Yes, sure.
So you will better know, but you properly check it.
Yes.
Okay. Okay. Otherwise.
Okay. Thank you.
Good afternoon, all the sponsors and my dear research scholars. Today, I'll be presenting a part of my work which I prepared for Inland Waterways Authority of India. So, the topic of my presentation is port performance measurement considering multiple cargo categories and multidimensional nature of port performance indicators. I'm working under Professor Sharma and Professor Jannamani ma'am. This is the overview of my presentation. So, coming to the introduction, ports form the backbone of the inland waterways transportation and waterways transportation in general, as they connect the logistics and provide the trade exchange platform. So, as per the United Nations Conference on Trade and Development, the port performance is defined as one of the measure of various aspects of port operations to compare performance with the target and observe the trend in a performance level. So basically, there are two primary reasons for measuring the port performance. First is to improve the port performance. First is to improve the port operations, and second is to provide an appropriate basis for planning future development. Ports, as we all know, is a complex system involving multiple users and interests, which makes the decision maker task difficult, and it is indeed a complex process. So port performance, they form the basis for port choice and port selections among different users. And as we all know, there are multiple stakeholders. So the choice of making port, like selecting the ports for trade exchange, is one of the crucial element. There are traditional productivity indicators which are treated as one of the treated as performance measure. So by Hussain and others, cargo throughput and total traffic in terms of TEU, 20 feet equivalents, were considered to be one of the important performance measure, and other indicators are berth occupancy, crane efficiency, yard utilization, then the turnaround time. So these are all productivity indicators and effectiveness indicators. So the reason behind taking this study is to cope up with the increasing publication trends and need for this port performance measurement. So based on the literature review, we can say that the port performance form the basis for different efficiency measurement, effectiveness measurement, then the competitiveness, port selection strategy, and measuring the productivity. So these are the few key references where they have taken different dimensions like the operations, infrastructures, finances, socioeconomic. Most of the time, these has been considered individually or at most two at a time. But in our work, we are trying to consider different dimensions so that a composite unified index could be prepared. So there was an existing gap in the literature that there is no unified index available for the port decision makers and port authorities. So we have taken up this work for Inland Waterways Authority of India. Then the most of the time the existing traditional indicators, they are individually considered and has been it's a trade-off of more or less indicators, that one indicator is considered at the expense of others. So there is a need of unified index, as also mentioned by author Ung and others. So individual performance indicator may emphasize certain indicators at the expense of others. And there is a dearth in performance measurement study by considering various significant dimensions like the socioeconomic aspect, the infrastructural aspects. So we took up this objective to develop a methodology for port performance measurement considering cargo categories and multidimensional nature of port performance indicators. So this is a quantitative approach inspired by these two literatures. So our work is inspired by the well-known logistic performance index coined by the World Bank Group, and the other work carried out by Doon and Bradstreet in the topic port logistics issues and challenges in India. So they both took qualitative responses and a limited quantitative indicators. So in our work, we tried to, as we all know that the quantitative indicators and the data are very limited and are available to a few in the higher authorities. So we followed this methodology to construct the unified index, which we are calling it as comprehensive port performance index. So we identified certain ports which are of same scale, clustered these ports based on the different cargo types. So I'll just, yeah. So these are the ports we have taken. There are 13 major ports. We have eliminated 2 major ports in our study because of the different, because they being in the different scale. So these are the type of cargoes which we have considered in our study: the container cargo, the liquid bulk category, dry bulk, and break bulk under other cargo category. So we gathered the panel data from different sources, different annual reports, and then we standardized the data using the information like the total traffic, the total staff, total berth available, and the average parcel size. Then these are the steps which we followed to refine the data. So our work is a 5-dimensional study to include all the aspects of operations, infrastructure, finances, and socioeconomic. So these are the indicators which we have finalized after correlation, eliminating the correlated indicators and interrelated indicators. So this is our final data set, final panel data set. So we have taken data from 2012 to 2017 for all the ports and on different attributes. So this is the schema of our methodology. So this I have already explained. Yeah, so one thing to be mentioned is we have taken quintile score to normalize our data, which is the value provided to one of the value provided to the, or one of the value provided between 1 to 5 obtained by averaging out and dividing them in 20 percentile of their groups. So this is on the basis of our analysis, we have obtained the bottom 3 and top 3 ports as per their total index score. We have ranked them. So for individual category of ports, we have obtained bottom 3 and top 3 ports. So this is one of the visualization technique. There could be many visualization technique, maybe the spider web chart, maybe the histogram charts. This is where we are showing the progression of performance of the ports, and we see that the Jawaharlal Nehru Port Trust are outperforming other ports as compared to, like, in terms of all the aspects, all the 5-dimensional aspects. So we can have a different visualization tool to visualize the performance and gauge the reasons behind their over performance or underperformance, like good performance or poor performance. So in the these are the contributions. In the existing literature, only container cargo ports has been considered, and other aspects like the operational and financial aspects are minimalistic. And in our study, we have considered the panel data and indicators, which are standard to almost every port worldwide. So this is a generic framework which we have prepared, and we employed certain novel indicators which are available and can be utilized. So this is research implications, and conclusions are, so we have filled the gaps of like there was a need of having a performance index. Then these tools capture different aspects of maritime supply chain to have more holistic view of port performance. And we have included, we have tried to include all the quantitative indicators which are available for effective decision making. So this studies would be extended for making an efficiency measurement for benchmarking study. So this is just a part of our work. We have already done these efficiency analysis and all. These are some of the limitations. These are some of the key references. Thank you.
The first thing, Nikesh,
yes,
is try not to read your slides.
Yes.
Okay. If you are making a presentation, try not to read your slides. But whatever is there is visible. Highlight which is important.
Right.
Second thing, coming to your that table where you are saying that we are doing all this literature review table. Yeah. So what you are saying that you are bringing all these dimensions together and creating a performance index.
Yes.
But I could not see where is that composite index. What is that composite index? At least from this presentation.
Yes.
I cannot see. Is it additive? It is multiplicative. It is power. How you are adding all this?
Yes. So this is an additive model of all the indicators.
How do you validate such model?
So we have validated with the industry, like
I'm talking about scientifically.
Okay.
How do you validate that this is the model which is adding up all these things? With, even if you are normalizing, taking the quantiles, how do you say that it is the model? I just added 4 different things: operations, socio-economic, and bring them together and give an index. And what is the range of your index?
So this is like 0 to 200. It depends on how many indicators.
That is what I'm saying. So it can be 500, it can be 100, but you do not know the upper limit, then you do not know it is good or bad.
Because see, we are considering the pores which are of same scale. So every.
No, I don't think JNPT is very big.
No, sir.
JNPT, if you are talking about JNPT, that's why it is going high. JNPT is very big.
All are major codes, sir.
Major codes still JNPT. If you look at the, you are showing the TUs, just showing. That data. Yeah. Look at JNPT. Then coaching. This is including all kind of cargoes.
Yes, sir.
So that is another issue. Some are container, some are like coal. How do you bring them together?
So this is like we have segregated the data as per their cargo category. So when we are taking
I understand
total traffic, when we are considering only the container traffic.
See, you look at JNPT and other here. Here in the data itself, the first third column. Get comparable 6.23 average TRT per ton as compared to other which are maybe in average of 3.5. 6.23, 5.53, 5.30.
Yes.
So maybe you have done, but you are not showing here. But if you are trying to, talk about an index, if there is no maximum or minimum, it is difficult. 100 and 100 same is not same as 500 and 500. So that is missing here. Secondly, if you really looking from performance indicator perspective, maybe first evaluate them individually and then try to see, because just forcing it to be composite, there should be some reason why there is no composite index. What I look at it, you are calling it socio-economic financial, it looks like a sustainability index.
Yes.
If you want to use that term, it is actually you are looking at the finance, you are looking at the socio-economic, you are looking at the infrastructure. So it is a sustainable port index kind of something I am looking.
We can coin
that you can coin. That is because when I looked at the data, so these are some major concerns I have. I'm sure you must have been making progress with your PhD, but when you submit it, all these concerns will come. So whether you validate your index scientifically, otherwise data se nahi hota hai. You have to validate, because if you remember 11th and 12th, the first chapter we read in physics was units.
Yes.
Why something is multiplicative, why something is additive, something is in power, it should be done. Okay, that's all.
Yeah, I also have the similar no, I do not have any issue on it. But it is very so I can come up with my own expression for that index, right?
Yes.
So there should be some process of validation. Okay, that you should show that if you have this additive index, then this is the performance. Some measure has to be there.
Yes.
Validation. Over maybe you can also take some 3 or 4 different indices, okay, and with the same data you can check, right, and show that which one is performing better.
Yeah.
That also, that comparison is not there, no?
Yes.
Isn't it? You should
so
do
this
some
is
comparative
part
analysis.
of it. Actually, we have followed methodology which were taken up for logistic performance index. We have validated with our model with that model. So we have used principal component analysis, and we have weighted.
That is the way to move. I know comparison.
So that
I
is
have not discussed anything.
I have not put it
because I have make a sensitivity index. It uses that. I do not know you are not.
So to validate it, we have used that.
So that is one point. Another thing is that you see all these factors that you have taken. Why didn't you consider these connectivity to these ports? I mean, that would be a very important factor.
Yes.
Say train connection. This because one of the major issue of port logistics is that when they arrive at the port, the material, then they have to move it out, right, and supply it to different places. So if there is some, what is the infrastructure or other transportation modes like the highway connectivity, right, or the train connectivity?
We have an attribute saying that the distance from a highway and distance from a railway station. So we had that attribute, but for the sake of as per the experts' advice, we have tried to remove that.
Oh, that is removed.
Yes.
So you have both quantitative and qualitative?
No, sir. Here we are having only quantitative data.
Why not qualitative?
Sir, we were associated with one of the expert from IWAI. So he wanted something which is like what it is there. So we wanted to have.
Okay, that is project. But as a research scholar, why not bring qualitative also? Why not bring qualitative measures also in this one?
Right.
Because don't look at it as like solving their problem.
Yes.
At the end of the day, you have to do academic research to get publication.
Yes.
Okay.
Okay.
All right. Thank you so much.
Okay. Thank you.
Yes, sir. Good. Yes. So good afternoon, sir, and good afternoon, everyone. So myself, Akshay Bhosle. So I am present today. I am presenting on the risk analysis and application on reinforcement learning for cybersecurity of connected and autonomous ground vehicle. So in today's presentation, I will present the literature review and the basic concept about the risk. So in introduction, in connected and autonomous vehicle have emerged as one of the key achievement in the technology in the first 21st century. So basically the CAVs, that is connected and autonomous vehicle, is an integration of connected and autonomous vehicle. So autonomous vehicle, there are autonomous vehicles, just autonomous vehicle drive automatically without driver, but connected means they are connected through the network. So that's why they combine the connected and autonomous vehicle. The autonomous vehicle perform all necessary functions by sensing the surround. Various sensors are used in connected and autonomous vehicle. So by sensing the surrounding, the autonomous vehicle perform the computational calculations and the necessary function like driving, then safety features. So Society of Automotive Engineering has defined 6 level of autonomy from level 0 to level 5. So level 0 is the consist of the driver, and level 5 is the fully autonomous vehicle without driver. So in autonomous vehicles, various IoT devices like cameras, GPS, then LiDAR, TPMS, tire pressure monitoring system, and other sensors which collects the data. In autonomous vehicle, like in connected, that connected meaning there are different modes of communication. So the communication mainly with the vehicle to vehicle, then vehicle to infrastructure, and vehicle to everything. So vehicle to infrastructure is like there are various roadside units are there in roadside units. So from there vehicle collect the data, and vehicle to infrastructure communication will happen. So the advantages of these autonomous vehicles are improve efficiency of resource utilization, then increase safety on the roads, because the safety is the major concern. There are more number of accidents happen because of the drivers. So minimize the infrastructure cost, reduce human efforts in transportation of passenger and cargo. So this is the autonomous vehicle sensors are used. Various ECUs are also used in autonomous vehicle, electronic control units. Then OBD onboard devices are also used.
So applications of autonomous vehicles are autonomous vehicles has a wide variety of application from military to disaster management, public road transport, and in critical applications also like mining industry. Because mining industry there are very like risk is a major concern in mining industry. So in that area, the autonomous vehicle like UAV also plays a very big role in mining industry. So what are the challenges faced by these autonomous vehicles? There with increase in the level of autonomy, like if we go to the now level 5 autonomy is not there in on the road, but if we increase the level of autonomy, then the risk associated with the autonomous vehicle system increases because of the cyber attacks happen. Then the autonomous vehicle establish a communication network with the vehicle to vehicle and vehicle to infrastructure, which causes the greatest risk to connected an autonomous vehicle. Then various sensors and computational systems are vulnerable to intentional attack, like GPS is GPS spoofing attack is there. Then attackers try to hack the system so that they can collect the information. So as the autonomous vehicle is highly dependent on the wireless network communication, so it is also susceptible to cyber attack. So motivation behind the research is, as number of cyber attacks is increasing with the more entry points. Like entry points are nothing but the attack surfaces, the various sensors, then ECU are the attack surfaces for the cyber attacks. So therefore there is a need to develop the more advanced cybersecurity framework. There are different types of security threat line, cyber crime, cyber attack, and cyber terrorism. So in cyber security, various types of threat agents are involved. Threat agents, cyber security threat agents like activists, terrorists, then internal spy, government cyber warriors are other threat agents to the cyber security. Then cyber security of autonomous vehicle has huge importance because of the confidentiality, integrity, and availability of the data. Because the confidentiality means it is available to the only to the authorized person. So that is the confidentiality of it is not available to the unauthorized person. So these are the various types of attack, attacks on DOS attack. Then Cyber attack is also there. Cyber attack is mainly the creating the different types of identity using fake identities creating. Then there are different defense mechanisms are also there, like intrusion detection system. Then supervised learning. Using supervised learning, we can overcome the cyber attacks or detect the cyber attacks. Then firewall, user authentications are some of the defense techniques. So this is the literature review related to risk analysis. So in risk analysis, mainly the multi-criteria decision-making approach is used for the cyber attack detection. So literature related to game theory. In game theory, mainly they are considering the problem related with the guiding of the autonomous vehicle. They are not considering the problem which cyber attacks can face. So we can solve the problem using this game theory approach also. So these are the research gap, like the existing cybersecurity method considers the completely observable state scenario, because in supervised learning we have the label data, but in real world situation the environment is unknown to us. So we can use the partially observable environment. So using the POMDP method, partially observable Markov decision process, we can solve the problem. So reinforcement learning also we can use for the autonomous vehicle problem solving. The objectives of my research is like formulation of risk assessment model for the autonomous vehicle cybersecurity. Then risk assessment model, in this we consider the various types of losses, various types of hazards for this autonomous vehicle. Then development of reinforcement learning algorithm to fulfill the game theory related objective. So these are some references. Thanks.
So what is the problem statement? Problem statement is not clear.
So problem like formulation of first objective is the formulation of risk assessment model. There we consider the from expert we can get the different loss cost. Like there are various losses associated with the autonomous vehicle: loss of personal injury, loss of vehicle data, loss of data breach. So from experts, we collect the cost related with this losses, and then the consequences like frequency of this losses happening. So
let me interrupt you. Since you have started, you are very early in your research, so I will not ask you those questions. But what I'm seeing, you are talking about experts. Who are those experts?
Sir,
in India, at least you are trying to collect those data.
Yes, sir. Yes, sir.
Do you have any automated vehicle here in the campus?
Yes, sir. AGV is the autonomous ground. I am also making a prototype model also using the Raspberry Pi, and there is a one in our college autonomous guided vehicle department is there. So I am connected with that persons also, and the experts like cybersecurity analyst, and one is working in the Tesla industry. He's my friend, so I am collecting the data from there also, like expert.
They are not expert. They are trying. Okay. When you say expert, of course, they are like you only trying something, right? Please don't take it otherwise. But that's my concern, because if you're talking about, there's hardly any, at least in car sector, any autonomous vehicle running on Indian roads, right?
Yes, sir. No.
So whatever is there in US and developed countries. So first of all, I'm not sure how those data you're talking about IoT sensors, because when I start looking at it, it looked like a very interesting problem. But when you boil down to objectives, I'm seeing that one of the most important thing is your data. If you want to do theoretical research, then it is fine. But if you want to do some data-driven research, I'm finding difficulty how you will collect this data.
Yes, sir. That's why that data is the main problem. So I go to the expert opinion, and I thought that I will collect the data from expert, and then I will.
Like how many autonomous vehicle accidents has happened in whole world?
So there are California Department of Vehicle has published the report every year.
So how many?
Exactly number is not, but
I'm not sure, but maybe 10 or 12, maybe 15. So that personal loss data which you are talking about, how do we quantify it? So you have to keep all these things.
Yes.
Because you are in very early phase of your research. So these are the questions you need to ask. And apart from that, when you go to motivations and everything, you're talking without giving any reference. See, cyber security has well-researched area, and a lot of research is happening still. So what you are doing, you are taking IoT cyber security and put it under the autonomous vehicles. That is what you are doing. What I have understood.
No, sir. Actually, I'm just considering the cyber attacks happening on the autonomous vehicle. So there are articles or papers are
happened.
Yes,
you
sir.
Have all those
Yes,
reports,
sir.
the data and everything.
Yes, sir. Actually, like YMO is there, then YMO data is there. So he has like that are the legal attacks.
Simulated data or actual?
Actual, sir. Actual
attacks.
Yes, sir.
How much attacks will happen?
So they are just like they are checking whether our system is okay or not. Like it is. So that's why
that is your part, your research part. But these are the concern I have, because you are at very early phase. So if you keep all these things in mind, because you're starting with data and then you're jumping into game theory.
Yes.
So that's what I have said, that your problem is what exactly you are going to do. The problem statement and what is the novelty in the problem. Although you have done your literature review, but the way you have presented, it is not clear that under each objective that what is the new, thing that you are considering with respect to the literature. That is not clear. See, the risk assessment model, you have shown some literature, but you have not pointed out that what is missing, or what is the new thing that you are. At least I was expecting a problem statement with a clear identification of the novelty. That these are the different features, or these are the different modeling issues that we are, which is not considered in the literature, right? Because your presentation is more about, reviewing the literature and identifying the gaps and framing your problem statement and objectives, right? Yes. But I do not find anything. Can you please look at this?
Yes, sir. Thank you, sir.
Thank you.
Good afternoon, sir. Good afternoon, everyone. I am Anisha Pal, and today I'm going to present on adopting Industry 4.0 in Indian SMEs. I have been working under the supervision of Professor Vishlesh-Mohanty, and today on my presentation, I'm going to talk about the challenges that the SMEs are facing to adopt Industry 4.0 and how to overcome them. And using my the field where I'm working is in system dynamics and the system archetypes that will be used here. So just an introduction that as we all know, Industry 4.0 present huge opportunities for SMEs that enables them to grow. And SMEs are the major driving force for all the manufacturing sector. And at the same time, SMEs are facing the risk, like they are due to the lack of technical know-how, the financial and the human resource constraints. And thus the integration of ICT and Industry 4.0 can transform the SMEs to its huge economic potential. So just a definition, the Ministry of MSMEs have made a revised definition. Like earlier, only the this time also the annual turnover is also taken into consideration. So according to the provisions of MSME Act 2006, the MSMEs are classified into two classes, which are the manufacturing and the service enterprise that has been covered in the previous slide. And given the importance of MSME, it is critical to ensure that it remains competitive both nationally and globally. Recently, in an article by the Economic Times, the Joint Secretary of the Ministry of MSMEs, she stated that for MSME to grow in India, the things we should talk about the global value chain, not only for them to develop in the country itself. In India, the sector has gained significant importance. Obviously, 30% of India's GDP, MSMEs count for 30% of India's GDP, and the sector has also contributed with respect to entrepreneurship. So, I have been using system archetypes to solve this issue. These are the to evaluate the complex behavior of the system. So, 8 system archetypes have been proposed. These are the limits to growth, shifting the burden, drifting the goal, escalation, success to the successful, tragedy of the common, fixes that fail, growth and underinvestment. So today I'll be going to talk about drifting the goal because I have covered this archetype. So each archetype has its own important characteristics. So this is the drifting the goal archetype. In this kind of archetype, the short-term solution involves letting of a long-term fundamental goal decline. So here there are two balancing loops. From this diagram, we can see that there is a actual goal which an organization works on. However, the current state of the system, as we all know, it's not appropriate to the actual goal, and there always is a gap between the actual goal and the current state of the system. So this goal needs to be reduced, and there are two possible ways. First is to take the action to get back to that original goal that has been thought of, and the second can be the pressure to adjust the goal. So in the actual method or that should be taken is the action to improve the state of the system. But however, the Indian SMEs, they are working on the pressure to adjust the goal. Like in nowadays, it is stated, earlier there was a problem that there is lack of government support and even the large enterprises are not providing the market to the SMEs. However, in the current scenario, post-COVID-19 pandemic, the thing is, there are government support there. Even the large enterprises are helping out the SMEs. They are providing the market to the SMEs. However, the SMEs are not growing to the full potential. The main reason is because they are working on the balancing loop B1 and they are acting like this itself, they are eroding their goal. At the same time, they are not meeting the expectations of the market. So from this diagram, when a gap exists between the current state of the system and a goal, so proportional action needs to be taken to move the system back towards the goal. And there's always a delay. Now, why don't the SMEs are not taking the working on the balancing loop B2? Because whenever they're taking an action to move back to the current system, there'll always be going to be a delay in this process. And SMEs in India have, from the literature review, I've been this has been stated that SMEs have that mentality of do not fix the things until and unless it is broken. So they take action only when things are broken. So they are only working on the balancing loop B1 instead of those balancing loop B2. This gives rise to this eroding the goal archetype, and I've been working on this. So the motivation behind my work is SMEs, as it is the backbone of the India's industrial sector, and they are the hard hit sector after the COVID-19 pandemics. And in spite of the government incentives and support from the large enterprises, they are not performing to the full potential and they are not able to grow. So they are facing challenges to adopt Industry 4.0, and I will be, like in my work, I'll be giving some finding out the key variables, though I have not covered in this presentation right now. So I'll be covering those key indicators that are hampering their growth, and that will be classified under the various system archetypes. So as I said, that they have the system, they have the thinking of do not fix until it's broken. So that is itself is a main drawback why SMEs in India are not growing to their full potential. So these are the literature review that I have covered regarding the SMEs. The research gaps that from the literature review, these gaps were identified, that the interaction between the large enterprise and SMEs are sparse, and the government policies, the study on the government policies are also limited, and there lies only the theoretical studies, only the challenges that SMEs are faced and how to overcome them, that is not mentioned, and there exist no models regarding the system archetypes to come to the conclusion of this problem. So these are the references. Thank you.
Again, you are at a very early phase. So, I mean, what you have taught, I have not done any analysis, but we already know. Forget about SMEs. Most of the Indian companies are, if it ain't broken, I won't fix it.
Yes, sir.
Even the biggest software industry. So there is nothing that what you have found so far is not known to you.
Yes, sir.
Right? Now you are talking about Industry 4.2. I understand COVID and all that. Have you visited any industrial area?
No, sir.
I would say there is one in Calcutta. I'm not sure that area I have visited. Another one is in Jamshedpur, Aditpur area. Just go and first see how they are. Forget about literature. Just have a first-hand look at how SMEs work. Okay. Many research says that they are not able to meet expectation. They are already working at 200%. So those things, if you can bring in, real, from the field, that would be really helpful for you. Rather than literature, many things are published, many things are published, but your first-hand experience, look at the. I'm telling you, we talk about utilizing, increasing the utilizing for many companies. They are already working, the machine is working at 130% utilization. So we need to bring all those factors and then see if something interesting can come on. Because forget about Industry 4.0 to SME, many big firms have not tried to. First, we should look at why they are not implementing. So look at it. Other than you are at very early phase, I'm not sure why all the literature review people are presenting right now. Okay.
Yeah, that is right. Just one point. No, just one point that when you are talking about IoT, to the SMEs, have you looked at the cost? Like what is the cost of cost aspect of of enabling the SME with IoT, and of course the maintenance, the right manpower if they have the right access to the right manpower. So all these are different factors you should consider, because as Akhilesh has pointed out, many big industries have also not implemented that. So there must be some reasons. So you should first go and see that what are the reasons. And especially for SME, what are their resource constraints, funding constraints, manpower constraints, skill constraints, right? What are the different constraints under which they operate, right?
I'm covering that part. Maybe I'm not included in this, because of the time.
Yeah. So you please look into that. And for this type of work, the real data would be very much needed. You should visit some industry.
So I'll be covering the Indian handloom sector.
Yeah.
For this. My work will be based on this.
And also, when you have done your literature review and you are presenting your problem, what are the things, with respect to the SME, apart from this maintenance issue that when something is broken, they're going to. Apart from this, is there any other new, features or new aspects that you have considered? in your problem statement?
So like they are not considering the for the handloom industries, they are moving since towards their old traditional practices. So they are not considering the quality.
Quality.
Yes, sir. So like whenever there's a breakdown, so the breakdown issue is not considered by them, even the quality, because they have that old traditional approach. So that's the thing. Till now, these two factors are considered.
But that has nothing to do with IoT quality.
So how that will be overcome?
Yes,
So
using IoT. So that's some kind of model you have to build.
Yes.
Okay. The last one.
मेरे को आता है पे 80 हो 130 तक आना आप वहीं रहिएगा गेट के बाहर
Good afternoon, everyone. Today I am Amarjit Das. Under supervision of Professor VISHLESHAN is going to give the presentation on implementing optimizing techniques in assembly line balancing. So, to introduce this topic, I would like to first give an introduction about the heavy industries, how they are actually doing in this era. So, heavy industry, as we all know, that low volume and long lead time is one of the basic characteristics of heavy industries, due to which there is no much progress can be seen in the industrial output point of view. And if we consider the supply chain behind this heavy industries, there are a lot of complexities as well, because there are the MSMEs, the micro, small and medium enterprises that are available. They're also in the supply chain for the heavy industries, due to which the productivity even gets complex. Why is it so? Because MSME being a very good platform for the entrepreneur and the innovators, but it becomes actually a big bottleneck for the growth in this country because of few reasons which I would like to mention. Because of the cheap imports which are coming from China, and also some tax-free agreements are made between India and other countries, due to which some cheap imports come, due to which and MSME doesn't get into this good opportunity with the heavy industries. To solve such a problem, government of India is taking a good initiative also, considering Make in India initiative, and it is actually investing a good amount of money for the betterment of the productivity point of view. So for that problem to address, we have taken a case study to see what is actually the scenario going on. So for that, what we have seen that the MSMEs are not able to provide the optimum amount of output which the heavy industries require for the net total output which is coming outside the industry. For that, one MSME we have taken who is producing track frames and giving it to the heavy industries. So the problem what they are facing, the heavy industry, is that the MSMEs are not able to provide the optimum number of track frames, as the data set shows over here. We have a 4 months data set over here, and we can see that it is insufficient. This green one, blue one shows the plan. So the heavy industry is planning for so and so amount of the output, whereas the amount of dispatched is quite random actually. Arbitrarily, they are giving anything. So to address this problem, we have found out few objectives to look after the thing. So what we are first plan is to replicate the same plant, whatever the assembly line they are having, the MSME plant, we'll replicate in a simulation model, and we'll try to find out what are the actual bottlenecks which are actually happening in the process, and we'll try to fix it so that we can get a better output. So this is the methodology which we have taken into consideration. I have already discussed, and the simulation model which I have used During the simulation, it is any logic. This is our plant layout showing which portions of the plant is dedicated for the track frame they are making actually. This is the methodology which I am following right now. This is the case study where we found insufficiency of data, and after which there was a industrial visit which was in the plant itself. We few JRFs with accompanied professors went to the industry and got few data, and we analyzed those data and we understood the shortcomings of the problem. And thereafter we built the model. After that we tested it. If it's working, it's fine. We can go for optimization. If it's not, we'll again go for rebuilding the model. This is the glimpse of the model that I have made, and to understand it better, sir.
What? There is no glimpse.
Here you will understand, sir.
So usko dekho. Yeah.
So this is a schematic diagram of the process flow which is going under for the track frame manufacturing. So there are basically 4 sub assemblies which are coming together and becoming a big part. So right hand frame is there, left hand frame is there, lower frame, bend frame, everything is getting assembled, and then the output track frame is coming out. So to understand the problem, actually what we have done is that, so they have given a daily basis data, and which was difficult to analyze the same thing in the simulation software. So for conveniency, we have taken the data into weekly manner. This is what the data we have evaluated from the given data set, and we have plotted the same in the graph. Now, according to the model, what we have arrived is that initially this is the replica of the model which is giving the same result as the real plant is actually giving. So the basic motive behind doing that, because if you are changing, you can say it is just a digital twin of that actual assembly line which RSB is making, actually the MSME. We are replicating it in the same simulation software. So whenever we are changing some parameters over there, we can reflect the same thing in the actual output. So this is what we have tried, and we have seen that in the 10th week, we are coming out quite close to the actual values, what they are producing. So this is how I conclude my work for now. And the warm-up period which we have found out to be 2.2 days, that is 2 days, 4 hours and 48 minutes, which is required. This is the time required for making one track frame from the scratch initially, and thereafter it is going to make the track frames within 0.1 days only. That's it, sir. Thank you.
So in your simulation model, where is the randomness? Is there any random factor there?
So random factor in the sense, I didn't get.
Simulation. So you are saying that you have developed a simulation. Right? What is the stochastic part? The randomness, or it is just you have some data and you.
Yeah, we had
some
data.
You are presenting some analysis of that data. Why you are calling it simulation? What is the simulation model?
We are actually replicating that same plant in the simulation model, virtually, we can say.
Okay,
the same thing, whatever is being manufactured here.
Yes, and then so the data, in the data, so you have to run the simulation and validate your. Have you done that?
Yes, sir.
So when you run the simulation, okay, is there any stochastic component in your simulation model?
No, sir.
What distribution you have used?
The triangular distribution I have used.
Everywhere.
Yes, sir.
Every point.
Yeah, wherever the service stations are there, I have taken triangular distribution.
Triangular distribution.
Sir, because we knew the most likely time actually, and we went for the when we went for the plant visit.
You choose a distribution, there must be some basis, right? That, is there any basis or just randomly you pick triangular distribution? That is, and what about the validation of the results? The simulation results that you have, how did you validate it?
Sir, we had all.
From a real system, you have built a simulation, but you have to know now you have missed out on something or not, right? there might be some errors in the simulation model. So how do you validate?
So the validation part we have seen over here. This light color is the original output what the MSMEs are making, and this dark color is what my virtual model is making. So this is how I'm validating from this point. This is the 10th week. We are seeing that it is coming, that the output which my model is giving is exactly the same what the MSME plant is producing. So this is how I can validate at this point my model.
And you see in your first slide, you are talking about some optimization. So I don't know where you will fit the optimization and what kind of.
Sir, actually, we are actually working on this policy testing for different solution proposal, in which we will be finding out the bottleneck in the existing model, and we'll be increasing the resources or whatever is necessary for that, and we'll get up with a new solution which will actually optimize the model.
I didn't get it.
Yeah, no, it doesn't make sense. Actually, what you are saying, it does not make sense what exactly they are optimizing. Okay, so I understand. You are a MS student, right?
Yes, sir.
At least any academic presentation, you have to connect it with some academic. No this literature, you know what study has been done, nothing is there. So that needs to come.
Okay,
see, solving an industry problem definitely it is very relevant. But as an academician, we need to, you know, make sure that what we have developed, many other people can replicate. So that part is missing. Okay? Or if something else happens, you know, published earlier, where it is closely related. So these things we have to bring in. And don't use the word digital twin.
Okay.
Every simulation does not mean it is a digital. We have a habit of using this cache phrase. Not use. This is not a digital twin. Okay.
Okay.
So these are some few things. As far as simulation model is concerned, you have definitely you have shown that whatever is there going on in the actual plant after 10 feet, you are able to
Trace the same data,
trace
whatever.
the same thing. But for how many months? It's just one instance.
No. It is 4 months data we have, and we are doing for 4 months data only.
So that is for 4 months data that
Yes,
is
sir.
up PLC?
Yes, sir. So we have divided into weekly basis.
Do not use such figures which you are showing. You are showing something which may be confidential for the moment.
Yes, sir.
Draw your own. So this is for?
This is for, sir, 18 weeks,
yeah,
which is the 4 months, actually 126 days actually comes. So this is giving 4 months data only. We have divided into weekly basis.
Suppose you already have a year's data or 2 years data.
No, sir. 4 months data only we have.
So let's say 3 months data you have, you ran your model and the virtual model. And from your model, you kind of simulate what will happen in the 4th month and then check whether it is matching with what you have seen earlier in the actual output.
Okay.
You will be able to see it. So that's all. Okay. Thank you.
One more thing I would like to say, over here we had no data about inventory, so we have not considered also inventory in my model, due to which initially this gap was coming. But once the inventory was building up, it was able to catch up with the actual data set. No, thank you, sir. Thank you, everyone.
And one more thing regarding the slides.
Yes, sir.
Do not make it like a story. I can see this big, write-ups. Try to make small, concise bullets. Okay? तो तुम्हारा लग रहा था if I'm reading something on क्या होता है जो पढ़ते हैं अमेज़न वगैरह Kindle पे कुछ पढ़ रहा हूँ ऐसा लग रहा था. It's going like a story of a novel, right? Concise, bullets. Okay, thank you.
Thank you, sir.
So individually
Let's now take a break for the lunch. We will have a sponsors presentation at 2 p.m. followed by the oral presentation of panel 2. In the meantime, the videos made by the sponsors about the companies will be played here. You can all proceed outside for the lunch arranged. Thank you. Meantime, the videos made by the sponsors about the companies will be played here. You can all proceed outside for the lunch arranged. Thank you. Meantime, the videos made by the sponsors about the companies will be played here. You can all proceed outside for the lunch arranged. Thank you. Meantime, the videos made by the sponsors about the companies will be played here. You can all proceed outside for the lunch arranged. Thank you.
झारखंड की खेल प्रतिभाओं को उचित प्रशिक्षण प्रदान कर उनके पंखों को उड़ान देने के लिए सीसीएल ने कोयला मंत्रालय के मार्गदर्शन में अपने सीएसआर कार्यक्रम के अंतर्गत सन 2015 में राज्य सरकार के साथ मिलकर फुटबॉल रांची स्थित खेलगांव परिसर में खेल अकादमी एवं इसके संचालन के लिए झारखंड स्टेट स्पोर्ट्स प्रमोशन सोसाइटी की स्थापना की, जिससे खेलो इंडिया डेवलपमेंट प्रोग्राम के तहत मान्यता प्राप्त है। झारखंड के 24 जिलों में ट्रायल द्वारा 8 से 12 वर्ष के प्रतिभावान बच्चों का चयन कर उन्हें मुफ्त आवासीय शिक्षा, प्रशिक्षण एवं पौष्टिक भोजन, मेडिकल सुविधा प्रदान की जाती है। चयनित प्रशिक्षुओं में 96% अनुसूचित जाति, जनजाति एवं पिछड़े वर्ग से आते हैं। एकेडमी में 437 कैडेट्स हैं, जिन्हें पढ़ाई एवं प्रशिक्षण में सहयोग के लिए टैबलेट भी दिए गए हैं। एकेडमी के कैडेट्स जैसे फ्लोरेंस बर्ला, दीपक टोप्पो, चंचला कुमारी एवं कई अन्य ने अंतर्राष्ट्रीय एवं राष्ट्रीय स्तर पर अभूतपूर्व प्रदर्शन कर राज्य एवं देश का नाम रोशन किया है।
मेरा नाम निसीमा कुमारी है। मैं काके प्रखंड की रहने वाली हूँ। मैं फुटबॉल खेलती हूँ। मेरा सिलेक्शन फीफा वर्ल्ड कप अंडर 17 इंडिया कैंप के लिए हुआ है।
यहाँ के कैडेट्स ने अंतर्राष्ट्रीय, राष्ट्रीय, राज्य तथा जिला स्तरों को मिलाकर अब तक 845 पदक जीते हैं, जबकि एकेडमी में मात्र 10 खेल विधाओं को ही सम्मिलित किया गया है। शीघ्र ही 5 अन्य खेल विधाओं को भी इसमें सम्मिलित किया जाएगा। इन प्रयासों को प्रथम नेशनल सीएसआर अवार्ड एवं राष्ट्रीय स्तर पर व्यापक सराहना भी मिली है।
मेरा नाम सबीना कुमारी है। मैं जेएसएसपीएस में 2018 से रह रही हूँ। मैं अभी 73 नेशनल ट्रैक साइकिलिंग चैंपियनशिप में भाग ली थी। मैं उसमें एक गोल्ड और एक ब्रॉन्ज मेडल जीती।
उपलब्धियों ने हमें और ऊर्जा भरी है और राज्य की खेल प्रतिभाओं के लिए एक आदर्श भविष्य निश्चय ही गढ़ेंगे।
तथा ऊसू गांवों को रोशन करने के लिए कुल 1500 घरेलू सौर इकाइयों की स्थापना की गई है। प्रत्येक सोलर पैनल, बैटरी तथा कंट्रोल यूनिट के द्वारा ग्रामीणों को एक टेबल फैन, 2 एलईडी बल्ब तथा एक मोबाइल चार्जिंग पॉइंट की सुविधा मिल गई है। इससे न सिर्फ उन गांवों के बच्चों की पढ़ाई निर्बाध रूप से हो पा रही है, वरन घर के अन्य कामकाज भी सुचारू रूप से संपादित हो पा रहे हैं। इन सोलर यूनिटों का रखरखाव आसान है, फिर भी ग्रामीणों को इसके लिए प्रशिक्षित भी किया गया है। दूसरी ओर लातेहार तथा चतरा जिले के परियोजना प्रभावित कुल 21 गांवों में 41 डीप बोरवेल करवाए गए हैं। इनमें शुद्ध पेयजल की सहज आपूर्ति के लिए सौर ऊर्जा चालित पंप युक्त ओवरहेड टैंक भी लगवाए गए हैं। सीसीएल अपनी परियोजना क्षेत्र के गांवों के विकास के लिए सदैव तत्पर है। पानी बिजली मुफ्त मिला, ग्रामीणों का मुखमंडल खिला।
झारखंड की खेल प्रतिभाओं को उचित प्रशिक्षण प्रदान कर उनके पंखों को उड़ान देने के लिए सीसीएल ने कोयला मंत्रालय के मार्गदर्शन में अपने सीएसआर कार्यक्रम के अंतर्गत सन 2015 में राज्य सरकार के साथ मिलकर फुटबॉल रांची स्थित खेलगांव परिसर में खेल अकादमी एवं इसके संचालन के लिए झारखंड स्टेट स्पोर्ट्स प्रमोशन सोसाइटी की स्थापना की, जिसे खेलो इंडिया डेवलपमेंट प्रोग्राम के तहत मान्यता प्राप्त है। झारखंड के 24 जिलों में ट्रायल द्वारा 8 से 12 वर्ष के प्रतिभावान बच्चों का चयन कर उन्हें मुफ्त आवासीय शिक्षा, प्रशिक्षण एवं पौष्टिक भोजन, मेडिकल सुविधा प्रदान की जाती है। चयनित प्रशिक्षुओं में 96% अनुसूचित जाति, जनजाति एवं पिछड़े वर्ग से आते हैं। एकेडमी में 437 कैडेट्स हैं, जिन्हें पढ़ाई एवं प्रशिक्षण में सहयोग के लिए टैबलेट भी दिए गए हैं। एकेडमी के कैडेट्स जैसे फ्लोरेंस बर्ला, दीपक टोप्पो, चंचला कुमारी एवं कई अन्य ने अंतर्राष्ट्रीय एवं राष्ट्रीय स्तर पर अभूतपूर्व प्रदर्शन कर राज्य एवं देश का नाम रोशन किया है।
मेरा नाम निसीमा कुमारी है। मैं काके प्रखंड की रहने वाली हूँ। मैं फुटबॉल खेलती हूँ। मेरा सिलेक्शन फीफा वर्ल्ड कप अंडर 17 इंडिया कैंप के लिए हुआ है।
यहाँ के कैडेट्स ने अंतर्राष्ट्रीय, राष्ट्रीय, राज्य तथा जिला स्तरों को मिलाकर अब तक 845 पदक जीते हैं, जबकि एकेडमी में मात्र 10 खेल विधाओं को ही सम्मिलित किया गया है। शीघ्र ही 5 अन्य खेल विधाओं को भी इसमें सम्मिलित किया जाएगा। इन प्रयासों को प्रथम नेशनल सीएसआर अवार्ड एवं राष्ट्रीय स्तर पर व्यापक सराहना भी मिली है।
मेरा नाम सबीना कुमारी है। मैं जेएसएसपीएस में 2018 से रह रही हूँ। मैं अभी 73 नेशनल ट्रैक साइकिलिंग चैंपियनशिप में भाग ली थी। मैं उसमें 1 गोल्ड और 1 ब्रॉन्ज मेडल जीती।
उपलब्धियों ने हम में और ऊर्जा भरी है और राज्य की खेल प्रतिभाओं के लिए एक आदर्श भविष्य निश्चय ही गढ़ेंगे।
प्रमुख आवश्यकताएं हैं। इनके बिना जीवन यापन आसान नहीं होता। इनकी कमी से हमारा विकास प्रभावित होता है। झारखंड के दुर्गम क्षेत्रों में बसने वाले गांवों में भी यह सुविधा सुलभ नहीं है। सीसीएल के खनन क्षेत्रों के आसपास भी ऐसे कई गांव हैं। अतः सीसीएल ने कोयला मंत्रालय के मार्गदर्शन में अपनी सीएसआर कार्यक्रम के अंतर्गत सन 2020 में ऐसे गांवों को सोलर ऊर्जा से पेयजल तथा रोशनी पहुंचाने की पहल की है और चंद महीनों में ही यहाँ के लोगों के चेहरों पर आ गई अनूठी चमक।
इसमें लाइट का बहुत दिक्कत था हमारे गांव में, तो 1500 सोलर पैनल के साथ पंखा और बैटरी और 2 बल्ब ग्रामीणों को दिया गया है।
दरअसल चतरा जिले के टंडवा प्रखंड में स्थित सीसीएल के आम्रपाली, ओसीपी तथा चंद्रगुप्त परियोजना क्षेत्रों में परियोजना प्रभावित कई गांव हैं। इनमें से होन्हे, कुमरंग खुर्द, कोयाड बिरहोर टोला, कुमरंग कला, बिंगलाट तथा उस्सू गांवों को रोशन करने के लिए कुल 1500 घरेलू सौर इकाइयों की स्थापना की गई है। प्रत्येक सोलर पैनल, बैटरी तथा कंट्रोल यूनिट के द्वारा ग्रामीणों को 1 टेबल फैन, 2 एलईडी बल्ब तथा 1 मोबाइल चार्जिंग पॉइंट की सुविधा मिल गई है। इससे न सिर्फ उन गांवों के बच्चों की पढ़ाई निर्बाध रूप से हो पा रही है, वरन घर के अन्य कामकाज भी सुचारू रूप से संपादित हो पा रहे हैं। इन सोलर यूनिटों का रखरखाव आसान है, फिर भी ग्रामीणों को इसके लिए प्रशिक्षित भी किया गया है। दूसरी ओर लातेहार तथा चतरा जिले के परियोजना प्रभावित कुल 21 गांवों में 41 डीप बोरवेल करवाए गए हैं। इनमें शुद्ध पेयजल की सहज आपूर्ति के लिए सौर ऊर्जा चालित पंप युक्त ओवरहेड टैंक भी लगवाए गए हैं। सीसीएल अपनी परियोजना क्षेत्र के गांवों के विकास के लिए सदैव तत्पर है। पानी बिजली मुफ्त मिला, ग्रामीणों का मुखमंडल खिला।
Corporation, which is one of the largest multidisciplinary calibration laboratories in India. It is accredited to ISO with an expanded scope for electrotechnical, thermal, dimensional, volume pressure, force and torque, biomedical, viscosity calibration. It has its wholly owned subsidiaries in the countries of Bangladesh, Sri Lanka. Besides, it has its accredited labs in Orissa and New Delhi. EMC also takes pride in conducting industrial tests like thermal imaging, protection relay testing, test of pressure, safety or relief valves, energy meter calibration. So from EMC, now I would request Mr. Avik Das to come upon the dais for presentation.
Good afternoon, everyone. This is Avik Das from Electrometer Corporation, and I am the Chief Operating Officer of the company. So before starting the presentation, I would just give a brief idea about what we do, what already ma'am has narrated to you, that we are a multidisciplinary NABL accredited calibration laboratory, which comes under the Ministry of Science and Technology, Government of India. And we have been accredited to NABL since 2001. And over the period of time, at primary stage, we were accredited for a very small scope under electrotechnical discipline. And thereafter, we have expanded our scope in the thermal, in mechanical, which is being subgrouped into dimension, pressure, mass, volume, viscosity, and force. And later on, we have also expanded our service in the medical device calibration, testing of electromechanical relays, numerical relays, pressure safety valves, energy meters, and so on. So this is nothing but what I have narrated to you, that we had started our journey in the year of 1983, and with in a room which was of 100 square feet in an area of Amar Street of Kolkata. Primarily, we used to repair the kWh meters, and later on, at the very outset of this program, what Professor Mohanty had narrated, in the era of globalization, that is in the 90s, 91, 92, when globalization took place, this era of calibration was just coming into India, and we encashed that. But at that time, we were only performing the calibration activity. But later on, from the suggestion of some very noble person, we also have the idea that accreditation is also required to perform this particular kind of job. And then we approached NABL, which comes under Ministry of Science and Technology, and we got accredited under NABL from 2001. So we are having the 3 labs in Kolkata, Bhubaneswar, and New Delhi, and also we are having our wholly owned subsidiary in Dhaka of Bangladesh and Colombo of Sri Lanka. And it was being made through Reserve Bank of India, this wholly owned subsidiary, by making the foreign direct investment by us. These are some services which I have already narrated to you. That is hydrostatic test of pressure safety valve, then there is energy meter and flow meter, then there is medical device calibration also. Now, this is a very new thing, and we were been discussing in this program also, that is of IoT, or rather the Internet of Things, and it is a buzz in today's market. We have also been into this by virtue of the Industry 4.0 demands, and from the year 2019, this is one of our main focus to get into this, and also to get a kind of and basically we are getting a very good response from the industry as well, and to give some kind of customized products to the clients. These are some ongoing projects of our IoT. Which I guess we are all discussing in the first half of the program. And we are all, and basically we are a company, who are dealing with this on a practical phase to the companies. These are some customer solutions which we had already generated and we had delivered successfully to different clients across India. That is a consistent monitoring water quality device like pH, TDS, temperature, and DO. We have developed this kind of thing through our IoT team, which is being headed by Saptarshi, who is also a research scholar of here. This thing is very important to us because we also have a division of FMCG in our company, which is a very new also, and it started from the year 2020. First, we implemented this in our own warehouse, this IoT in warehouse part. That there is certain kind of temperature which we require to maintain over there. There are certain luminance or humidity which is being required to be maintained in a given warehouse. And this thing was being developed by us through our own system. And later on, we have been working on this. And this was implemented after getting it implemented in our own system. So it's a very lucrative project for us. And in the last 3 years, from this particular IoT projects, the revenue or whatever you call the profitability of our company had went up in leaps and bounds. This is also a very premier project which we have been performing in Alstom. Basically, it's a Madhepura Electric Locomotive Private Limited in Madhepura in the state of Bihar, which we have been performing. We have designed the solution for loco monitoring task over there. Route mapping is there and also the task history of activities and acquisition of for 25 kV, 415 volt and 110 volt AC. So this is basically our first IoT project started from this MELPL only. This is also a project of Madhepura Electric Locomotive Private Limited, which we have been performing. Now, why people should choose EMC? It's a very good question. First of all, we are having a very wide range of expertise in the field of calibration. So we know the core sector very well. And we have been imparting this job for this calibration job, particularly for the last 30 years. So we know the requirement of the industry, what they actually want. So the demand from the industry and supply from us gets optimized and we deliver in the way they require. So this is one of the main reasons why customer of ours choose us for delivering this project or whatever they are in requirement. This is calibration ML and IIoT products. This is very self-explanatory, this part. Now, this is a very important thing, API creation. Do we need to discard the old thing to get the new one? EMC says no, you don't. We have such modeling through which we can integrate the old one with the new one. And how? Through API, it acts as a bridge or rather an intermediary that allows two applications to talk to each other. So this is the thing that we are offering. PLC SCADA is an old concept which was being a very normal thing to the industry. in the 10 years back. And now this kind of RTUs, we only require the hardware command to create the data set or APIs for the communication with our applications. So the most important part is what we were talking about, that we are all talking about Industry 4.0 and we are all talking about this IoT and all. But the businessman or the person who is in the the purchase department of any given company thinks, what benefit would I get if I implement this in my own company? And the most important part is it would save your time, effort, and most importantly, the money. And Electrometer Corporation has been into this. The last line says it all. We transform your old RTDs or thermocouples, etc., into smart sensors with a piece of embedded hardware, allowing it to interface with our software. So, in later part also, if anyone wants to integrate anything into the hardware that we have been delivered to them, they can install it into their own system. So this is our IoT division of Electrometer Corporation. For any kind of issues, you can drop a mail in the mail ID as given over here as iotlab@labemc.org for any kind of cells and system analysis. Thank you.
Thank you, sir. So our next sponsor is the Indian Iron and Steel Sector Skill Council. It's an industry-driven non-profit company limited by guarantee registered under Indian Company Act 1965 and mandated under National Skills Development Corporation. IISSSC is primarily catering to industries like iron and steel, re-rolling, sponge iron units, ferroalloys, steel construction, and welding. The governing committee of the council comprises experts from major iron and steel companies, steel-related associations, and institutions. Now I would request Mr. Shantanu Bhoi to come upon the dais for presentation.
Thank you so much, everyone. And thank you, IIT Kharagpur, for good hospitality. Actually, IISc is working as a bridge between iron and steel industry and institute, as between government and iron and steel industry, or between student and industry. We have developed 49 job roles in courses as per industry requirement. We are working closely along with the member of IIT Kharagpur, and an MOU between IISc and IIT Kharagpur has been finalized, and we hope it will be signed soon. It will help us to build up a good relationship between IISc and IIT Kharagpur as an industry partner and a knowledge partner. As Professor Srinivasan sir said regarding the gap between industry and institute researcher, we can work together on this matter because we have good industry connection. We are working closely with iron and steel industry all over India. Major iron and steel industry like AMNS, JSPL, JSW, SAIL are all our industry partner, and all are in our board member. We have visited many steel plants, their rolling mills, discussed with their employees, contractual employees. So hope we can help each other to build a new nation. Thank you so much.
Video. That we are playing video.
We are playing our videos. Sector Skill Council, and we are working under MSD, Ministry of Skill Development and Innovation. These are the picture of training, assessment, and certification of AICT candidates. National Schedule Test. Candidates. These are all recognition of prior learning, RPL program. Short-term training program.
Thank you, sir. Now we will continue with our oral paper presentation for panel 2. I would request all the participants of panel 2 to be ready for the presentation. I request jury of panel 2, Professor J.K. Jha and Professor Shri Krishna Kumar to come for the evaluation. All the participants will be given 8 minutes for their presentation and 2 minutes for question and answer session. So first presentation for panel 2 will be of Ishita sir. Please come forward to the dais.
एक बार मैं देखती हूँ हाँ ठीक है पोस्ट कर दो हाँ
यहाँ से देंगे ना प्रेजेंटेशन और आगे ये कवर यहाँ कर जो कैमरा है ना हम लोग पानी यहाँ अब रजिस्ट्रेशन नहीं होगा
ठीक है सर आ रहे हैं
फोकस कीजिएगा अपनी फोटो को सेंटर ठीक है इसके टाइप ऑफ माउस कॉर्नर पे देखिएगा सेंटर पर आएंगे तो वहाँ पर सेंटर वो ऑटो फोकस कर रहा ठीक है ठीक है
You have time limit, 8 minutes presentation.
Good afternoon, respected professors, all the industry sponsors, and my dear colleagues. Today I am going to give a presentation on the topic assessment of driving comfort with exposure to auditory, olfactory, and visual stimuli. I have performed my work under the supervision of Professor Aurobindo Rautre sir and Professor Vishwajit Mohanty sir. So, before proceeding further, driving behavior.
Yes, yes.
So, driving behavior is basically a summation of driver personality and effects of different internal and external stimuli. Actually, driver has an inherent personality that is dependent on congenital characteristics, socio-cultural aspects, and technological aspects. But different types of internal and external stimuli help to create different types of driving behavior. So here our main focus is the external stimuli part. Internal stimuli is basically driver's mental states like anxiety, anger, distraction, etc. External stimuli includes different stimuli like auditory stimuli, olfactory stimuli, and visual stimuli, and also different environmental features like road condition, traffic, etc. Driving behavior mainly affects 5 factors like safety, cost, time, comfort, and environment. Here I will discuss effects of external stimuli and how these external stimuli are affecting driving behavior, and as a result it's affecting driving comfort. So my primary research objectives of this study is basically 2. First one is to identify discomfort causing external stimuli, and 2, to quantify and assess driving comfort with respect to different external stimuli. So this is my experimental details. I have performed short distance driving experiments in 70 sessions. Each session's duration was of 20 minutes to 1 hour 45 minutes. And I have obtained different types of vehicular data from the experiments like triaxial acceleration, GPS location, etc. And in the entire journey experience, the drivers were brought under effects of different external stimuli. Like, in some of the instances, there was song played next to the driver, that is our auditory interference. In some instances, the driver were exposed to olfactory interference, that is some perfumes were sprayed, and next there were LED screens placed in front of the driver where different visual interferences were played like different pictures, and
we have studied the driver's behavioral pattern with respect to this type of stimuli. So talking about driving comfort, my methodology first consists of proposing a comfort index based on driving quality. So first of all, what I have done is first Fourier transform has been applied on triaxial acceleration values. Then weighted RMS acceleration value AW is obtained from acceleration values. The formula is like AW equals to 1 by T integration over 0 to 2 AWT whole square dt whole to the power half. Now all the triaxial accelerations I have taken all the triaxial acceleration and the RMS value have been computed with the like this formula AT equals to kx square AWX square plus ky square AWY square plus kz square AWZ square whole to the power half. This comfort index is basically computed based on the standard of ISO 26311. So comfort index is ultimately computed by the formula Ci equals to 1 by Tm summation over I equals to 0 to Tm AT square whole to the power half. Here Tm is the entire time period considered. These are the range of comfort level indicated by different Ci values. Like if the Ci value is greater than 0.229, the journey is considered to be extremely uncomfortable. For 0.145 to 0.229 is very uncomfortable, and like that for 0.032 to 0.057 the journey experience is a little uncomfortable. Now I have computed the mean comfort index value for all these 70 sessions when the drivers were exposed to different types of external stimuli mentioned before. So for auditory interference, the mean comfort index is computed as 0.01. So it can be said that journey experience was comfortable. For olfactory, it was 0.0085. That is also satisfying the criteria of comfortable journey. And for visual interference, it was 0.037. That is a little uncomfortable journey experience. So here I have plotted the bar diagram to compute the changes in the driving comfort level before and after exposure to different type of stimuli. For auditory stimuli, what I can observe is that there is no discomfort created in the drivers. For visual stimuli, there is the 0.037 comfort index, mean comfort index I am getting. So it can be said that the little discomfort is being caused by visual stimuli. For olfactory stimuli, there is also no significant changes observed. So that's all. Thank you.
Okay, go to your slide number 6-7. Have you done the literature review for this?
Yes,
but you have not shown me.
Yes, sir.
You have not shown any literature,
No,
right?
sir, I am not showing.
These are what your formula, or you have adapted
No, sir,
from somewhere?
this is basically by the standard of ISO 26311.
Right. That is methodology already there, right? Somewhere.
Yes, sir. Yes.
And the next comfort level index range, go to the range. Next. Yes. These ranges are also defined, right?
Yes, sir. First table is defined.
Right. You have just collected data.
Yes, sir.
And then we have found whether this is fitting into that range or not, right?
Right, sir.
You have not done any statistical analysis, right? Whether before and after there is a significant difference or not.
Yes, sir. So this is the bar diagram plot.
But whether this difference is statistically significant or not, you
Yes,
have
sir,
done
that,
some.
that I have done
average.
ANOVA test, I have done, but I have not shown it.
Okay, you have not shown.
Yes, sir.
Okay.
Yes.
Respected professors and my dear friends, the research carried out by me in my PhD under the supervision of Professor Vishwajit Mahanti and Dr. B.G. Menon falls under a broad category of ecological modeling and to be specific on resources conservation and recycling. Hence, the title of my work is The Modeling the Circular Economy Process in Indian Metal Industry. We have we have chosen the copper as our product because the reasons for choosing the copper is that the copper does not lose its properties when it goes into multiple times of recycling. And from this figure 1, we can see that more than 50% of copper used in the infrastructure and development. And from figure 2, we can see that the projected per capita consumption of copper will be doubled in coming 5 years. Yes, the motivation. The motivation of the motivations of using the copper in the circular economy process is shown from this figure 3, that we can see that after 2029 there is an overshoot and collapse behavior is shown in the copper production. So there is a need of the hour to do the circular economy for the copper production. So today I will discuss the objective to identify the systemic variables associated with the circular economic process in Indian metal industries and develop a dynamic macroeconomic model. So from this figure, I would like to discuss about the model. Here is the two-flow primary flow of primary metal production, which drives the flow of the secondary metal production. And hence, there are two flow of the primary flow of primary metal production, the secondary flow of secondary metal production. So this is the macroeconomic model for the circular economy process in Indian metal industries, and this theoretical model is developed to capture the direct rebound effect associated with the circular economy process. In the equation 1 and 2, there are total 6 variables. Q is the total production, K is capital, L is labor, D is demand, P is the production cost, and MS is the total metal scrap stocked. This model is developed on the Cobb-Douglas production function and based on the flow mechanism. And this equation 3 shows the ARDL model, the auto-regressive distributed lag model of the metal scrap stocked, and the equation 4 is based on the substitution effect, which follows a geometric progression in which the first term is QPIT into R, and where R is the recycling rate and A is the number of recycling cycles the metal goes through. And equation 5 and 6 gives the miscellaneous cost per price of primary and secondary. So the final log linear multivariate regression model is given by this equation 7 and 8. Now we will move for the estimation process for these equations, and from 9 and 10 we can estimate the change in primary production and change in secondary production. The circular economic process is expected to reduce the environmental impact only if this condition 11 is fulfilled. The necessary conditions for the circular economy activity to experience circular economy rebound is given by this equation 12, and the resources displacement rate is given by this equation 13. Now the data is collected from this ICSD International Copper Study Group and CMI. The available data for the labor is not available. That's why we have chosen the equation 14 to calculate the values for this labor. And the demand for the secondary product copper is estimated by this equation 15. And the available data for this production cost is not available. That's why we have removed from this model. So this is the finally we have to estimate equation 16 and 17. So before going for the estimation process, we have done the descriptive statistics, and we have seen that whether the data is whether the data is stationary or not, which type of distribution is following. So from this Jark-Beda values of the probability, we can see that the probability values are more than 0.05. Hence, the variables are normally distributed. Now from this equation, table number 2 gives the KPSS unit to test the stationarity of the data. So the asymptotic critical values of 1% is 0.739. We can see that the values for all these variables are less than 0.739. So we can say that all the variables are stationary. So after checking all these stationarity and the distributions, we can go for the full information maximum likelihood estimation, and we can see that the values of R square is good, and there is a goodness of fit, and the Durbin-Watson is also less than 2. There is a positive correlation. So we will go for the forecasting. The independent variables are forecasted for the 9 years time horizon by using the false double exponential smoothing method, because here is a one trend is following. So we are using this method, and the fitted values from the forecast were utilized to project the in figure 5 the primary and the secondary copper production in India. We can see that the primary production is oscillating behavior, and after 2028 it's collapse, and the secondary copper production is stabilized over the time horizon, and suddenly it rises in 2026, and the maximum is 2028, and then it's collapse. And the fitted values from the forecast is projected in the environmental impact due to circular economy process, and here is also it is fluctuating over this time horizon, and we can see that the maximum environmental impact occur in 2025 and the minimum environmental impact occur in 2029. And the figure 7 gives the circular economy rebound effect of Indian copper industry. We can see here that there is a fluctuating behavior over the time horizon is also seen from the figure, and there is a partial rebound and backfire, and the super conservation type of rebound are seen in this metal industries, because in the 2022, 2023, 2025 and 2028 the rebound effect values are less than 1. That means that is falls under the partial rebound condition, and the 2027 it is maximum more than 1. That's why it falls under this backfire, means the maximum utilization of those resources takes place. This is happens because in 2027 there is a huge increase in the secondary copper production. That is why the maximum utilization of the resources takes place. That's why there is a increase in the rebound effect, and 2020 2029 and 2030 is a superposition condition of rebound effect, because the rebound values are less than 0.1. Now coming to this figure 8, circular economy process induce the resources displacement. Here from 2022 to 2025 this is stabilized, but after 2025 it is again in the increasing in the exponential phase, because this is also happens because there is a sudden increase in the secondary copper production after 2026. That's why this is happening in this resources displacement, because the definition of resources displacement is change in primary production by change in secondary production, and there is a sudden decrease in the resources displacement. This is also happened because there is a collapsing, the secondary production is collapsed after the 2029. So this is all happening in these figures. So the conclusion part is that the dynamic macroeconomic model is based on co-flow structure in multivariate framework for metal industries is developed. Due to unavailability of the reliable data, some of the variables in the econometric model was removed from the estimation process. The estimation model was used to forecast the influential variables using the Hall's double exponential smoothing method, and the fitted values from the forecast were utilized to project the primary and secondary copper production in the country. Benefits of circular economic process measured by rebound effect and the resources displacement towards nature conservation for a 9 years time horizon are shown. So these are the references. Thank you.
What you have done for the validation of your model?
Sir, we have gone through the simulation part.
Validation, go to the result figure number 5, 6.
Yes.
5?
Yes.
Okay. You are just projecting 2021 onwards, right?
Yes.
Have you compared the result that you are getting from your model and the actual values?
Yes, sir. We have done the data collection part, and we have checked that this is following the same trend.
You have not shown this, right?
Yes, sir. We have not shown this. We have shown in the model.
So first of all, you have to establish
Yes,
that the model is valid.
Yes, sir. Yes, we have got the comments in the seminar room. We have done this in the statement.
What is specific about the copper that you are capturing in this model?
Sir,
so if you just change for the aluminum, right, or gold,
yes, sir.
How things will change?
So things will be not yet, because my methodology is applicable for all metal industries. But in this presentation, I am presenting for the Indian copper metal industry.
Then you should develop a general model, and then you should take copper as just cases.
So we have using the copper because the properties of copper is that copper does not lose its properties when we go for the multiple times of recycling. And the second thing is that our
But really, this is what affecting your study here.
Yes, sir.
This factor is affecting your study. This is copper is not changing its property because of multiple times of recycling.
Yes, sir, this is happening because I am using this recycling rate in my model.
Okay.
Yes, sir, substitution effect. Yes.
Yes. You should show me the figure number 5. Yeah.
Yes, sir.
If you look into that, primary plus secondary.
Yes.
Suddenly, in 2029 and 30 onwards, the total requirement of the copper,
yes,
whether coming from the primary and the secondary, has suddenly dropped down.
Yes, sir.
What is the reason?
Sir, this is reason because there is a sudden increase in the consumptions of the copper, because as the increase in the production of the copper, people have started using the more amount of copper. That's why this rebound effect is, what is this backfire? That's why this after 2027 it is a sudden backfire.
From the past data, can you show this?
Yes, sir, we can show this from the past because this is also happening in the past data also. That's why we have gone through this.
I mean, that's something different. Maybe the production could be different. How consumption can change? How consumption can suddenly drop down? That's what my question is. Your primary and secondary production can, decrease because there is, you have excess inventory or so on.
Yes, sir.
But what about this total consumption? How suddenly consumption has come down? Can you explain this?
Yes, sir. Sir, production is going down. Consumption.
The production is going down. But why? Because the consumption is going down, or you have excess amount.
Sir, from this figure, sir, like 1 minute. Yes, sir. This we have taken from the CMI source. Here you can see that the refined copper consumption and the refined copper production, they are overshoot and collapse in 2019. This is what the condition is happening for this consumption part of view. That's why we have gone through this and done the analysis part.
Okay.
Yes,
okay.
Sir.
Show me figure number 1 and number 2. Figure 1 and figure 2.
Yes, sir, yes. Figure 1.
Figure 1 and figure 2.
Figure 1 in the starting. Yes, sir.
Figure 1. Wait. Okay. Go to the next slide.
Yes.
ठीक है. Okay.
Thank you, sir.
Good afternoon, Professor, and we are research scholar. Today I am going to present my seminar on forecasting the quantity and expected time for return core, module, parts, material, and disposal using the GERT network. So as everything is going to digitalization, that is more return is actually happening in online order rather than the brick and mortar store. That is 30% from the figure. We can see that 30% of all online products are returned, and only 8.89% of return from the brick and mortar store. So there are various reasons why the consumer or return their product. Like they can receive 20% receipt from the damaged product, and 22% that is look different from what they see in the internet and when they get physically. And sometimes the customer order 23% are wrong item, and 30% they return from the other region. And due to the online retailer, we provide the means the online which provide the return, more return means they provide with more return, the consumer is preferable to that network. So that for the technology driven product, the successful launch also impact on that, so that consumer experience the latest technology, so upgrade their product. So here we consider a smartphone of poor return. So that first OEM produce the product and that going to the retailer. Then from the retailer the customer order the product, and if they found any mismatch or faulty, then the customer either return to the retailer or sometimes they use, and after that when after this use the customer again swap with the new product due to the successful launch, so that that product is again sorting, and whether it go to the second-hand market or going for the recycling. Then after the recycling, that core or return product is inspected in the OEM. Then whether that will be a module manufacturing, is that okay, then the module is recovered and the module is going to the module inventory. If the module is found any faulty or not in use, then that is going to the part recovery, and similarly the material recovery, and lastly the rest part is the landfill. So according to that, we propose the GRT network. First, by this step, first we mapping the product return process according to the schematic diagram, figure 1. Then all the process we translate into the GRT stochastic network, like exaggerate, like we actually use the monsoon rule and the other control theory to calculate the expected probability of return for the node and the expected time. After that, so actually we all the processing mapping in this process, we map the product return and manufacturing process. Next slide. First. So this is the actually GRT network. First one is the OEM, and when the OEM transfer to the one is the retailer, then when the customer return to the retailer, then the product again going to the OEM. And the node 3 is when the customer use some time, and that also after some time it also go to the recycle or going to the secondary market. And after the secondary market also, the customer either store it as a secondary product or go for the recycler. And when the recycle node 7, the recycle and the recycle product inspected, and it is either going for the module inventory or part inventory and or material inventory, and if that fails, that going to the disposal of the material. So here actually, yes. So in this network, we use the density function, and that density function is again collaborate with the monsoon rule to calculate the expected probability of the node and the expected time. So here we use two distribution mainly for activity 1. Yes, for activity 1, that is cell. So we use two distribution. First one is the normal distribution for the product long to the end of life, and second is used as a negative exponential distribution, and third is for the testing, sorting, and dismantling part we use the constant distribution. And these are the MGF moment generating function of your negative exponential distribution. And So first step is in first network we want to estimate the expected time and the expected probability of the product return this network. So here from node 0 to node 7 there are 4 routes, and from the Monson equivalence transfer function we calculate your total weightage, and then we calculate the expected time by that equation. Next. This is for the module recovery from node 7 to your node 12, and in similar fashion we calculate the expected probability and expected time of module recovery, and after that we find out the how much module will be recovered from the product. Similarly, we predict the remanufacturable part, that is from suppose Q product are written, then how much the remanufacturable part is predicted, and that is from the node 7 to node 13. And next we predict the recyclable material from the node 7 to node 14. There are three paths. And according to that also we calculate the recyclable material. This is for the forecasting of disposal material and how much material will be disposal, and that is calculated by the equation 33. And this is the illustrative case study, that is suppose the core is a smartphone and there are 5 modules, and there are each module have different parts, and this is from the paper, and that data actually we use, and ifix.com that provide the yielding probability and the processing time. From that we calculate our from that equation 13 and the data we use from the paper, and find out that the product is returned in probability, that is product return probability is 0.436, and that is expected return of time is 75.19 month. And similarly we can predict the how much renewable module is, what is the probability of renewable module, that is 0.41, and the expected time is 51.4 hour, that's weeks. And suppose that 1,000 smartphones are sold in 3-month time period, then how much number of each module and parts and module recovery and material landfill and disposal is predicted by the similar equation. And so that we apply the GRT technique to model the return network of a smartphone, and by using the stochastic network we find out the equivalence transfer function, and from that we predict the parts and module and material disposal. And your reference. Thank you.
Who will use this result? Your recommendation, prediction, right? The result. Who will use, user or maybe company?
Companies.
Companies. For what?
So when they go for remanufacturing, the product return is the key factor, so that they can know that in how much time that product will be returned, and what are the probability of that return and expected time.
Probability of return.
Yes.
And expected time?
Expected time in how many months that product will be returned.
Because they know what is the life of their product, and because they would known to the company.
No, sir, actually due to this successor launch, the product will return earlier.
Are you considering the launch of a new product?
Yes, successor.
Influence of that on the return?
Yes. Yes, sir, in first
year itself. And your title itself, go to the title. This was the first slide. Okay. First slide. Forecasting the quantity and expected time for return code, modules, parts, materials, and disposal using God. Do you think this is appropriate title for this book? Okay.
Go to the next slide, please. No, this is, I can say that this is a motivational part for your research part. Previous one. Correct?
Yes.
Which one?
So next one.
See at the top right corner.
Is it automated or what?
So that return and the return which you are talking, both are different, isn't it? 20% received damaged product, 22% product received looks different. This is not returned to the OEM. These are returned to the what?
retailer.
Right. But you are talking about something else. And this motivational slide should be different.
You're talking about return after the use of the product?
End of life.
End of life or delivery after delivery? What are you talking about?
So both are first end of life and also on spec item also.
No, but returning to home, let's say that 23% received wrong item. But this wrong item would return to whom?
Return to retailer.
Right. Even if it is returned to the manufacturer, are they going to sell it somewhere else or if they are going to recycle?
There is no way related to the recycling.
Secondary.
Why secondary?
Why secondary?
You ask for Samsung, you got something else.
They will sell to the people, again sell to the people, right people.
So this slide need to be changed.
Yes.
Okay.
Okay. Thank you.
Yes.
Good evening, everyone. I am Kriti Kormukar and I am a research scholar in this department. I am working under the supervision of Professor Pradeep Kumar Ray. And today my topic of presentation is the effect of COVID-19 pandemic on Indian blood banking system. So, COVID-19 pandemic has a detrimental effect on socio-economic system of the country, but most importantly, it has a very disastrous effect on the healthcare system. So, the coronavirus disease caused by severe acute respiratory syndrome coronavirus 2 was first reported in 31st December 2019 at Wuhan city of Hubei province in China, and it was identified as a public health emergency of international concern on 30th January 2020, and it was declared as a global pandemic on 11th of March 2020 by World Health Organization. It has affected almost 219 countries and territories all over the world with over 100 million confirmed cases. So the first case of COVID-19 in India was identified in Kerala on 27th of January 2020, and government announced to contain the spread of the virus. The government announced a countrywide 21-day lockdown on 25th of March 2020, and it got extended till 31st of May in 4 phases. And despite taking all the possible restrictions, the virus transmitted rapidly and it affected almost 10 million people all over the country in 2020 itself. And we can see the figure displays the daily new cases of coronavirus in 2020 in India.
This is not daily, I think this is cumulative, right?
Yes, sir?
It's a daily?
It is a daily.
Okay. The bar chart that is
So the blood bank is considered to be an integral part of any healthcare facility, and it ensures the smooth functioning of the system. It is identified as the fifth most common procedure of a healthcare industry. In India, blood is treated as a drug under the Drug and Cosmetic Act 1940, and India has almost 3,000 blood banks all over India. But unlike most of the countries, the blood banking system of India is not centralized, it is decentralized, and it is a kind of a mixed blood banking system with central blood banks, hospital blood banks, and standalone community blood banks. There are some unique features of blood banking system that makes it different from other perishable inventory problems, like it has varied proportionality of blood groups in human population. There are 8 major blood groups, and the proportion of blood groups vary in every region of the country and every region of the world. There are various different blood components that are prepared from the whole blood, like red blood cell, fresh frozen plasma, and platelet, and their usage is different, and so their different demand is different as well. And the blood components are perishable in nature, but their shelf life are also different. Like the red blood cell, the shelf life of red blood cell is 35 to 42 days according to the preservative that is used. The platelet is highly perishable with only 5 days of shelf life.
Time limit you have.
5 days of shelf life, and FFP can be stored for a year. So we have conducted a study in a standalone community blood bank situated in Kolkata, India for the year 2020, and we have collected the data regarding the blood collection, blood component processing, testing, and daily demand for different therapeutic uses during the pandemic. We have discussed the preventive measures with management officials, and we have analyzed the data. So from the figure, first figure, we can see the monthly collection of blood during 2020. We can see a major drop of almost 80% in the month of April. No blood donation camp was organized in this period, and the blood bank encouraged the patients to bring some replacement for every issued blood, and only the replacement donation was there to as the supply of blood during this period. As a consequence of that, we can see a major drop of average inventory level of blood components. So there was no blood component for 3 days in this concerned blood bank, and also the inventory of blood component was below 10 units for 13 days during this time. So as per the directive from the Government of India to suspend any elective surgeries or non-urgent clinical interventions, the demand of the blood also decreased, and we can see a difference in utilization pattern for this period. Like generally, this blood bank caters to almost 100 thalassemia patients. So, and the 30% of the blood demanded was from those thalassemia patients. But in this time, during this period, the blood bank officials only prioritized these thalassemia patients, and 40% of the blood was issued to the thalassemia patients, and the rest of the demand was fulfilled only after confirming urgent need. So we can see the difference in percentage in supply and demand for different type of blood groups, and and also the high standard deviation of daily demand of different blood type was also indicative of highly volatile nature of this demand. So there was also decrease in the staff of blood bank, and due to the additional cost of personal protective equipment and sanitization, the cost of blood collection also increased during this time, and most of the reagents that are used in a blood bank are imported, so there was a disrupted supply of consumables as well. So there are some policies that were taken by the Government of India and the concerned blood bank. So to ensure the safety of the donor, different criteria was
imposed on them. The blood banking staffs were trained about the transmissibility of the virus, and also the replacement donation was highly prioritized, and the patient blood management by ensuring the utmost need of the blood was ensured, and some lessons were learned for the next as a measure for next similar situation, as the importance of proper flow of information was prioritized. Like the public should be aware about the type of transmissibility, and we should also analyze the utilization pattern of the blood bank so that safety stock can be maintained properly. The blood, as we all know that there were some contaminated areas that were selected as highly contaminated zones, so the blood drive location should be selected as per the contamination, and blood banking staff should be trained well. Communication with the donor, hospitals and other blood banks should be prioritized, and a national hemovigilance system should be in order to ensure the safety of the whole system. Thank you.
The previous slide that you have written, right? These are what just intuitive.
We have this discussion with the blood banking officials, and they have
we have collected so many data, right? But at the end, these conclusions are based on your observations from the data.
Sir, actually, I'm trying to formulate a model to quantify the safety stock, like time varying safety stock from this data. I have not
because if I remove this one as a COVID, don't look at the COVID perspective. This is fine. This can be applicable anywhere. What additional, things which is there due to the COVID? Nothing.
So actually the utilization pattern also changed. So from that only, there is a steady demand of demand for thalassemia patients. So we are taking for the next study, we are taking this part as a constant demand, and the other demand are taking as a time varying demand. There is some seasonal patterns. So we'll consider that, and we'll try to quantify the safety stock. That should be like a time varying safety stock, not a constant stock.
At least the model for the safety stock will have been much better.
Also, say for the COVID and blood, these two are so I don't know why any places.
Like there was no supply of blood for
Because of demand also, that's all.
Demand
people
was also
were just deferring their visit.
No, but shortage was reported, like for the many thalassemia patients were not getting blood. That was reported.
Anyway.
Good afternoon, respected professors and my dear friends. So I'm Swati Patnaik. I'm working under Professor Mamta Jinamani. And my topic is export mode planning of horticultural produce in cold chain using CFD or computational fluid dynamics analysis and kinetic model of quality. The case is for an Indian mango. So transcontinental transport or exporting to a different countries, there every single shipment is subjected to a unique temperature history from the farm to consumer. Not only in each shipment, not only in different shipments, but also in each shipments, the quality of different produce may be different. It varies with the temperature, mainly for perishable produce, which are dependent on temperature and time for its quality. So that's why we need a proper monitoring system, temperature monitoring system, or also an environmental conditions monitoring system in which the cargo is exposed.
So there are a number of devices like the sensors, the wireless connectivity, Internet of Things, all these are adopted for monitoring the temperature of the produce while exporting. But there are some limitations like the cost. We cannot use a lot of devices inside a container which is 20 feet or 40 feet. It will be too costly. And one more is that it cannot be placed at remote locations. Like considering mango fruit, the center of the fruit is at generally at a higher temperature upon which the quality depends, where we cannot put any sensors. So what is an alternative approach? It is the use of simulation modeling with the help of computational fluid dynamics. So there we can determine the temperature distribution at any region inside the domain. So with the help of virtual temperature tracking throughout the cold chain via simulation method, we can predict the quality with the help of kinetic rate law model that I will be explaining. So some of the advantages of computational fluid dynamics modeling is, first, the potential problems can be diagnosed in an early stage and preventive measures can be taken. So before the actual export takes place, we can know what can be the potential problems faced during the cold chain. Then each shipment or pallet of horticultural produce can be leveled with a best before date. So as we know the quality, so before the actual shipment takes place, we can level each region of the produce at a best before date. Next is forecasting food quality evolution under the assumption of expected cold chain and operating conditions. So with different operating conditions also, we can perform the simulation and know which is the best condition prior to the export process. Then first expired, first out, which means that at destination, when we have reached a destination, the one which has less shelf life, that can be sent to the nearest retailer, and which have a better quality or better shelf life, that we can plan to send to the farthest retailer. More elaborate monitoring of control points to establish corrective action, which as I already said, that we can, with the help of computational fluid dynamics modeling, we can know that the temperature distribution of the whole domain, which is not possible with the help of sensors. So there are a lot of stages in a cold chain, but I have considered the 4 basic stages. Harvesting, that is mango is first harvested, then pre-cooling is that after harvesting it has got a lot of field heat, then immediately it is taken to a pre-cooling chamber. After that it is packed, palletized and loaded in the reefer container for land transport, then the sea transports or air transport, whatever is preferred. So first, these are the conditions which I have used for my simulation. The harvesting temperature, I have considered it as 308 Kelvin or 35 degrees Celsius, as mangoes are harvested in summer time. Then next stage is pre-cooling. So initial temperature of mangoes are considered as same 35 degrees Celsius, and the cooling air temperature which is circulated in the pre-cooling chamber, that is 286 Kelvin or 13 degrees Celsius. That mangoes have got a variable heat of respiration, means that at high temperature the heat of respiration is also higher, and at lower temperature it reduces. So that variable heat of respiration is also included in my model. Then the inlet, that is with the help of a fan whose airflow rate is given, cooling is done. And then after pre-cooling, the temperature of the mangoes obtained, the temperature distribution obtained, that is taken as means input condition for initial condition for the land transport stage. Here the cooling air circulation inside during transport stage is considered as 283 or 10 degrees Celsius. Again, we are applying the variable heat of respiration. So there are some assumptions to my modeling, that is air is considered as steady, turbulent and incompressible fluid with constant properties. Radiation exchange is also neglected because yes, radiation exchange is also neglected because the refrigerated container is quite insulated. Physical characteristics of air, mangoes are assumed to be fixed in a temperature range. Buoyancy is also not considered, and we are assuming an ideal cold chain, that is there is no power failure or things like that. Then only I have considered the 4 stages, main stage, that is harvesting, pre-cooling, land and sea transportation. So with the help of Navier-Stokes equation,
First, airflow distribution is obtained with conservation of mass and momentum equations. Then, with the help of conservation of energy equation, we are getting the temperature distribution inside the container as well as pre-cooling chamber. Then, with the help of kinetic rate law model, we are calculating an overall quality. So, this A is the overall quality, and the N by varying the N, that is order of reaction, we are getting different qualities like loss in vitamins or browning of the skin. All these factors by varying N we are getting. So some conditions like the Alfonso mango fruit, it can be stored for 28 days at 12 degrees Celsius. So these are already experimentally determined. So these conditions we are using to calculate these constant values and finally determine the overall quality with respect to time. So these are my results. This shows the pre-cooling. This is the inlet, pre-cooling chamber inlet, and these are the airflow vectors, how they are distributed. This shows the temperature distribution and contour. Then this is the transport. Here it's the inlet at the bottom and outlet is at the top. The air circulation takes place in this manner. So now I have considered two pallets inside the container, one with high airflow rate, one with low airflow rate. So this shows the airflow vector and velocity distribution in the pallet. So this is the quality with respect to time, which I have calculated by taking the temperature of center of the mangoes. So for this is for pre-cooling stage, and this is for the two pallets during transport stage. Next. Finally, to conclude, we have developed a simplified model to predict the temperature and quality before the actual export process takes place. Then, and the produce can be the total. Finally, at the destination, we can. It was found that we divide the produce into 3 quality levels inside the container, and based upon that, we can make a distribution plan. Like the produce which is have higher quality can be exported to a distance retailer. So, thank you.
How do you quantify this quality?
Sir, that is by kinetic rate law model.
बोला लिंक एक्टिवेट हो गया ना, नहीं हुआ हो गया होगा, टीमिंग जा रहा है, जा तो रहा है, जा रहे भाई, हाँ जा रहे
can be there.
वो आपको नहीं देखिए, इसको कब कीजिए, कीजिए ना,
In the ancient literature of our great country, we can find a simple yet profound thought. Na choraharyam, na cha rajyaharyam, na bhatrabhagyam, na cha bharakari. Vyayam krite vardhata, evam nityam vidyadhanam sarvadhanam pradhanam. Which means knowledge is the best wealth among all. No one can steal it, no one can snatch it. It cannot be divided among the brothers, and it's not heavy to carry. As one spends, it increases, and as one shares, it expands. To learn and acquire knowledge from the experts, teachers, fellow scholars, we have created this platform in the form of VISHLESHAN 2022, the Doctoral Colloquium and Research Scholars Day, jointly organized by Department of Industrial and Systems Engineering and Institute of Industrial and Systems Engineer. On behalf of our department and IISc University chapter, I, Swati Patnaik, respectfully extend a warm welcome to all of you to VISHLESHAN 2022. We believe that VISHLESHAN 2022 will be a great opportunity for all of you to acquire knowledge and, most importantly, share it. As we begin our program, it's my pleasure to welcome the dignitaries on the dais. Our chief guest, Padma Shri Professor Shankar Kumar Pal, National Science Chair, Emeritus Professor, Distinguished Scientist and former Director, ISI Kolkata. Our Chief Patron, Professor V.K. Tiwari, Director, IIT Kharagpur. Professor J. Maiti, Head of the Department and Convener of VISHLESHAN 2022. And Professor Mamta Jainamani, Research Scholar Coordinator, Department of Industrial and Systems Engineering. Now I would request Kriti and Anisha to kindly present bouquet to our chief guest as a token of respect. I would again request Kriti and Anisha to kindly present the bouquet to our chief patron as a token of respect. I would request Anisha to kindly present bouquet to our head of the department as a token of respect. Light symbolizes knowledge, purity, and is the dispeller of darkness. Now may I request the dignitaries on the dais to come forward and light the lamp as we inaugurate VISHLESHAN 2022. Let us commence this auspicious occasion by remembering the blessings of Almighty. I request Gaurav to come forward for Saraswati Vandana and all to rise for the prayer.
या कुंदेन्दु तुषार हार धवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्कर प्रभृतिभिः देव सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसार परमा आद्यां जगद्व्यापिनीं वीणा पुस्तकधारिणीम् अभयदां जात्यान्धकारापहां हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदाम्. Now I call upon Professor J. Mathi, Head of the Department, to deliver the welcome speech. Sir.
Respected Professor B.K. Tiwari, Director IIT Kharagpur, Chief Patron of this function, Professor Padma Shri Shankar Pal, Chief Guest of this function, Professor Chanamani, Research Scholar Coordinator, convener of this function, Professor Sri Krishna Kumar, and co-convener of this function, Professor Ray, Professor Mohanty, Professor Krishna, Professor Sharma, Professor Jha, other professors of this department, distinguished delegates from companies like Central Coalfield Limited, like Indian Iron Steel Council and ECAB Lab, Kolkata, and also that support from Arti Steel, my dear research scholars, other MTech students and other students, as well as the staff members of this department, as well as other departments of IIT Kharagpur, as well as the support team from CET. It's heartiest welcome to all of you to this inaugural session. And as you have seen in the morning, we have done some of the technical events, and this session is also full of events. And you all know that the program is Doctoral Colloquium and Research Scholars Day. Here our research students, as well as MTech students who have initiated their research careers at the early stage, they are presenting their work in terms of paper presentation, in terms of poster presentation. And sir, I'm happy to tell you that so many students presented, and also there are a lot many posters, including the sponsors presentation, everything in the whole day, in a packed full day, we have done this. And our department is having around 50 number of research students, and there are many project staff members, as well as the MTech students who are participating in this 2 days program. And our motto is, particularly this time, we thought of that we are believing in not only the research as an academic output, we are basically believing in the concept of research and industry. So this Research Scholar Day, we can coin in another name like Research and Industry Day, because today's research, it should go to the society, go to the industry. So maybe in coming days, we will organize program like this, Research and Industry Day, or for a couple of days where more number of industry people will be participated. This time, sir, we have around 11 industry delegates present today. And because of the pandemic, we initially thought of that we will be doing the things online only, but fortunately we are now probably in the safest phase, considering the past 2 years, and then we switched over to the hybrid mode, mostly in physical presence, and we got very limited time. I think last 10 days we actually got to organize this program. But even then, I am telling you, sir, the research scholars, they showed so much of courage, so much of enthusiasm, and a lot of effort they put everywhere in the social media to the that physical medium. Everywhere they have made this VISHLESHAN 2002 presence felt. So I am extremely happy, and as well as I want to share with you that the scholars of this department, they are really doing wonderful, including our MTech and MTech students and project staff. We have got many projects. The department is had been conducting several years. Both of you, Professor Terry and Professor Paul, both of you know our department since long, and based on your attachment with this department. And I will request all both of you after this function to see the posters where we have demonstrated our capabilities and achievements, particularly in terms of research and its connection to industry. And with my research scholars, so I always interact with you, so I don't want to tell again those advices and suggestions that you know I have given you in several times. It is time to listen to the eminent personalities like Professor Pal and Professor Tiwari. So with this, I welcome all of you again to this function, as well as my special welcome to my industry delegates. I think five people from Central Coalfield Limited and 6 from Kolkata, 2 companies. So with this, thank you everybody, and I am extremely thankful to Professor Thierry and Professor Pal for coming here and gracing the occasion, because this is a big event for us. Your presence makes the difference, and we feel encouraged and motivated, and I'm sure the scholars will show you in near future even bigger events where the international conference this year we are going to organize, and Professor J.K. Jha actually working very hard for that purpose. So even for the sponsors point of view, sir, I can tell you, all the professors, they tried within 10 days, I think 4 industry connect, and getting the sponsor is not a easy task. I can say that Professor Jha single-handedly brought that Central Coalfield Limited into this particular occasion, as well as Aarti Steel and the Kolkata and IISSC Kolkata. So all other faculty members, including Professor Obi Krishna. So from the Aarti Steel sponsor point of view and other professors, everyone tried, 4 materialized, and I'm sure that in future that with the effort of all the faculty members, as well as with the collective effort of all the students, particularly when we motivate our students, I find that they do miracle. It has been proven time again. So thank you everybody. Thanks a lot.
Thank you, sir, for your kind words. A very warm welcome to a personality with distinct vision and who is also our chief patron, Professor V.K. Tiwari, Director IIT Kharagpur. His field of specialization includes machineries, system designs, industrial ergonomics and safety, and electronics and computer application in farm machinery design. He has published more than 150 research papers in national and international peer-reviewed journals and conference proceedings in the field of tractor and farm machinery designs, industrial ergonomics, and safety and precision agriculture. I would request sir to come forward to address the audience.
Thank you. Good afternoon to all of you present over here. Professor Pal, a distinguished personality who has agreed to be with us here and share his knowledge. Professor Mathi, the head of department of ISC as well as chairperson of Safety Engineering and Analytics Center. Professor P.K. Ray, Professor Mahanti, Professor Obi Krishna, other faculty colleagues over here, Professor Janamani, and all other participants who have come from the different industries, and student friends, if they are here. I welcome each one of you in this gathering. Friends, I think maybe about 15 years back or so, it was thought of having this Scholars Day. And the very idea was that scholars were feeling let down, because earlier we had a feeling that the holiday used to be there where the UGs used to enjoy, and then there was no avenue for the, of course, PG, particularly the research scholars. And then there was an idea, one of the directors thought that why not there should be a research scholar day as well, possibly Professor Acharya, right, who belonged to this department, and he was later the director of this institute. And right from that time, the idea was that the research scholars will also be on toes, and they will know that what sort of people who will come from the different industries and the organizations who will come over here and see the work that we are doing. And therefore, they must have something tangible to show to the outsiders. So it will be beneficial in both the ways. They will be also on their toes. They will try to do good quality work, and there will be energy in them for the next year again. Now, this was the aim. Over the years, I think we have lost the way somehow or the other, and the whole concept is not possibly got diluted. We did not dilute it, but it got diluted because of several reasons that need not be VISHLESHAN. We need not do that VISHLESHAN here, and that is why possibly the name here is given VISHLESHAN. VISHLESHAN किया जाए कि क्या हो गया. Well, I think as the research scholars, the industry people, when they come together, they find that many things which are not known to them, although the industry people are doing many things which are happening in the world. But because of the advancement in knowledge, until unless they freshen up their knowledge, it will not be there that they will be in tune with what is happening in the world. And hence there is a two-way process which is essential, that our research scholars also share, and they also know as to what is happening in these institutes. And it will be a good platform for both. And hence such thing started. I'm very happy that 4 companies, maybe it was a very short time, and all of you know that COVID has, I do not know whether we are left back COVID or not, because yesterday I was in Cochin, and then still people are saying that no, we have to maintain. I said, sure, we should maintain the distance, social distance, as well as mask, etc. We do maintain. But inside when we come, okay, fine, I think possibly the COVID has left outside the room or something like that. But yes, let us hope that nothing comes up and we will have a new dawn. That is why possibly what Professor Maiti said, that it was picked up initially for online, and now we have shifted to hybrid mode. Well, it has its own advantages, because even the number here could be about 60, 70, but about more than 300, 400 people are connected across the globe. And yes, across the globe, which has not been possible if everybody has to come here to think of the logistics. So I think this has become a new normal, and it is going to continue for the rest how many 30, 40 years or so, because new platforms have come up, and maybe even many things will happen as if we are sitting across the table, even though we are about 10,000 kilometers away in the different parts of the globe. Well, I was in Naval Physical and Oceanography Laboratory Cochin yesterday, and I was talking, there was a meeting with the director and other alumni, in fact, Colloquium alumni, and one of your students, Aziz, I think, right?
Samir Abdul.
Salim Abdul, yeah, he was there. So I think we were talking that, you see, there is a threat from one of our neighboring countries. And because of the threat, we are thinking that we should become Atmanirbhar. Now, you see, the concept of Atmanirbhar is very, very important, because until unless, see, if you want to become Atmanirbhar to save yourself, suppose somebody hits you, then only you will hit, fine. वो तो महात्मा गांधी ने कहा है कि पहले इधर मारे तो ये भी दे दीजिए. But the situation is changing now. We have to be careful that the other fellow should not be able to even hit the first of the cheeks, right? So we should be ready with that. And therefore, we have to be clever. And hence, particularly in waterways, you will have to know that these submarines are inside. You don't know who is coming and what sort of thing they will do it. And therefore, the work which is going on in that laboratory is of extremely high quality. They have the facilities for even testing underwater to about 200 meters. And they have found out, they have gone up to the base of the ocean, and up to 240 kilometers they can detect the submarines and take action of that. What was important there, we were discussing is, while we think that we have to become Atmanirbhar, some of the things which we are still dependent on. For example, I can give you, when we are talking of oxygen cylinders to be prepared in the country and all that during the COVID period, when the second wave came, at that time, we had in fact, here also many of our friends did it. But you know what was not available to us? The zeolite. The zeolite was brought from China. Now, the fact remains this. So we should be now, why not create that? Otherwise, where is the Atmanirbharta? In fact, the vaccine that we created for that, the base material was to get from US, and they delayed for some time, if you recall that. Although we had given them the earlier tablet, we had given them. When Trump was there at that time, we had given. But later on, these people, when the base material was to be supplied, they delayed somehow or the other. And everything we do, the medicine which we created, which is better than others, you see that it took so much time to get approval. So we have to work under so much of difficult situations across the globe, although we are capable and we have the best talent in the world. You see, our own talent is going to the other countries and they are doing so well. So why not hold them back? This is one question. Secondly, the funding required. You require a lot of funding for creating those, the chips. We are in a position to do everything except the chips. Now, you need to have the infrastructure for that. You need to have the laboratories for that. And most important is the security of that. So until unless you have enough security for those chips, the whole thing will go away. Now, the question is that in US and these industries come forward with money, and they have assurance that they will be in a position to help us with the view of keeping the secrecy of that that product for a long time to come, which is not possible in our country like this. So therefore, the government has to come forward to help us in a big way in order to create each and every item of a particular product, which is important. So the moment you are thinking of Atmanirbharta, this has to be from material A to Z. Then only we can have. For that, you need the infrastructure, particularly the machines, the fabrication facility, which we do lack. Then the testing facility we do lack. So what is important today is there is a need for the synchronization of the abilities and capacities and strength of the industries, the academia, and the government. And that is why in the National Education Policy 2020, I think you must have seen that we have the NRF, the National Research Foundation, which has been created, so that the industries come together with the academia and the government helps us to create that infrastructure. Of course, there is a lack of political will, which is very important as such, because the industries are not going to take that much of risk with secrecy as the other industries do take. And therefore, I think it is important to give that sort of confidence in the people or the stakeholders who have money, who can come forward and help the government. And there, a situation like these industries who are looking for models, who are looking for products, who are looking for this help. In fact, the one which you can develop over here will be easy to get repaired as well. But if you take something from other countries, you will have, the moment something goes wrong, I think it will be very difficult for you to get it repaired. The downtime is so much that you can't afford. And time is money today. Therefore, we have to understand that until unless we are Atmanirbhar in each and every product, the design part of it and its testing, validation of that, we will not be Atmanirbhar even for next 100 years or so. And that sort of thing has to come. And where is the time? Time left is only 25 years. By 2047, I think if you do not plan, the new generation must be involved in the research and with the industries, then only by 2047 we can think that yes, we are Atmanirbhar. Another 30 years plan has to be on the anvil. We are thinking of zero carbon by 2070. That has to also start right away. Lot of opportunities exist, lot of infrastructure exists in this country. What is missing is the willpower. What is missing is our working together. I tell you that still we have that feeling the seniors don't look after the younger ones, and then those younger ones look after the very young ones. This is essential today. Otherwise, it is not possible to create those groups who will be working. The idea is not that it should be, say, head of department driven system or a director driven system. No, we have to create systems. We have to take a 15-year plan by which, irrespective of the director changes or the head changes, the system should grow, because we have a product at the end of the 15 years, or a set of products or a set of infrastructure to be developed. I think those are the things which are important for us. And we have to go in a systematic manner, in a planned manner, and a cohesive manner. There has to be inclusivity of all the people together. And then only it is possible, where we have the industry people as well. We are talking of small MSMEs. Yes, MSMEs are to be looked after very, very well, because they do not have that much of infrastructure, but they do have the manpower availability. So how do we utilize those manpower? How to train them well in some of the most sophisticated equipment, so that the product which they are developing, that product is of a very good quality. It has better reliability and sustainability. Safety is introduced in that. I think these are some of the important things which have to be looked after. And we have some infrastructure. I think Professor Matthew will definitely take you to so advanced manufacturing that we have here, the infrastructure, smart infrastructure which we have developed over here. And also in medical care as well, we have done some of the things. But what remains is, friends, let us come together, plan certain things in a mission mode, and involve our second-year students, third-year students. Try to think that how best you can utilize their talent. They are brilliant students, and let them have a feeling that yes, they can do something. If that feeling comes in, if that sort of a you can say, make them inbuilt some of these attributes, I'm sure that will go a long way. I'm sure such programs done quite often. This is maybe the research scholar program for once a year, but I think we should have such industry, and as he was telling, industry and academia interface should be another every 4 months, 5 months, at least thrice in a year. We should think of, and every department should think of like this. Then only we'll be more closer to the industries, more closer to the stakeholders as well as the users. I think with this, I welcome each one of you and hope that this will be a very successful program. Thank you very much.
Thank you so much, sir, for your motivational words. Now I request our chief guest, Padma Shri Professor Shankar Kumar Pal, National Science Chair, Emeritus Professor, Distinguished Scientist and former Director, ISA Kolkata, to address the audience.
Good afternoon. Dear Professor V.K. Tiwari, Director of IIT Kharagpur, Professor Jharshar Maiti, Professor Mamata Janamani, my beloved students, research scholars, ladies and gentlemen. It's my great pleasure to attend this inaugural ceremony of VISHLESHAN. I remember the similar program, I think I attended on 17th of February 2018. And I think from that day, I started collaboration in the area of safety analytics, about which I didn't have any knowledge, with the group led here by Professor Jharshar Maiti. So I have learned many things about your safety analytics. I had only little knowledge about soft computing, pattern recognition, data mining. And even during our pandemic, for the last 2 years, we could make our collaboration sustain. We worked up to 1 o'clock in the morning for correcting paper with my students. I'm not seeing her here because she got recently married. So even during pandemic, that collaboration was sustained very much. Now, since I have to say a few words, and I'm not a good
speaker like your director. So director speaks so fine. Now, since it is a technical program, and I saw in your program that data science analytics is one of your just theme areas also. So I like to say a few words. In the sense, those who are research scholars, they should keep it in mind while working in these areas and also some related areas. What are those words? First of all, this data science AI, this is a buzzword. And Americans love to have buzzwords every 10 years. You can see that. So I'm now telling, so it is a buzzword. Let's see its evolution. I started working in pattern recognition and Indian Statistical Institute back in 75. That time, no book, no journal, nothing. Indian Statistical Institute used to have only journals in statistics and mathematics. And I was belonging to a very third grade department, division, physical and art science. Because every institute will say there are some primary division department and there are some secondary department. So that time we were believing, because that is only for statistics mathematics. And for example, I'm correcting, I'm not the director of Statistics Calcutta. I'm the director of Indian Statistical Institute. It had 10 centers, one director, one dean. They are located in headquarters. So everybody say director ISI Calcutta. No. Calcutta is the headquarters. But it's a director is a philosopher. So we have got 10 centers, including Delhi, Bangalore, Bombay, Chennai, Northeast, etc. So my pattern journey started in 75, 1st March. No book, nothing. Then I moved to Imperial College. I started working image processing because nobody in the world works except two places, University of Maryland, College Park. But I knew that our defense was going wide for image processing. But you cannot work because you don't have computer system. It is just poor country that time. So leaving behind my postdoctoral offer from Purdue, I went for another PhD at Imperial College to do under formal scholarship. But I completed in 2 years and then 2 years. So 70s, that is. Now, when I work in pattern recognition had certain limitation. What? You measurement something and then you make a decision. That is the subject electrical engineers initiated. Not from mathematics, but statistical mathematics jumped after all to develop the subject. But our human mind, they make decision how? They do not measurement and go. So they use their expert knowledge. So expert system came into 80s. That became a buzzword. Medical expert system, lawyer interpretation, everywhere. It's a rule-based system. If A, then B. If, so accordingly, artificial intelligence and machine learning was inefficient. But that time, artificial intelligence could not survive because we didn't have smart computer, we didn't have mass processing power, we didn't have data. Today, we have everything. So after 10 years, again, we had knowledge-based system. India had 5 knowledge-based centers, TIFR, Indian Statistical Institute, Indian Institute of Science, IIT Madras, CDAC Pune. Why knowledge-based system? Because that is advanced version of expert system. And knowledge-based system takes care of domain knowledge, reasoning, learning, etc. So in the process, we have coined new technologies, terminologies. Then after 10 years, America brought the new data mining because of the Genome Project and WWW, which generated heterogeneous data, large data. But if you go to library, not to the Google search, data mining was there in statistical pattern recognition. But that time, we could not do anything because we didn't have data. Now, after 10 years, we talk about big data. That is again ML. USA brought this word. Large volume, large veracity, large your 4 V's basically. Volume, velocity, variety, veracity. So we have this. Now we are talking about after 10 years, data science, deep learning, data science, deep learning, deep learning. Subject will evolve. Why subject is evolving? Because we have demand from society, from the data. And accordingly, our decision-making problems are all changing. Therefore, we are bringing out new terminology. When we started working in patterns in 75, our work was classification, clustering, feature selection. Feature selection was not that important. After 10 years, when we do expert system, we brought those on rule-based learning, rule-based adaptation, if-then rule. Then when we brought KBCS, knowledge-based system, that's a new terminology came for case-based reasoning, approximate reasoning, information retrieval. Then topic like soft computing came out. Then when big data is coming, we are talking about granular mining. So every time after 10 years, the names are coming up and we are bringing out new terminology technology in order to cater to the need of the data and the various kinds of decision-making problems. Now the next question comes, it's all right, but lots of funding is coming up all over the world. But as a researcher, you should keep in mind certain things, that don't jump into the subject abruptly. That means if you want to learn deep learning, you need to know shallow learning. If you want to know shallow learning, you need to know artificial neural networks. If you want to know artificial neural networks, you need to know pattern recognition. That is the mother subject pattern recognition that is getting evolved every decade in order to generate new topics, in order to cater to the need of the society and scientists. So my concern and the little bit caution also to my research scholars who are working in data science, data analytics, which are all different names, big data analytics, applied statistics. In the literature, you'll say similar things in just different names. So when you work on this, don't jump into the subject deep learning, because if you jump into the in deep learning directly without knowing the background, without knowing the subject, right, then I'm very likely within a few hours you will have a disrespect. Oh, this subject is not doing anything. Look at this in 1980s. What happened when we started working in neural networks? That time we was a buzzword in India. Funding coming every conference you go, neural network for chemical, artificial, atmospheric science, wherever you go. In America, everybody thought neural network will solve our all problems. So banking system came forward, medical healthcare system, everybody said, no, prediction. But after 7 to 8 years, we have seen subject has lost interest. And all the journals that came up in my life, I haven't seen a subject which had so many journals within the span of 10 years. They could not publish paper because nobody is working. So I did the transaction on neural networks, #1 journal. They changed the name, neural networks and learning system. They are publishing paper on support vector machine. Neurocomputing, they are publishing paper in other disciplines. Now, because of deep learning, they have again come up. So my dear research scholars, please look into the subject very carefully. Read the background material. Don't jump. You create the science. Unless you increase the science component, you won't be able to do good research, and your subject will die within future. That's my one. And at last, since it is our students, I take this opportunity to say a few words. You may follow, you may like it, you may not just like it. So, first of all, when you join a research scholar as a student, you define your goal first. And you set your target, big target. Target should be big. For example, when you, if you put your target to Delhi, then you get Kanpur on the way. So if you put your target to Kanpur, you may not be able to reach even Allahabad. Now it's called Prayagraj. So you set your target high, define your goal, work very hard. But in the process, don't cheat, don't shortcut, don't plagiarism, don't digit. To do that, and also work in the forefront research. Maybe every 5 to 7 years, you will change the focus of your research. Then you will be the leader. Others will be the follower. Otherwise, you will be always remaining as a follower. And at last, be humble. These are a few words I always tell to my students wherever I go. It's a convocation speech or inaugural speech for my daily student. So if you keep this in your mind, you remember again, for research scholarship, for always in the forefront area. And every 5 to 7 years or 8 years, you change the focus because subject is flourishing every day. New transactions are coming. In my discipline, ITP transaction, when I started working, there were 9 transactions. Now it is 130 transactions. Every day transactions are coming. So you have to cope up. Otherwise, it will be tossing. You better work. Thank you very much. I hope with my few advices, you will keep it in mind. Yeah. Thank you very much. Thank you.
Thank you so much, sir. It's really a great opportunity for all of us to listen to your encouraging words. Now I request all the dignitaries to inaugurate the souvenir of VISHLESHAN 2022. Faculties को बुलाना है. Now I call upon Professor Mamta Janamani ma'am, Research Scholar Coordinator, to propose the vote of thanks.
Dignitaries on the dais, my esteemed colleagues, respected participants from sponsoring agencies, and my dear research scholars. A very good evening to you all. Now we have come to the end of this inaugural function of Doctoral Colloquium. Of course, in the morning we had few technical sessions, but formally we are now inaugurating the function. Now we are really very happy to have Professor S.K. Pal, Padma Shri, and former director of ISI Kolkata with us. And already sir has told many encouraging things. And this is a real good guideline for our students. Sir, we are also waiting eagerly to hear from you as the keynote speech. And we really are thankful to you for sparing your valuable time and be with us. Thank you very much, sir. We also have with us our director, Professor V.K. Tiwari. And to be very frank, we were not even thinking that we'll be able to get him on this occasion. Until the last moment, Professor Maiti was calling and he was in the meeting. He was that busy. And in spite of that, he could come here and join with us. Sir, we are very much thankful to you. Now, without Professor Maiti's support, this function would not have been possible. As he has already told, within 10 days of time, our scholars really did wonderful things. And our faculty members, Professor Jha and others, they supported really very well and got many industry sponsorship. We are really thankful to you, sir, Professor Maiti. And all my faculty colleagues, I am really thankful to all of you for providing support to the scholars. Now, this function is supported by 4 companies, and the companies are Electrometer Corporation, Aarti Steel, Central Coalfield Limited, Iron and Steel Sector, Steel India. We are really thankful to you all And from many of the organizations, I think we have some representatives here. I would like, if all of them are here, I would request all of them to stand up so that we give a standing ovation to them. Professor Krishna Kumar, who is leading our IISc students chapter, he is one of the very important pillar here, and without his timely support and encouragement and guidance, this function would not have been possible. So we are very thankful to you. And we must not forget our research scholars. Of course, this program is organized by them and for them, but they really worked hard, and specifically under the leadership of Ronit and Gaurav. And Ronit is our research scholar representative, and Gaurav is student chapter president of IISc student chapter. A big hand to the team. And finally, I would like to say a few things to our scholars. As our director, Professor Tiwari, Professor Maiti, and Professor Pal has already said, we really have a lot of responsibility. And specifically, when under this new education policy, when one of the major pillars is interdisciplinarity of the subjects and research, we really carry a lot of value. As I would request our guests to go through our posters and all, and of course presentations, I mean the summary of the presentations will be there in our souvenir, and we can, I mean you can find out from every department, I mean the whatever is people are covering, we are somehow contributing to that. So in that sense, we are a truly interdisciplinary department. And this is an opportunity. Our scholars work in different areas. All the scholars. In the morning, Professor Mahanti was telling that you have to go deep, and when you are at the bottom of that depth and you work on your problem, you are alone. And that's specifically true in our field because all of us, being interdisciplinary, work on different areas. And this is an opportunity when we showcase not only showcase our research, we also get to know what the other person is working so that we can work together and do wonder. I once again welcome you to this function and thank you everyone.
Thank you all the dignitaries for your kind words and for motivating us. So let's have a break and proceed to our tea arranged outside. We'll start our next session at 6 p.m. That is keynote speech by Professor Shankar Kumar Pal.
हमारी प्रमुख आवश्यकताएं हैं। इनके बिना जीवन यापन आसान नहीं होता। इनकी कमी से हमारा विकास प्रभावित होता है। झारखंड के दुर्गम क्षेत्रों में बसने वाले गांवों में भी यह सुविधा सुलभ नहीं है। सीसीएल के खनन क्षेत्रों के आसपास भी ऐसे कई गांव हैं। अतः सीसीएल ने कोयला मंत्रालय के मार्गदर्शन में अपनी CSR कार्यक्रम के अंतर्गत सन 2020 में ऐसे गांवों को सोलर ऊर्जा से हमारी प्रमुख आवश्यकताएं हैं। इनके बिना जीवन यापन आसान नहीं होता। इनकी कमी से हमारा विकास पेयजल तथा रोशनी पहुंचाने की पहल की है और चंद महीनों में ही यहाँ के लोगों के चेहरों पर आ गई अनूठी चमक।
इसमें लाइट का बहुत दिक्कत था हमारे गांव में, तो 1500 सोलर पैनल के साथ पंखा और बैटरी और 2 बल्ब ग्रामीणों को दिया गया है।
दरअसल चतरा जिले के टंडवा प्रखंड में स्थित सीसीएल के आम्रपाली, OCP तथा चंद्रगुप्त परियोजना क्षेत्रों में परियोजना प्रभावित कई गांव हैं। इनमें से होन्हे, कुमरंग खुर्द, कोयाड बिरहोर टोला, कुमरंग कलां, बिंगलाट तथा उस्सू गांवों को रोशन करने के लिए कुल 1500 घरेलू सौर इकाइयों की स्थापना की गई है। प्रत्येक सोलर पैनल, बैटरी तथा कंट्रोल यूनिट के द्वारा ग्रामीणों को एक टेबल फैन, 2 LED बल्ब तथा एक मोबाइल चार्जिंग पॉइंट की सुविधा मिल गई है। इससे न सिर्फ उन गांवों के बच्चों की पढ़ाई निर्बाध रूप से हो पा रही है, वरन घर के अन्य कामकाज भी सुचारू रूप से संपादित हो पा रहे हैं। इन सोलर यूनिटों का रखरखाव आसान है, फिर भी ग्रामीणों को इसके लिए प्रशिक्षित भी किया गया है। दूसरी ओर लातेहार तथा चतरा जिले के परियोजना प्रभावित कुल 21 गांवों में 41 डीप बोरवेल करवाए गए हैं। इनमें शुद्ध पेयजल की सहज आपूर्ति के लिए सौर ऊर्जा चालित पंप युक्त ओवरहेड टैंक भी लगवाए गए हैं। सीसीएल अपनी परियोजना क्षेत्र के गांवों के विकास के लिए सदैव तत्पर है। पानी बिजली मुफ्त मिला, ग्रामीणों का मुखमंडल खिला।
झारखंड की खेल प्रतिभाओं को उचित प्रशिक्षण प्रदान कर उनके पंखों को उड़ान देने के लिए सीसीएल ने कोयला मंत्रालय के मार्गदर्शन में अपने CSR कार्यक्रम के अंतर्गत सन 2015 में राज्य सरकार के साथ मिलकर कोटवार रांची स्थित खेलगांव परिसर में खेल अकादमी एवं इसके संचालन के लिए झारखंड स्टेट स्पोर्ट्स प्रमोशन सोसाइटी की स्थापना की, जिसे खेलो इंडिया डेवलपमेंट प्रोग्राम के तहत मान्यता प्राप्त है। झारखंड के 24 जिलों में ट्रायल द्वारा 8 से 12 वर्ष के प्रतिभावान बच्चों का चयन कर उन्हें मुफ्त आवासीय शिक्षा, प्रशिक्षण एवं पौष्टिक भोजन, मेडिकल सुविधा प्रदान की जाती है। चयनित प्रशिक्षुओं में 96% अनुसूचित जाति, जनजाति एवं पिछड़े वर्ग से आते हैं। एकेडमी में 437 कैडेट्स हैं, जिन्हें पढ़ाई एवं प्रशिक्षण में सहयोग के लिए टैबलेट भी दिए गए हैं। एकेडमी के कैडेट्स जैसे फ्लोरेंस बर्ला, दीपक टोप्पो, चंचला कुमारी एवं कई अन्य ने अंतर्राष्ट्रीय एवं राष्ट्रीय स्तर पर अभूतपूर्व प्रदर्शन कर राज्य एवं देश का नाम रोशन किया है।
मेरा नाम निसीमा कुमारी है। मैं काके प्रखंड की रहने वाली हूँ। मैं फुटबॉल खेलती हूँ। मेरा सिलेक्शन फीफा वर्ल्ड कप अंडर 17 इंडिया कैंप के लिए हुआ है।
यहाँ के कैडेट्स ने अंतर्राष्ट्रीय, राष्ट्रीय, राज्य तथा जिला स्तरों को मिलाकर अब तक 845 पदक जीते हैं, जबकि एकेडमी में मात्र 10 खेल विधाओं को ही सम्मिलित किया गया है। शीघ्र ही 5 अन्य खेल विधाओं को भी इसमें सम्मिलित किया जाएगा। इन प्रयासों को प्रथम नेशनल सीएसआर अवार्ड एवं राष्ट्रीय स्तर पर व्यापक सराहना भी मिली है।
मेरा नाम सबीना कुमारी है। मैं JSSPS में 2018 से रह रही हूँ। मैं अभी 73 नेशनल ट्रैक साइकिलिंग चैंपियनशिप में भाग ली थी। मैं उसमें एक गोल्ड और एक ब्रॉन्ज मेडल जीती।
उपलब्धियों ने हम में और ऊर्जा भरी है और राज्य की खेल प्रतिभाओं के लिए एक आदर्श भविष्य निश्चय ही गढ़ेंगे।
और प्रकाश हमारी प्रमुख आवश्यकताएं हैं। इनके बिना जीवन यापन आसान नहीं होता। इनकी कमी से हमारा विकास प्रभावित होता है। झारखंड के दुर्गम क्षेत्रों में बसने वाले गांवों में भी यह सुविधा सुलभ नहीं है। सीसीएल के खनन क्षेत्रों के आसपास भी ऐसे कई गांव हैं। अतः सीसीएल ने कोयला मंत्रालय के मार्गदर्शन में अपने सीएसआर कार्यक्रम के अंतर्गत सन 2020 में ऐसे गांवों को सोलर ऊर्जा से पेयजल तथा रोशनी पहुंचाने की पहल की है और चंद महीनों में ही यहाँ के लोगों के चेहरों पर आ गई अनूठी चमक।
इसमें लाइट का बहुत दिक्कत था हमारे गांव में, तो 1500 सोलर पैनल के साथ पंखा और बैटरी और 2 बल्ब ग्रामीणों को दिया गया है।
दरअसल चतरा जिले के टंडवा प्रखंड में स्थित सीसीएल के आम्रपाली, ओसीपी तथा चंद्रगुप्त परियोजना क्षेत्रों में परियोजना प्रभावित कई गांव हैं। इनमें से होन्हे, कुमरंग खुर्द, कोयाड बिरहोर टोला, कुमरंग कला, बिंगलाट तथा उस्सू गांवों को रोशन करने के लिए कुल 1500 घरेलू सौर इकाइयों की स्थापना की गई है। प्रत्येक सोलर पैनल, बैटरी तथा कंट्रोल यूनिट के द्वारा ग्रामीणों को एक टेबल फैन, 2 एलईडी बल्ब तथा एक मोबाइल चार्जिंग पॉइंट की सुविधा मिल गई है। इससे न सिर्फ उन गांवों के बच्चों की पढ़ाई निर्बाध रूप से हो पा रही है, वरन घर के अन्य कामकाज भी सुचारू रूप से संपादित हो पा रहे हैं। इन सोलर यूनिटों का रखरखाव आसान है, फिर भी ग्रामीणों को इसके लिए प्रशिक्षित भी किया गया है। दूसरी ओर लातेहार तथा चतरा जिले के परियोजना प्रभावित कुल 21 गांवों में 41 डीप बोरवेल करवाए गए हैं। इनमें शुद्ध पेयजल की सहज आपूर्ति के लिए सौर ऊर्जा चालित पंप युक्त ओवरहेड टैंक भी लगवाए गए हैं। सीसीएल अपनी परियोजना क्षेत्र के गांवों के विकास के लिए सदैव तत्पर है। पानी बिजली मुफ्त मिला, ग्रामीणों का मुखमंडल खिला।
झारखंड की खेल प्रतिभाओं को उचित प्रशिक्षण प्रदान कर उनके पंखों को उड़ान देने के लिए सीसीएल ने कोयला मंत्रालय के मार्गदर्शन में अपने सीएसआर कार्यक्रम के अंतर्गत सन 2015 में राज्य सरकार के साथ मिलकर फुटबॉल रांची स्थित खेलगांव परिसर में खेल अकादमी एवं इसके संचालन के लिए झारखंड स्टेट स्पोर्ट्स प्रमोशन सोसाइटी की स्थापना की, जिसे खेलो इंडिया डेवलपमेंट प्रोग्राम के तहत मान्यता प्राप्त है। झारखंड के 24 जिलों में ट्रायल द्वारा 8 से 12 वर्ष के प्रतिभावान बच्चों का चयन कर उन्हें मुफ्त आवासीय शिक्षा, प्रशिक्षण एवं पौष्टिक भोजन, मेडिकल सुविधा प्रदान की जाती है। चयनित प्रशिक्षुओं में 96% अनुसूचित जाति, जनजाति एवं पिछड़े वर्ग से आते हैं। एकेडमी में 437 कैडेट्स हैं, जिन्हें पढ़ाई एवं प्रशिक्षण में सहयोग के लिए टैबलेट भी दिए गए हैं। एकेडमी के कैडेट्स जैसे फ्लोरेंस बर्ला, दीपक टोप्पो, चंचला कुमारी एवं कई अन्य ने अंतर्राष्ट्रीय एवं राष्ट्रीय स्तर पर अभूतपूर्व प्रदर्शन कर राज्य एवं देश का नाम रोशन किया है।
मेरा नाम निसीमा कुमारी है। मैं काके प्रखंड की रहने वाली हूँ। मैं फुटबॉल खेलती हूँ। मेरा सिलेक्शन फीफा वर्ल्ड कप अंडर 17 इंडिया कैंप के लिए हुआ है।
यहाँ के कैडेट्स ने अंतर्राष्ट्रीय, राष्ट्रीय, राज्य तथा जिला स्तरों को मिलाकर अब तक 845 पदक जीते हैं, जबकि एकेडमी में मात्र 10 खेल विधाओं को ही सम्मिलित किया गया है। शीघ्र ही 5 अन्य खेल विधाओं को भी इसमें सम्मिलित किया जाएगा। इन प्रयासों को प्रथम नेशनल सीएसआर अवार्ड एवं राष्ट्रीय स्तर पर व्यापक सराहना भी मिली है।
मेरा नाम सबीना कुमारी है। मैं जेएसएसपीएस में 2018 से रह रही हूँ। मैं अभी 73 नेशनल ट्रैक साइकिलिंग चैंपियनशिप में भाग ली थी। मैं उसमें 1 गोल्ड और 1 ब्रॉन्ज मेडल जीती।
उपलब्धियों ने हमें और ऊर्जा भरी है और राज्य की खेल प्रतिभाओं के लिए एक आदर्श भविष्य निश्चय ही गढ़ेंगे।
Is there any price distribution now?
Yes, yes.
But time 10 minutes late here?
5 minutes.
5 minutes. So how many prizes?
6.
6 prizes.
5 minutes.
Sir, there is a prize distribution to the poster winner and presentation winner or paper presentation, oral presentation winner. So these 5 minutes of distribution after the
So before moving to next section, I'm delighted to announce that panel of expert judges have identified best poster presentation and best oral paper presentation. So I request our chief guest, Padma Shri Professor Shankar Kumar Pal, to award the certificates to the winners of poster and oral paper presentation. So the third prize in poster paper presentation goes to Akhilesh Hothur.
Yes, sir.
What's happened?
Because he is
Share same name.
Oh.
Come.
So it is a. Oh. Thank you very much.
Second prize goes to in poster presentation Biswajit Kar. And first prize in poster presentation goes to Subhadeep Vardhaman. Subhadeep Vardhan.
Where is Subhadeep?
He's not here.
By this time absent. Okay. This is Subhadeep.
Come here. No problem.
Boxy Subhadeep. How is he getting first prize?
So in oral paper presentation, third prize goes to Imran Haider. He is also not here. And second prize goes to Sati Patnaik. And first prize in paper presentation goes to Anand Ranjan.
Now probably Sati,
Professor Pal presentation. Yes. Okay. So you just said Professor Ray will introduce, and then
take this one.
We will be now starting our second keynote session. For this, I request Professor Ray to introduce our keynote speaker.
so very good evening to all of you. You are already, informed that our chief guest is Padma Shri Dr. Shankar Kumar Pal. And frankly speaking, he doesn't need any introduction. He is a versatile personality, and we are very glad, sir, that you have accepted our invitation to grace this occasion. And I am sure that with his presence and your interactions with him, we'll all be benefited. Benefited in the sense that we'll enhance our knowledge, and definitely as a researcher, you will come to know that the path you are following, whether it is a right path or you need some, the change in your direction. And particularly, you know that being a researcher, your problem is a totally unstructured problem. Unstructured problem. And ultimately you have to produce a thesis. Okay. So while you write the thesis, that means there could be some antithesis. Okay, while you propose a thesis, then antithesis,
then synthesis, then again it will be questioned through dialectic process. It has been going on since the start of the human civilization. Okay, so humans are different from, say, is a different species from all other species in the animal kingdom, isn't it? So it's a mystery. So one of the reasons that why we are different from all others in the animal kingdom, that is, we can change ourselves. Okay, so now, here is one personality. We're very lucky that he has readily, agreed to our request, to our invitation. So, sir, we are very happy. Now, I'll just, briefly, I will tell you about his achievement, about his biography. You know what is the meaning of biography? Professor Shankar Kumar Pal, born 1950. I feel like reading each and every sentence, every word as written. Okay. Born 1950, is a computer scientist and former director of Indian Statistical Institute, Kolkata. And you possibly know the history of Indian Statistical Institute. You must have heard the name of Prashant Mahalanavish. Okay, as a researcher, you must know. Okay, so he is a computer scientist with an international reputation on fuzzy neural network, soft computing, and machine intelligence. He founded the Machine Intelligence Unit in 1993 and the Center for Soft Computing Research, a national facility, in 2004, both at the ISI. He is the founder president of the Indian National Academy of Engineering, Kolkata chapter. He is a recipient of S.S. Bhatnagar Prize in 1990. He was awarded Padma Shri in Science and Engineering on 5th April 2013 by the President of India, Pranab Mukherjee, in recognition of his work in machine intelligence. Professor Pal, Shanti Swarup Bhatnagar awardee, as you know, that is the most coveted award in science in India. The 1999 G.D. Birla Award, 1998 Om Bhasin Award from the Prime Minister of India, 1993 Jawaharlal Nehru Fellowship, 2000 Khawarizmi International Award from the President of Iran, 2001 FICCI Award, 1993 Vikram Sarabhai Research Award, 1993 NASA Tech Briefs Award, USA, 1994 IEEE Transaction in Neural Networks Outstanding Paper Award, 1995 NASA Patent Application Award, 1997 IETE RL WADA Gold Medal, the 2001 INSA SH Jahir Medal, 2005 and 6 Indian Science Congress PC Maulanavish Birth Centenary Gold Medal from Prime Minister of India for lifetime achievement, 2007 Jeshi Bose Fellowships of the Government of India, 2008 Vigyan Ratna Award from Science and Culture Organization, 2013 Indian National Academy of Engineering Chair Professor, 2015 INAE SN Mitsu Award, 2017 INSA Jawaharlal Nehru Birth Centenary Lecture Award, and many other awards. So here is a person who is awarded, and we get recognized. Getting my point? It's like, we must recognize such a person. Okay, so sir, we are, the entire country is proud of you, and we are very happy that that you are here to interact with our research scholars.
Thank you very much.
Sir, please.
This is the unknown.
Yes, sir, already answered.
Okay, so who control?
Oh, yeah.
You will control.
So, projector income.
Good afternoon. So this is the talk. What I told this morning, this is the afternoon during the inauguration event. That was an abstract of this talk. So now I will go in detail a little bit so that you can see the subject growth of the just subject starting from pattern recognition. That's why I chose the topic. So yes, huh? Pointer.
Yes, sir.
No pattern? Okay. Huh? Oh.
This is the one.
Oh, this is the one. Huh? Sorry. Yes. So pattern recognition, I will start. Machine intelligence to data science. And I will explain what I will say is my experience journey in over 45 plus years. Growth of this discipline. So as I mentioned this afternoon, this is basically a buzzword going on, and it is highly multidisciplinary. Comprises computer science, doubly information technology, information science, statistics, mathematics, and engineering domains, wherever you are going to apply it. Therefore, it has too much job prospect, at least today. Good prospects, academia, R&D, as well as in industry. That's why everywhere you see that different kinds of courses are just coming up in IITs and just private organizations, wherever. Recently, I saw in the Facebook, IIT Delhi has introduced a basic program in machine intelligence and data science. They do not call artificial intelligence. Now, this is the content. I will explain. I joined my institute in 1975. So then the facilitate and uncertainty model is just in a short expert system, 1980, knowledge-based system, relevance of subcomputing and machine intelligence, as well as emergence of new technology, new discipline, data mining, relevance of granular computing, big data. Example, I will explain something. And then last part is very important, deep learning. Because today, any data science, any machine learning, any data analytics you do, always people will ask about deep learning, whether they understand or not. So you have to be also very careful about what is the difference between deep learning and the conventional learning. I will call it shallow learning. The evolution of data science and the certain concerns. Now, I joined my institute on 1st March 1975 as CSI Senior Research Fellow. At that time, my fellowship was rupees 500 rupees. And I used to get, I think, 1,000 something for contingency grant. And my supervisor gave this area, pattern recognition and FISA. No institute in India used to teach pattern recognition. There is no course, no journal, no book. So in our library, I had only these two books. That is edited by Professor K.S. Fu, who is the founder, in my opinion, the father of pattern recognition from Purdue. He has a collection of papers edited. And this was a PhD, the DSc thesis in my library I had, very difficult to understand. Decision making in Macmillan Place. And this book was purchased at the end of my dissertation work from our library. So until I got these two books. And this is the book I bought from my research fellowship grant. This was a conference edited book between NATO Advanced Study. And these are the two libraries journals I collected from my parent institute, Institute of Radiation and Electronics, Calcutta. My ISI did not subscribe any of those electrical science journals at that time. So this was my resource only to editor at this book. Now, if you look at this pattern recognition, that time, as per the Professor K's full idea, I'm just still following today also. So basically, and then short, it's a 3 blocks: measurement, feature, decision. Then any pattern, whether it is a visual pattern, whether it is a linguistic pattern, whether it is a audio pattern, whatever you take, you start an extra measurement, and measurement could be numerical, measurement could be non-numerical. So if it is a numerical, you represent as a vector. Then out of those, you will see that all measurements may not be equally important. So you need to throw out something that's called feature extraction. In the process, you reduce the number of features so that you reduce the cost. And at the same time, you increase the distance between classes and you reduce the distance within classes. Heterogeneity, homogeneity. That's the main thing. And make a decision. But here, uncertainty arises from deficiency of information. Deficiency may come from incompleteness, impreciseness, ill-defined, not so many reasons. So once you have uncertainty, it will propagate. So my concern, our concern is to reduce the uncertainty, to check the uncertainty. We cannot remove. We can reduce. We can manage uncertainty. That's why handling uncertainty has become a challenging issue. Wherever you have a data, whether it is a low size data, medium size data, large size data. And if you consider image as an object, then I call it is a measurement, because you need to do before decision some kinds of processing, enhancement, edge detection, segmentation, all those things. So it becomes a low-level vision, mid-level vision, high-level vision. So I consider image processing as part of feature, part of pattern recognition, only because it is a image. So by its own right, image processing became a new subject around 80s. So if you look at this, there are 2 concepts basically: classification and clustering. Classification, what is the challenge? You have the sample data, the incomplete information is given to you. And the task is to, the challenge is to estimate the unknown region of the pattern space based on the sample data. Whereas in the case of clustering, sorry. Whereas in case of clustering, you are given the entire data. And the challenge is to partition it into meaningful homogeneous region. But you are not given the number of classes. You do not know what those classes are representing. So here look at it carefully. You are given only a sample data of known classes. But your challenge is to estimate the unknown regions. So it is called abstraction followed by generalization. First you abstract the information from the incomplete information, then you make it generalized. So your performance should be very good both in abstraction and generalization. If you more abstraction, then it will be overlearning. And it is called supervised learning, and it's called unsupervised learning. So that's the learning concept came from that time. We used to write on a paper supervised, unsupervised learning. But that time it was not concept of any machine learning or deep learning. Just used to learn the parameter of straight line, hyperbola, your just covariance matrix, and so on from the data. But whether it is supervised task or unsupervised task. Then, when the data is there, what the challenge is? Overlapping cluster. That's the challenging area. When the clusters are disjoint, no problem. Very simple linear boundary, you can do it. But life is not that easy. You come overlapping class, region concept. That can be dealt with 2 approaches. Usually, conventional is probability. That is assuming that the patterns follow some distribution. On the other hand, when I joined, that was a new topic. It's called, this is a parametric, because you need to know the parameter of the distribution. But when we do not have the sufficient number of data, then we went for the new technology we started developing based on fuzzy set theory, or it's called based on membership. Here, probability density function depends on the number of occurrence of an event. Here, membership function doesn't depend on the number of occurrence of an event. It depends on the concept of similarity of an object with an imprecise concept. Now, what is fuzzy set theory? You have an idea, or just I will explain one slide. Okay, so suppose this is a 5 o'clock. You are asked to meet your friend at some point at 5 o'clock. So 5 o'clock means it is basically quiz set. At 5 o'clock, 1, 0. My lecture will start at 4 o'clock. That means it is a quiz set, either 4 or not. So characteristic value, function value has 1 at 5, other 0. It is a quiz set. But in real life problem, 5 o'clock means you may think that it is a 5 to 5, 5 past 5, 10 to 5, 10 past 5. Just like my classes also. Many people have come before, that 1 or 2% may come later on also. So in reality, it becomes a function like this. That is 5 to 5, 5 past 5, depending. So it is what is called fuzzy set. In reality, it becomes a fuzzy set. Here, any value before 5 also, 5 is a matter of degree. Any value after 5 also, it's a matter of degree. So it's called, originally it was quiz set, this is fuzzy set. So fuzzy sets are nothing but membership function. Now if you go to Germany, 10 times at 5 o'clock means very sharp. But in my country, if you say Colloquium, for example, in the middle of the, but 10 times at 5 o'clock, it may not be sharp at 5. So it depends on the context. Similarly, tall men in Germany or Hungary, tall men in my country, they have different membership. It is context dependent. So fuzzy sets are nothing but membership functions. Membership functions are context dependent, and fuzzy sets are elastic, that you can play with it. R sets are not elastic. That's why it has characteristic of flexibility. And I have explained the difference between probability and membership function. There are ample of examples I can give. One. So concept of flexibility and uncertainty capability analysis for overlapping data, this becomes very one of the characteristics of fuzzy set theory in pattern recognition problem. So when we wrote papers back in 77, 78, our concept was like this. And another concept is a pattern, in case of clustering, pattern can go to more than one process. So what are the challenge that time? Bringing out the root relation between abstract concept of fuzzy set and the task of pattern and English policy. Because Lathi Jade, when he wrote the paper on pattern recognition, fuzzy set theory, his subject got more prominent by control engineer. But his first paper he wrote in pattern recognition. Bellman, Kalaba, Jade, if you look at this engineering application, while he was visiting Stanford. It is a short paper. If you have the opportunity, you read from the abstraction and generalization. So here is the concept of notion of multi-class belonging. And in case of image, if it is a sinusoidal variation, a grayscale image sinusoidal variation, we have the concept of boundary, region, edge, corner, relation. They do not lend themselves to precise definition. That's why fuzzy set theory becomes so important. And this was our first paper in just speech recognition from Indian Statistical Institute. I took a transition systems and stability. And when I was electing at Imperial College, my first paper in electronics letter, that is a very prestigious journal, IW, for sensing image processing. Now, these are so many examples. We have worked in India and abroad because speech is when you utter the same word in the morning or evening, or in a good mood or in a bad mood, the frequency changes. So we do not say that this is because of the randomness. We say it is because of your habit of speed or your mood. Similarly, medical image, remote sensing image, natural language processing, etc. Then in 80s, scientists thought, hey, attention is not enough to make human-like decision making. Because we do not make decision by computing, by making some measurement, then we just throwing out some information, extract the features, and then we make the classification. We use our experience. So here comes the concept of expert system to address the limitation of pattern recognition. And basically it's a rule-based, if-then rule. Probability theory can come into the rule, fuzzy logic can come into the rule. Then rough set theory also became a hot topic. The subject was explained by an applied mathematician from Poland, Warsaw. He was fuzzy logic guy, was an electrical engineer. He is also basically an electrical engineer, but he is an applied mathematician. So uncertainty modeling. So then the concept of rule learning, rule adaptation, all those terms came up. And here also, Rhapsody is used for uncertainty modeling in if-then rule. Fuzzy logic is also used for modeling uncertainty. Probability theory is also modeling for uncertainty. And that gave the rise of that time artificial intelligence and machine learning in 80s. That time I was busy in Berkeley. So learning and machine learning is learning patterns from examples of sample data. This is in one line. What is machine learning? Learning the patterns from a given set of data. Learning the pattern, that's all. So, and if you look at this machine learning is basically based on the realization of Alan Turing in 1947. He gave a talk in London Mathematical Society. You can get it in Google. He said, we need a machine that can learn from the environment. And that was the envision of intelligent machine. So he told it in 1937. So the machine learning concept is not new, but it came in 80s. But lack of adequate data and the processing power storage, the subject could not survive. In my institute, we initiated something, artificial intelligence. When I returned from Berkeley, 86, but after 2 to 3 years, we did not get any student. And also the job market was not there at that time. That's why subject could not survive that time. Then after 10 years, knowledge-based system, which is basically Japanese brain. It's an advanced form. What is the difference? Use more domain knowledge base in reasoning and derive new knowledge to solve problems. And incorporate higher level knowledge like semantic, pragmatic, etc. in the rule base to make the system more intelligent. And the new terms like knowledge representation, case-based reasoning, the way medical doctors or law interpreters take decisions. They have previous cases. Based on the cases, you get a new case, you make the adaptation, you get the learning, you change. Information retrieval, rule learning, and India had 5 KB center I mentioned in the afternoon on END funds. Then emergence of soft computing came in that time because it has characteristics like flexibility, tractability, low-cost solution, human-like decision. And if you look at this subcomputing takes care of uncertainty modeling, reasoning, learning, speed, searching. So any design engineer would love to have all those characteristics in his or her system. The system has to have the adaptivity capacity. System has to have the learning capability. System has to have the first decision making, reasoning, learning, etc. So in a nutshell, what is soft computing? If we mention the one, suppose generally, if you know parallel parking, you know no parallel parking. You know parallel parking in a metro city, you cannot park the parallel this way. You have to park between 2 cars. And in America, if you learn driving, I learned driving, I failed 3 times. So just for first time, they give the parallel parking. Very difficult task. So if you know driving, it's just few minutes because you are not asked to solve the problem correctly, precisely. But if I ask you to put the car exactly 6 inches from the footpath or car and keep your car between exactly 2, then it will take hours of manually. So your precise, next question comes, high precision carries high cost and high precision is not meaningful also sometimes. And this is the crux of soft computing. So basically definition is to exploit the tolerance for imprecision, uncertainty, approximate reasoning, and partial truth to achieve tractability, robustness, low solution cost, of course. By the way, now parallel parking is not a must because my son took that from battery and they said no, it is not a mandate, parallel parking. Because many people are failing on this water, but actually you need also car to drive there. Now let's come. So what are the roles of soft computing? Basically 3 components. Fuzzy logic, algorithm for dealing imprecision uncertainty, neural computation, machinery for learning and curve fitting, genetic algorithm for search chain optimization. And I brought new subject 1 that was not the previous is the definition from our group, rough set theory, which provides handling uncertainty from granular. There is a difference between 2. Here, uncertainty is coming from overlapping of the concept, overlapping of the classes, overlapping of the regions. Whereas here, uncertainty is coming from granularity in the domain. I will just explain later on. So within those soft computing, what is the beauty? They work together. That means they do not fight with each other, rather they help each other. Because this has some limitation. And those limitations can be overcome by using genetic. Neural computation has some limitation because you do not know how to determine the number of nodes and layers. Here comes the significance of neural genetic. So there have been several papers published in 80s. And it was argued that in soft computing, rather than the hard computing, which should be treated as the modern AI. Now, this is an example of I've given synergistic integration of soft computing. That was one of the challenges that time to publish paper. See, publishing paper gives you the also feeling of the for research area. If you attempt to publish in a best quality journal, then you will see that what kind of demand they are expecting from you. So this was the one. Exploit the merits of individual tools. So let us consider to achieve application specific. What is application specific? Suppose you are integrating neural network and fuzzy set, you have to see that you are getting more benefit in terms of application wise, what you could not get by using those tools alone individually. Here comes the challenge. So here neurophagy becomes so popular because you have neurophagy popular, your vacuum cleaner, tube, your television, washing machine. Why? Because neural network has capability of generating nonlinear boundary. Fuzzy logic or fuzzy sets has capability of uncertainty modeling. So if you can make judicious integration, then you can solve many problems. You can make it tractable. For example, so what is neural net characteristic? Adaptivity, speed, fault tolerance, ruggedness, optimality. And as I mentioned, adaptivity to change in environment, new data information, speed via massive parallelism, fault tolerant to missing or confusing noise data, ruggedness to failure of component. That means even if one component of neural network gets down, still the system works, just like human brain. If you get a heart, you just do not die. It's called gracefully degradation. Optimality as because. And when we integrate and look at this, basically neural network learns from examples. That if you give if A then B, if X then Y, if C do, then it can learn the relation between A and Y, the input and output, whatever computation it is, in the form of its neural network parameter. So it extracts the input-output relation, however, complicated into network parameter. So this is a good candidate for machine learning. That's why machine learning becomes so popular. It is after neural network revived in 80s, late 80s. So I'll see that one integration we made of our lab. This is a multi-layer perceptor we bought from the market. It has the characteristic like it can accept only 0, 1 and it can output also 0, 1. But we said, no, in real life problem, you cannot be always 0, 1. It could be linguistic, it could be numerical also. Similarly, boundary also, it cannot be 0, 1 decision. So we incorporated fuzzy logic in terms of low, medium, high, output also fuzzy. And during back propagation of error for using gradient descent search, we use the membership values of those classes in order to change, so that my boundary changes slowly. Otherwise, boundary will be abruptly adjusted. So I get input, output, and during training, I use fuzzy set. And that we have made the fusion of nonlinear boundary capability generating of neural network and uncertainty modeling capability. So it handles efficiency input, handles uncertainty arising from overlay classes, back propagation errors are assigned appropriate weightage depending on the mu values corresponding one, and can handle linguistic input in addition to one. And this paper received 1994 outstanding paper about that time. This is a very benchmark paper, highly cited paper. And future neurofuzzy models are based on this model. It's a derivative. Now, accordingly, we defined in our institute machine intelligence, 1993. Machine intelligence unit. What is this one? It's a core concept of grouping all these advanced tools with the basic task of pattern search and learning. All these tools, these are not exhausted. Depending on the time and one, you can enlist this time. As I said, rough set, probabilistic reasoning, approximate reasoning, case-based. Previously, we should know only just probabilistic reasoning. Then we have adopted approximate reasoning, case-based. Integration and any intelligent autonomous systems are nothing but physical embodiments of machine intelligence. Now, one may note, though short computing term was coined by Professor Zadeh in 1994, but if you look at this, the synergistic integration we already started 4 years before, because that the paper got 92 publication. So 92 publication is that time. You have to start at least communicate 2 years before that time. That time we did not have the internet facility. So all over the world, one of few groups, including my ISI, we started working back in 88, 89. So that's why I got the paper published in 92 and council. But he coined the term short computing in 1994 in different challenge synergistic integration and technology. This many people do not know. They do this one. So because America loves to give new names always. And we have in our institute these centers of community research, national facility in 2004. Now in 2010, around after 10 years, data mining. Around 2000, data mining became a buzzword because of internet. They are generating too much heterogeneous data, any kind of heterogeneous, and genome project. So large and heterogeneous data. What do you mean by heterogeneous data? For example, if you go to healthcare data, if you go to a medical hospital, what you get the what? You can numerical, text, yes, tick, tack, yes, no, color, shape, etc. So this is what's called heterogeneous data. Previously, our pattern theory, we assumed it is numerical. And also we assume the number of samples is much larger than the number of features. But now today, your number of patterns is very small because you go to hospital only when you are sick. The number of patterns is small, but number of features is there. For example, genome data. If you want to say gene selection, your number of persons, 70, 80, 100. If you just download the data, you see, but number of features is few thousands. So it becomes topsy-turvy. So statistical decision making, what you have developed in 8 days, you cannot use it, you use them. It's called large sample It's called small sample, large feature problem in statistical decision making. So therefore it demands new algorithms. And data mining plus knowledge interpretation is called knowledge discovery. So data mining in one sentence line, if you define from pattern point of view, it can be defined from statistical point of view, it can be defined from DBMS point. But from pattern point of view, pattern and machine learning principles when applied to very largely both size and dimension database. And data mining plus knowledge interpretation is called knowledge discovery. So it is a new terminology came at that time. And it's a process of identifying valid, novel, potentially useful, and ultimately understandable patterns in data. So when you are talking about data mining, the new technology came out. It's called granular. I told you that every areas you are giving new subjects according to new technologies are also evolved. So what is granular computing? It's a nature-inspired information processing paradigm with the basic element called granules. What is granules? Granules are collection of indistinct objects. That means when, for example, I'm just looking at the class, I'm just seeing that some boys here, some girls here. So this is my granule. Without looking at the individual you people, I can see that at a glance, and I'm just seeing that here nobody is there, and some here senior person is sitting here. So this information, this kind of at an abstract of information, instead of going by the point by point, that means it's a kind of clustering also you can think. It's one way of forming clustering. So once you make a clustering, that can also give the concept of granule. Granule can be obtained in many other ways. I'm just giving a simple example. Similarly, if you just look at a scene, what you see, road, water body, sky, vegetation. So these are called my granule. So I do not bother about the individual pixel wise information. So basically, granule means it's a compressed information. Out of the entire scene, you have taken only. So since you are playing with the information compression, you gain in computation. So it is suitable for mining algorithm. Based on the base, my group at ISI, we started working about just 10 to 12 years back. Just the basic concept that because in reality, I do not need perfectness. In many problems, I do not need the precise definition of a boundary. So instead of that, I can reduce the computation time. And if you need preciseness, you start from there. So instead of starting from very beginning, losing time, you just start from here. So then rough set came in the picture. Just in one slide, this is based on the concept of granules. So this is an information access. What is that? Yeah. So this is my x-axis, y-axis. Now I define on this based on relations of granules. That means here no other elements can be discriminated from x, given this x-axis, y-axis. And this, if you look at this, different granules have different sizes. These are created based on the x-axis, y-axis. If you add one more axis here, z-axis, then the granular size will be different. So granule means clump of objects which you cannot discriminate with the help of certain kind of properties called similarity, proximity, functionality, and so on. So these are my granules. And within this granule, I define a set. Now I ask you a question, what are the granules that will belong to this set? Now you can see that I do not have unique reply. But what I can reply? Well, it has got certain granules are marked by the yellow line, which definitely belong. On the other hand, it has certain granules as marked by the orange line, which includes these definitely belong granules also, and some granules which are possibly belong. So I can call these granules as marked by the yellow line, which are definitely belonging called lower approximation of this set defined over this granulated domain. And this orange granules upper approximation of this set defined over. So in other words, given a set on a granulated domain, I can approximate from inner side, from outer side, or from lower side, or from upper side, with the help of two approximations for lower and upper. And why? And if you have lower equal to upper means there is no granularity, because these possible regions are coming only because of this granularity. For example, if I take an image, when I discretize into x-axis, y-axis, and the level, intensity level, then I introduce granularity, because it's a loss of information. If I do not integrate, there is just no the loss of information. Here also, this is the meaning of the example set. Here also. So anyway, so now I'm just anyway, so look at this. So therefore, given a granulated domain, if I define a set, set is crisp. Set means crisp region, concept, whatever thing. Then I can approximate this set in terms of two approximations from inner side and upper side, in the name of definitely belonging, in the name of definitely and possibly. And my uncertainty is coming from possibly belonging. So given this granulated domain set and given this approximation, this vague definition of the set in terms of lower and upper, that signifies the incompleteness of knowledge about the universe. Therefore, if I want to make a decision, I will minimize this incompleteness in the name of entropy, in the name of effect. So it has. I picked up the subject when I was working at NASA. I don't know how many of know. NASA does not always do the research in the space. They also provide funds to universities, small-scale industries, to research scholars, to interns. They used to come and work. So that time, East European countries, they had problems. So they used to all come to America. And those East Europeans are very good in mathematics. So they used to come for internship. So when you come to internship 2 to 3 months, you have to deliver talk, because you're paid. So I used to listen to them, but I didn't have knowledge. I had only knowledge about uncertainty modeling using 563. So that time I realized that you can use the concept of lower and upper, because they were using for expert system to encode the information about the expert in terms of lower and upper, which is possible. And I thought that granule, that time I could not give the name, but I can see the granule I can use for reducing the computation time. And here comes the significance. Again, I'm putting this one in front of you. What is a granule? Clump of indiscernible entities drawn together with respect to given entity. And the similarity could be in terms of similarity, proximity, function. Because if you go to genome project data, it's in terms of functionality. If you go to vector space, you just compute in terms of similarity. So it has got so many applications. I will explain one example, only video of that. It has got microarrays and bioinformatics, link prediction problem in social network, neural network learning parameters one. And if you look at these are all big data. So after 10 years of data mining, big data became a buzzword. And here it is characterized by 4 V's: large volume, large velocity, large variety, large veracity. Veracity is very important. Veracity means conforming to fact, because data that you are playing with, whether it is conforms to the fact or not. And if it doesn't conform, then it will create uncertainty, loss of information, explainable AI, trustability AI, all those streams, because your data is not perfect. So that's why veracity has become a very important issue. Now we'll explain this by information application. So let's consider a difficult task. We are considering unsupervised video tracking for handling overlapping and occluded object. That means you are tracking one object, another object got occluded. Still you want to track. So you are using prediction method. What you will do? Well, you use spatial color neighborhood. That means you take videos means sequencer image frames. So if the sequence frames is a color or one, you compute the similarity of the neighboring intensities, and you put a threshold. If they are dissimilar, then you cut it. If they are similar, you integrate. So it's a region growing method. By this way, you extract spatial color neighborhood in tau space, that is in difference domain. So you take the table, because if you take the tau domain, then the only roaming objects will be common. Because static object, if you take the difference, that will be 0. And then we develop a new filter. It's called neighborhood dart filter. That borrowing idea from electrical engineers. Electrical engineer, you have idea say low pass filter, band pass filter, high pass filter. Here I got rough filter. It gives estimate of location of the color object in terms of lower and upper approximation. So I have sequence of images, image frames. I pass it through the filter. I get object model, that the estimated value of the object in 3 frames in terms of sure and possible. And out of those, I get the values in the predict in the next frame. That's how we object, right? And we compute the index roughness. If roughness is low, that means it is sure tracking. If roughness is more, that means object is occluded. Then we take the boundary object pixels and we put in the lower side and the upper side, and then see in which part uncertainty is minimized. So giving an example, so what do we do? So union of, you are getting frame, US frame. So you take X, T frame, T minus 1, T minus 2, T minus 2 differences. And you have taken union of, sorry, T minus 1, you take the union of those. And another thing, T to T minus 1, T minus 1, T minus 2, T minus 2 to T minus 3, T minus T4, successive difference. So I get here, if you get P frames, here I get union, 1 frame, here I get P frames. Then I take the convolution of this 1 to P point convolution, and that results in lower and upper approximation. That is definitely belonging of the object model, and definitely and possibly. If you look at the pictorial one, it's a 3 and 1 point crossover point, and our convolution operator is union and intersection operator. This is lower approximation. They will be definitely belonging, possibly, definitely as well as possibly. And based on this, if you look at the one, can you please click it?
Yeah, thank you.
Yeah, please. It's a London underground that this is occluded, completely occluded, but it has been able to track. There is a frames per second 15 and the previous frames 6. If you increase the number of previous frames, it will be expensive also, but it will be better prediction. Yeah, completely occluded. So it's based on prediction. There are other ways also. You can make it based on rule-based classification. You can make it based on segmentation, but it is unsupervised, that's what I'm saying, without knowing the thing. Now, so far we discussed machine learning. Now we are talking about deep learning. Now see the thing, machine learning, as you see, the performance depends on the number of samples. For example, by video, if we have take more number of previous steps, it will be more accurate, but it will be computationally intensive also. So, but today we have abundant data. When I started working in 75, I had only 871 vowel data with just 2 features. With that, we published paper, but now you cannot publish. You need to have thousands of data, and then thousands of your dimensional also. Then you. Now look at this one. today we have abundant data that for machine learning and deep learning, which is an advanced form of machine learning, has become a meaningful choice. However, what is deep learning? Learning in depth in different stages in one sentence, characterized by learning the data representation rather than task. In case of machine learning, we are more concerned about the task-specific algorithm. But here we are more concerned about learning the data representation so that we can learn how to learn. We can learn how to learn on a new data. Abundant data makes deep learning a meaningful choice. But deep learning process is time consuming and difficult to implement because you are taking lots of data and also in different layers you are doing. It becomes, that's why here comes the significance of granulated deep learning. We have that concept. So reduce computation time, improve performance. But sometimes you have to sacrifice because nothing is free. When you make some approximation, you compromise with the accuracy also. So, what is the basic concept we have? This is a typical convolutional neural network, which is widely used for image and video. Every architecture has its specialty. You cannot use it for audio. So in the framework of deep learning, object recognition means you identify the different objects with their probability of occurrence, and then you put a boundary on it. So what we do is it's a convolution layer, then you have max pool, rectifier, linear unit, so on. So what we do, here instead of taking every point, we make a granule first. There are many ways of making granule. So these are my granules. So in TDL model, instead of scanning the entire image pixel by pixel in convolution layer, we jump only over the granules from the one. So for a 32-byte image with n granules, if we have only n granules, where n is much larger than much smaller than 32:1, then we do the sliding filter only n times. Therefore, with significant speed up is achieved, compromising some accuracy. This is a very simple concept. That is, I do not need, because when you make granulation, boundary, your background is not your important. You are only important, you are concerned about the moving objects only. So if you make the granule, I can delete all those portions. So I do not need to use my filtering technique here around every pixel. Now look at this, some results. When you make without granulation, and here different types of granulation. This is a very simple granulation, 3x3 window. This is a rectangular, and this is an arbitrary shape granule, expensive. You look at the speed, tracking, accuracy, and we use CPU time. So without deep learning, without granulation, 1.6 frames per second, and this is the accuracy. 1.89, and it is the most 2.2, but say. So this is the gracefully degradation of this one. Now, this is the GDL framework is used only for testing, not during training. In training, we used reinforcement learning. Now, next question is, can we use it for training also? That will be the important thing. So here our student Onima did this work.
Sir, we have time constraints, sir. 10 minutes.
10 minutes, yes, I'm almost done.
Thank you, sir.
Almost done. My time was 1 hour. So is it including my biodata? I prepared it for 1 hour. Just last page. If I stop it, then everything will be gone. No meaning. So what we did here, I have acknowledged my student Onima, but otherwise this information will just go to her. So actually what she has done, we have improved, we have taken region-based CNN, which is very popular for video tracking. And it has faster RCNN. So our objective was to make it better than faster RCNN in terms of detection accuracy. And so that in real-time detection accuracy improved. So what is the model? Just simple. This was the RCNN. We incorporated this granulation. Spatio color, spatio temporal. Granule, that we take once we make granule, we reduce the pixels, and RCNN they used to take image by image, but we take the video directly because we are taking temporal information. So if you look at this, 1, 2, 3, and 4 block we have added. And what you are gaining? Videos are input rather than static image. Spatio-temporal granules for creating region of interest rather than the better than the faster and faster RCN. Only granules formed over the granules you are considering, not the entire image frames. Similarly, only you are using the positive portion of the granules for training and also recognition. And as a result, you are getting including the real-time detection and speed and accuracy. Your actually the system is also slow. This one. Now this is a typical example I am showing you. This is faster RCNN, AlexNet. We have made GAlexNet. So we have added those modules. So you need to have retraining. You take the trained model of AlexNet, then you make retraining. So retraining you have to just pay. So that is the paying time you give it. But you get the improvement from 57 to 78. Similarly, here also if you take RPN for this another training set data, 0.91 to 1.5, but you are improving this. And similarly during testing, if you see that AlexNet from first RCN 57.1, then first start 65, then granulated 79.4. Similarly, if you take first RCN with another training set, 61, 63, 80. So it's a detection accuracy very fast. Now I'm just skimming last slide because otherwise this lady will kill me. Yeah, please. This is the RPM. Yeah, no. Just last one you take. I'm just skipping. Yes, sir. See what I'm saying. This red means faster RCN could not detect. That's why we have put it in the red marks, whichever. Now next, this is using RPM. That means only spatial color. Now if we take the spatial temporal, more one. Next one, please. Yeah, this is FRPN. No? I cannot see FRPN RPN.
GRCN.
GRCN within bracket RPN. Now take the next one. FRPN. So FRPN is basically spatial temporal. Now you please run it. The video very interesting. See that whatever this FRPN could not do, it is able to detect. This red mark, which are uploaded there. Circle, circle, another circle is coming. Very interesting. That means the detection accuracy has improved. You see, that means though the number of pixels you have reduced down, but those number of reductions are much more effective than considering the entire pixel size. Right. And at the same time, you reduce the computation time. See, if I press. So evolution, I'm just skipping because this morning I told you that. New term. So this is the last slide. So data-driven science in a summary. That means it concerns with the acquisition, storage, retrieval, processing, mining, and finally conversion of data into knowledge. It employs techniques and theories drawn from.
By your hand, I think. Go to the last slide.
Yeah, can you please do it, Lala?
You do it. Last one. This is the last. No.
Just go. See, there's a voice called Atmanirbhar. That was telling that don't just depend on others. Atmanirbhar. I play. No. Yes. Yes.
Go to slide show.
Yeah, last slide. Please. Last slide. So, this mathematics application multidisciplinary, high potential, because which is important, because in India scenario is extremely encouraging, because it has got lots of job funding also, and all kinds of courses are coming up, and this is visible. 5 years back it was not that much, but today it is here. And with this, but again, in the morning I just give you caution. If you do not take care of the fundamental thing, then again 7 to 8 years you will remember me. If I not alive, then what I told it will be true. Again, subject to lost his interest, because America will be then another name. Another name we will be running. And this was our latest book, came during our pandemic time also. Also on scientific, the granular video computer. One of my previous students, he was with IIT Jodhpur. So thank you very much. I acknowledge my students and your colleagues and collaborators all over in India and abroad. And today I am holding National Science Chair position. PhD SCRB. Thank you very much. No question you are asking me to leave?
No.
Take.
We will have a quick question answer session.
What will be the future of economic or return application? Right?
Patternization has a future because patternization is the mother. If you say what is the future of patternization, then that means your data science has got future. See, data science, what I mentioned, everything is a pattern recognition. Data patternization initially it was classification, clustering, feature selection, measurement. Then expert system came, then the term came retrieval. Pattern scientists call it classification, machine learning guys call it retrieval. Pattern guy used to call it feature selection, machine learning guy call it dimension reduction. It's a different name in the user-friendly name. So patternization is the mother subject. You have to know patternization. You have to know classification. It's the same thing. Whatever you're doing, basically clustering. Clustering, when we started working in 75, it was subject for electrical engineer. That the computer science was there. Today, clustering is a subject for any applied scientist working with any kind of data. See, you get a huge data given to you. You do not know about data, anything, how many classes, where they're coming on. What do you do? You make it, you assume cluster number 3, cluster number, total number C equal to 4, 5, 7, then you make it clustering. Simple. Series clustering. If you get the pocket, fine. So clustering is a must. Whatever you're doing unsupervised video tracking, it's basically clustering. Granular computing, what you do granular, it's a clustering. Without knowing anything, you find the similarity pocket, similar pockets. So how can you see patterns? Patternization has to be there. Rather, I'll say that time, those pattern scientists, they did not get any money. But today, those are other people who are using, they are getting money nowadays. Understand? Similarly, image processing. When we started, we didn't talk. But now, any data having image means you have to know image segmentation. Segmentation is a clustering, unsupervised. Your whole world is supervised or unsupervised. That is a debate. What task? Your samples are known to you or not? Most of the time, samples are not known to us. And sometimes some known samples are given to us. So it is supervised and it's unsupervised. So patternization is the another subject. That's why I explained how it has evolved today to cater to the need depending on the data. And depending on the data means your complication, decision-making problem becomes complicated. So if you want to know deep learning, you need to know shallow learning. If you have to know shallow learning, you have to know neural network, neural learning. A neural node, you have to know pattern recognition. If you have to work with video, you have to know the image processing.
Any more questions?
Any more questions?
Anybody? No. Okay. So thank you, sir.
Thank you very much.
Thank you so much.
Thank
Give
you.
me
Thank you.
this one. This one. Okay. So first of all, sir, we are sorry that the time basically we could not maintain properly.
I took 1 hour.
No, you have not taken 1 hour, sir. Actually, we have started little late. So that's also, I think, Dr. Someone Alani Ajay, please, also is there. So he's waiting from, he's from Ford
I see.
company. But Dr. Ajay, I just want to introduce to you Professor Shankar Kumar Pal. He is basically the renowned personality in the subcomputing, machine learning, pattern recognition. And we are really unfortunate that we could not hear him fully. I think we should have made it at least 1.5 years, half hours. in fact, 1.5 years also, I can say that will be at least 1.5 hours. So, Professor Pal, so we are really sorry for this. And it was a fantastic, I think, the lecture, particularly excellent lecture, I can tell you, because I was listening from the beginning, because many concepts which I was knowing as that I know this data science and machine learning concept, then now I found that there are a lot of lacuna in my learning, particularly conceptualization point of view. So we are extremely happy, sir. You have cleared many of our ideas, and in fact, I can tell you all the research scholars as well as the other audiences members here. So all of you, I think you have also learned, because our department is very much involved in this particular domain, data analytics and machine learning area. So, sir, this is wonderful for all of us, and today, and you are so kind enough to help us in this manner. And definitely, sir,
I didn't help anything.
Yes, sir. Yes, sir. Absolutely, it was a fantastic lecture. I can see that many of the students, they were having some conceptual idea about this particular domain, but they were not having clear ideas, because we have taken the interviews and some kind of when they present their papers and other things in the PhD and other forum. So I found a lot of conceptual difficulties they have, and today I hope that you have got a lot of clarification in this particular domain, and this being one of the most important areas to work on for our department. I am sure that we will invite Professor Pal again, and in some maybe workshop mode, so that you will get much more from him. And absolutely, sir, it is fantastic, fabulous, sir. So we are sorry that we could have managed little. Thank you, sir.
My actually experience were 45 plus years.
Yes.
So actually in 1 hour.
So 1 hour is too less. I know. And at this, yes, sir.
Just evolution of the discipline, pattern discipline. Because many people do not know that, because clustering is the mother subject.
Yes,
Without
yes,
clustering, whatever you do basically clustering.
Yes, sir. Yes,
in the form of segmentation, in the form of your network community detection is clustering.
Yes, sir.
Prediction is clustering. You have to.
And at the same time, Dr. Alani Azhar, so yes, you also waiting for us, and we are really grateful to you. So now your lecture will be started, and that's all. Thank you, Professor Park. Thank you very much.
Now I request our Professor J. Maiti, head of the department, to present sir with a memento. Thank you, sir. Moving on to our next keynote session, which will be via online mode. I would request Professor Akhilesh Kumar to introduce our third keynote speaker, Dr. Saman Rani Azhar.
इसका चेंज करो. हाँ यस सर. दोनों पिन कर दो.
Good morning, Saman.
Good morning,
I hope you
Akhilesh.
can see me.
Can you hear me?
Unfortunately, I have to move back to see you. So, my dear students and faculty colleagues, Saman is a PhD batchmate back in 2006-2011 time, and someone now is working in Ford, working at Ford. We would like to welcome you, Saman. I hope you can hear me.
I can hear you well. Can you hear me?
Yeah, fantastic.
Okay.
So, Dr. Azhar, who is a global leader in AI, ML, and analytics at Ford Motor Company, with more than a decade of professional experience in data analytics in automotive, marketing, and financial industries. Before moving to right now, he is looking into all this AI, ML domain quality, but before that, he also worked at the Ford Credit. He was a senior research scientist at Analytics Research and Development at Ford Motor Credit Company. He did his PhD in our domain only, industrial engineering from Wayne State University. He worked in demand modeling and capacity planning for innovative short life cycle product. And he has a master's in applied mathematics from Wayne State. He is treasurer of Southeastern Michigan chapter, Institute of Operations Research and Management Science, which we know informs. His areas of interest includes product analytics, operations research, product assortment, credit analytics, demand estimation, but I believe he is now more involved in AI, ML in quality. So, Saman, I welcome you again to our Research Scholars Day. Just to give a brief background, it's more like our graduate symposium, where all the research scholars of the department come together and present their work in what areas they are working on, so that the whole department gets a feel of the departmental research, and more importantly, free lunch. So I welcome you again. Over to you, man. Thank you.
All right. Thanks, Akhilesh, and thanks for inviting me. I saw some gifts and flowers. We need to find a way to get those to me. So.
Sorry, I forgot to mention you. All right. Memento for you. I'm keeping it with myself. Next time when I see you, I will keep it as it.
That's good way. Thanks, Akhilesh. So, good afternoon, good evening, everyone, and thanks for having me. I'm really excited to be here. And I was texting Akhilesh before the session that I don't want to be the sole speaker here. Please, I will wrap it up as soon as I can, and then I would love to hear you guys' perspective and what you think and ideas. And it's always fun to talk to graduate students. There are more content and less on politics, so it's always fun to talk to them. So let me share my screen, if we don't mind. And I'm not very, our company's WebEx, and it's not Teams, so I'm a little bit not very familiar with this tool, but let me share it 1 second.
3 dots. Yeah.
Do you guys see my?
Yes, sir. Yes, I see.
Which one you see, the presenter mode or the audience mode?
Presenter mode. We can see your slide, Saman.
It's good now. Yep. All right. So I will talk about, as Akhilesh said, these days in the last 3-4 years, I've been very involved in quality. We have a domain called Quality Analytics, and I've been leading this for Ford Motor Company in last 3-4 years. So I will talk about why quality is important for the company and what we are doing on tool and AI ML side to support different quality initiatives for Ford. This is Mr. Jim Foley, is our CEO, and he's since he started his role, he had put a lot of emphasis on quality of our vehicles. This is a quote from him that this is really moral and ethical contract with our customers to improve our quality. Why quality matters? Some quality issues might lead to safety issues for our customers. Is something we are trying to avoid. Quality issues lead to satisfaction and brand loyalty for our company, and ultimately, it's a key objective for Ford Motor Company with respect to warranty and the cost of quality for the enterprise. So if I name 4 or 5 top priorities for Ford Motor Company at the moment, quality is one of them, improving quality of our products. So I brought this slide just to give you a high-level understanding of a company like Ford Motor Company. And think about it, and this is really oversimplified, you know, I don't have anything about suppliers here, but think about, we do from left side, we build components, the major components, let's say engine, transmission, axle. We move those major components to our assembly lines, final assembly lines, and we call them vehicle operations. And over there, we build the final product. We ship the final product to dealers. Dealers, they do preparation, sometimes some fixing of issues on the vehicle, and then we sell our vehicles. And that goes to the customer using some new technologies that we have on our vehicles. We collect some data based on if our customers allow us to do it. Issue happens, things break. Vehicles are very complex products. So either the customer takes the issues to dealers to fix them, or we have over-the-air updates if there are software-related issues. So when I talk about analytics and tools to support this process, we talk about 2 types of tools. One is in prevention side. This is before we ship our vehicles. We have algorithms and models and tools in place to prevent having quality issues. And I will talk about it in more details. The other one is find and fix. What we at Ford, we call it find and fix. The vehicle is out there. It's not in our possession anymore. And we need to quickly find quality issues and fix them. First of all, for those vehicles that we already produced and they're out there. And also make sure we fix our process so we don't make the mistakes that we already made. So I will start in this talk. I will come back to this slide, but please just spend some time to understand it. So prevention and find and fix. I'll start with prevention and then I'll go back to find and fix and explain what we do over here. Okay. Preventing quality issues. The speaker before me was talking about classification, and basically preventing is a classification problem in a way that you have historical data that tells you what, let's talk about transmission. We have historical data that tells us these transmissions had issues when our customers started driving them. And this vehicle, these transmissions did not have an issue. So that's our training data. Now, using this historical data, we want to build predictive models that tell us, hey, if you ship this transmission to customers within first 5,000 miles or that many kilometers, you will have a quality issue. Why it is difficult? Quality issues are not often frequent, you know, and this is probably many of you know where I'm going with this. Our training, if you as a scientist start working on it, your training data is not very balanced data. We have very, very few failures, but those failures are big failures, important failures, very expensive failures for Ford Motor Company, for our customers, but they do not happen often. So you were working with a data set that 99% of it is fine and 1% and sometimes under 1% failure. And you need to learn from this imbalanced data to build prediction models. Achieving an actionable precision using this kind of imbalanced data is very challenging, and I'm sure many in the audience understand it and know about this. I use this slide to communicate with our senior leaders in the company, but think about, let's say we have a program, F-150. I hope you heard about Ford Motor Company F-150. This is the high-selling vehicles in North America, across all manufacturers. Let's say we produce 500,000 units per year of that vehicle, and let's say 2% of those have a failure rate, have a quality issue. Now, I ask you as scientists, machine learning scientists, to build a prediction model to use in next 500,000 units to predict those 2% of vehicles that they have failure rates, so we don't let them go to the vehicle, be installed on the vehicle, so we prevent those quality issues. Very quickly, again, this is just simple three. We have 500,000 units, 98% have issues, 2% do not have issues. And let's say we build a very, very good model with 95% accuracy, both for healthy population and unhealthy population. And here probably you see where I'm going is we have a problem, which is we make only 5% mistake in the healthy population, but because my healthy population is so large, I make mistakes in 25,000 vehicles. So 25,000 vehicles, it's false positive, they're fine. We can ship them to customers, but because of my 5% mistake in the model, I label 25,000 vehicles as having quality issues, and indeed they do not have quality issues. Compare it to the 95% of the 10, and if you see my mouse here, 95% of the 10,000 vehicles that they have quality issues, and I want to predict them, I want to prevent them to be installed on vehicles. I'm 95% accurate, so I captured 9.5 thousand of them, 9,500 of them. So if you look at this, my false positive, which is 25,000 vehicles, is way larger than my true positives. Again, the reason is this imbalanced data. Large population of my data is fine. So what it does is I will end up with 27% precision, and I'm sure you all know what I mean by precision. What it means is I build a model, I spend a lot of resources of the company, I put that model in the plant, and I tell the engineer that do not let this transmission to go to next step because it will have issues. But in every 4 transmission that I stop, only 1 of them have quality issues. The rest are fine. This has consequences for the company, and it increased the cost of our manufacturing, and ultimately that cost will be transferred to our customers. So think about here, my failure rate was 2%. In many cases, failure rate is way lower than 2%. It's 1%, 0.5%, and that will, you see what it does to my precision. So I brought this slide today here to, I know you all graduate student and working on different probably research areas. A lot of problems in industry are imbalanced data sets. You know, make sure you study this field well, you understand it, and you know how to apply the techniques in this space, in this type of problems. This is just to explain what I said. Think about it like I'm working on transmission. Those transmissions either normal or they're anomaly, they have issues. And I have a prediction model that tells me if either they are normal or they have anomaly. So the diagonal one, if they're normal and my model says normal, good, then fine. If they're anomaly and the model predicts that they're anomaly, great. Again, this is what we want to do, but the false positive is the place that make us irrelevant, which is basically because they're false positive, so we interrupt the process, we add cost to the process, we risk overwhelming of the repair team, material costs will increase, and this is something that we cannot do sometimes in some situations. False negative is meaning it's anomaly and we missed it, so basically we ship that vehicle to customers, it leads to warranty, cost of returns, and customer satisfaction on us. So this topic, I want to wrap it up. Next one that I want to talk about is interpretability. You know, in some settings, let's say you are working in the previous example, previous speaker, I saw that there's a deep learning that detects some objects or drivers or motorcycles or cars. those settings really, the business user does not care about interpretability. So think about, let's say you have a function y, and this function, you have a response y, and this response y is a function of multiple access features. And you have a function on those features, and you have a coefficient. Just think about it basic, let's say linear regression. Sometimes the business user only wants y star. They don't really, it doesn't matter to them how you got to y star. They just want a good prediction model. Tell me if this is a bicycle or not. Tell me if this is a walking person or not. Tell me if it's a stop sign or not. It doesn't matter for them how you got there or how you tell them. As long as you tell them in a reasonable response time, they're good. Many examples in industry are not like this. In a way that the end user wants to know why you made that decision. What happened? What are the factors that are important on this response, on your prediction? So both y star is important and beta stars are important. You know, that coefficient, the way this, just think about the example. Not in many, we don't have beta star in random forest, for example. But what I'm trying to tell you is we need to, as professionals in this field, we need to be able to explain our models to give users confidence that why we are making these decisions. And sometimes it's by law. Let me give you another example. I was in for credit. I was scientist over there. Any model that we built, we had to explain to legal that why we are, what this model uses as input, because this will go and end up in some financial loan decision to customer. So we need to make sure that our models does not use some features like race, like gender, or things like that as input to make a recommendation for loan. So sometimes regulatories, we need to do it, and sometimes just business wants to know why you are telling me this transmission is bad. You have to explain it to or her. So probably shop value is something we recently have started using, and these are few examples. I try to hide the details, but whenever we say this transmission is bad, don't send it to next stage. We will tell users why we are making this recommendation, what drives this prediction. Okay, with this I wrap up the prevention side. I try to explain the challenges over there, and then in Q&A section we can go in more detail. So let's go back to find and fix, and this has been my life maybe for last 3 years. Then I will explain why this field is very challenging and difficult, and the things that we had done for Formato company. So find and fix is where we ship the data, we ship the vehicle, and the vehicle is out there. And now we want to think about it. Ford has millions of the vehicles on road. We want to find issues as soon as possible, and we want to fix them. So think about, you are a problem solver in the middle. Your job is fixing quality issue. Let's say you are a brake engineer, or you are a transmission engineer, or you are a pump engineer in engine, or things like that. You are a problem solver. You need to know what to fix. What are the issues out there that we need to fix them as soon as possible? So I want to start with here from the detection. So as an engineer, you need to know what are my issues out there. So we need detection engines. We need anomaly detection engine, and I will talk about this. Then there are always more problems than I can solve all of them at the same time. I need a prioritization list. I need to, so as an AI ML scientist, you need to tell them first of all what their issues are. Second, you need to prioritize for them. Say issue 1 is more important than issue 2, and that's not easy. I'll explain why prioritization is not easy. It's all about predicting. The third one is what causes the issue. You know, as I said, you know, sometimes we have iPhone. It's majority of the time it's on our table or in our pocket, or we are doing stuff that's very predictable, and we know how people are using the iPhones. Compare it to vehicles that, for example, in Ford, and the example that I mentioned is F-150. F-150 are driven in Alaska, in Texas, in high altitude, low altitude, in severe cold, in severe hot. In India, the car has to drive. In New Zealand, the car has to drive. In Russia, the car has to drive. So very, very complex environment, an unpredictable environment. So when you tell engineers, hey, Mr. Engineer, you have an issue that's very important for the company, you have to fix it. The next question is root cause analysis. It's okay, what happened? And I have a section about it, how we can tell engineers that don't worry about everything else, focus on these factors and see what's happening here. I'll talk about this more, and ultimately, this is more for leadership. They want to know if the containment, whatever we did to fix this issue, did we really fix it? Or no, the issue is still out there. Or in some cases, we tried to fix an issue, we made it worse. So verification. So you as scientists, when you look at this, what are my issues is anomaly detection. You need anomaly detection tools to tell engineers their issues. And I tell you guys in the next slide why it's so difficult. This one is statistical and sequence modeling. It's like probably if you know survival analysis or tools like this is how many customers will be impacted with this quality issue, how many safety issues we will have, how many fire we will have. These are all factors that impact the prioritization, and sometimes they're more difficult than detection. This recommendation system is telling the engineer, hey, seems like this issue is only happening in high altitude, drivers who have short trips, or this issue only happens in big cities in India when drivers have to stop and very frequently, or this issue only happening in very cold areas. So a recommendation system that very quickly tell the engineers not the root cause is difficult, but the space that they have to go search instead of looking at the whole ocean. The last one is causal inference and treatment effectiveness. Is we took action, did we fix it or not? And this is very common in tech industry these days for A/B testing and the things that they do on websites and things like this. That's the concept is very similar. Let me talk about detection. So, as I said, we collect data. So remember, I want to make sure everybody follow where I am. I'm in find and fix. Vehicles are on road and we want to find issues and fix them as soon as possible. So how do I know as a Ford employee that we have a quality issue out there? We have data from connected vehicle data, vehicles that we have. So some of vehicles have modems, and if the customer allow us to collect data, we collect some engineering and some data that's related to engine or transmission about the health of the vehicle. We have call center data, some customer call us. We have government agencies that they are overseeing our operations, and sometimes our customers call them and complain to them about issues, and they have databases. We conduct quality surveys. Our quality surveys are verbatim, are text. Dealers, when a vehicle goes to for being fixed, we collect data from the vehicles from dealer diagnostic files. Sometimes, and this is important, sometimes the dealer does not have the part to replace, to fix the vehicle. So we have a quality issue out there, but we don't have enough parts to replace them. So we do not know about them because the parts are back ordered. Technician hotline, sometimes the technician do not know how to fix the issue. So they call us, we have a hotline and we have the text of those calls. And ultimately warranty claims. And this is maybe one of the important ones. So you probably have played with data and you know about heterogeneity in data, different structure. Connected vehicle data is huge, terabytes, like billions of rows. And unstructured call center data is text. Government databases are kind of Excel files that they ship to us. Quality surveys are, we call people, what do you like about our vehicles or what don't you like about our vehicles? Text again. Dealer is very engineering type of data. Part back order is traditional Excel file, assume just it's tabular. Technician, again, traditional, like call center, text data, and warranty is traditional. So we tell you as scientists, hey, build some models that does anomaly detection across all these data sources, and tell engineer, hey, Mr. Engineer or Mrs. Engineer, you have a quality issue in your brake. The common next question by the scientists is, okay, give me some training data, give me some label data that I can use and build models. And I can assure you there is no label data anywhere. So how can you build models when there is no label data? How you can tell an engineer that something is wrong? And even by something is wrong, what do you mean by something is wrong? I think that's different, another question. But how can we build unsupervised model to detect issues? Why it's so complex? So as I try to make the case, thousands of signals and components. Vehicles, we have 10,000 plus parts in every vehicle. We have vehicles sold in India, in Asia, in China, in Europe, in North America. Many programs, and sometimes based of regional factors, we build vehicles differently in different regions. Seasonality, you know, maybe just we have more warranty claims just because it's colder season, doesn't mean we have a quality issue. Scale is important, you know, billions, literally billions of rows of data, you know, so whatever you build for us, let's say if you join for, has to be scalable. If you need to wait 2 days to run your model, then doesn't matter how great the model is. Baseline ground truths. Often there is no ground truth. There is nobody collected any data for you. Yeah, this is a quality issue. This is not a quality issue. You have to collect this data or somehow build them yourself. And ultimately, this is something I know. I consider this audience as algorithm audience. People, you guys are modelers, most likely. But whatever we build, the best algorithms in the world has to be deployable. We need a pipeline, we need the software, and maybe in Q&A we talk about it, how important that you guys learn more about cloud computing and deployment and software engineering, maybe as important as your deep learning models. Again, when you build any anomaly detection, it has to go over hundreds of thousands of signals every day. So whatever you build has to be, and I tried to give you examples here, the tools, the models that we use, scan statistic, isolation forest. Sometimes statistical process controls does the job, time series decomposition, how to, and all of this should be scalable, should run very quickly, and unstructured and unstructured data and unstructured data. Let me just give you an example. So let's say that the solid line is number of warranty claims that I'm getting for a part for a program that we launched in 2018. How do I know if this is a normal number of claims? You see, this is January. So in January, cold season, almost for all of our parts, our warranty goes up. So how do I know if this going up number of claims is something that's normal, or no, this is something abnormal, this is anomaly, and I will have to tell the engineer that something is wrong? So what we did, this is called scan statistic. You create baselines. So you look at previous launches, and we look at them, say, okay, just using some Poisson process assumption, say how many claims do we expect for this part given previous launches, and we create these baselines, these dashed lines, and then we have some tests whether this delta is significant or not significant. This is for, we do isolation forest here. What does spike mean? How significant is spike is, and this one is we use to detect spikes in a signal. I'm showing you guys more univariate cases, and we've done a lot of multivariate cases. Is like those signals have been moving together in this signature. Now one of them is not moving the same way that I was moving with the other signal. So the examples that I have here is more univariate, but you can think of many, many multivariate solutions for that. Okay, so I talked about detecting quality issues. Prioritization needs maybe a few hours by itself. I'm not going to focus on that. I will talk about this one, a recommendation system that help the engineer to find the root cause of the issue. So what we build it for, it's a risk factor recommendation system. It's a machine learning statistical model that built on big data technologies to facilitate root cause analysis. So what it does is, so what are the risk factors for a quality issue? Either it's component, either it's en route, somebody used the vehicle in a way that they should not be using. It's a weather data. Let's say before rain, we had cases that before rain, some of cameras had issues. After rain, during rain. Did one of our software updates cause any quality? So you can think of many, many things that may lead to a quality issue. So what it does is think about as variable importance exercise in the model. Let's say you build a model, you have a group of vehicles that they have a quality issue. You have a group of vehicles that they do not have those quality issues. And you have a lot of excess, a lot of factors, features, you know. Was it rain on that day or no rain? Or was it snowing or not snowing? Was it in a cold area or not in a cold area? Was it manufactured on this month or not manufactured on this month? So think about hundreds of excess of features. And your model, probably you guess again correctly, this again imbalanced data, and you build a model, and using that model you create a variable importance report, and that variable importance report will be an input to the engineer. So in summary, a failure happens, either we know by warranty claims or from connected vehicle signals, or we just know these 20 vehicles have an issue. We have a lot of excess, as I said, vehicle content, on-road usage, software version, weather data, components, which our manufacturing process. It comes to this recommendation system, and we did a lot of work for the imbalanced data here. And we want to know which risk factors are suspicious to be offenders in this failure. So if I show you an example, so this is real example, we told engineers that these weather features are correlated to the failures. Again, correlation and causation, I'm sure you guys are all aware of it, but here we just give them signals, hints to fix issues. These vehicle contents are correlated to these quality issues, meaning you see we put increase. We tell the engineers when this engine is on vehicles, the chance that we get this type of quality issues is higher compared to other engines. So instead of the engineering team go look at thousands of factors, why this issue is happening, we tell them, seems like there are some correlation here, and just focus on those instead of looking at everything. I want to wrap it up. You know, we launched early detection platform for Ford, and this has been in usage now for a few years. We are using AI/ML, but this is something hopefully I could communicate that sometimes just we need special attention to our algorithm, because they're not always, we don't have enough data always for them. So we over there updates, hopefully we can fix the issues before even customer knows about them, and this is something it's very priority for the company. All right, thank you very much. That's all I had. I hope I didn't take too much time, and I'm looking forward for your questions, and 32 minutes, so I think I'm good. Please let me know, and I'm looking forward to discuss this content with you.
We can now.
Can you hear me?
Yes, we can.
Okay.
Yeah, please go ahead.
I think there is some people. Okay, sir. Good evening.
Hello.
Hi. Sir, so in your opinion, like I have a question. In your opinion, which product would be having a better quality? Just launch product or a product which has gained some maturity, but at the same time, the mature product has gone several VAV or value addition, value engineering and cost cutting processes. So according to you, which product would be having more or better quality?
So launch is always, when you launch a new product, majority of the content or processes are new. And when you do something new compared to something that you've been doing for a few years, it's always very likely to have more quality issues when you launch a product. So when we launch, we usually have issues, and then as we get maturity in the launch, the issues will be gone. Sometimes some issues, they show themselves at the beginning of the launch. Let's say in its majority manufacturing issues. Some issues we see them after 2-3 years. It's more design issues, more reliability and durability issues. But often, a product that has been in market for a few years, it's more mature and less likely to have quality issues compared to a product that's just launched.
So how do we bridge the gap between the quality, which is like, if sometimes it happens that the just launched product is not meeting the criteria of not meeting the standards which the mature product is meeting now. So how do we bridge the gap when it is at the customer end?
So the question is how we bridge the gap between a product that has been out there and a product that's new launch. How we make these two closer. When we launch a product, we don't have that much quality issues relative to product. This is a good question, and it's more on feedback. This is not a space I spend so much time on it, but product development, the engineering community has a process. So whenever something happens, and maybe probably you guys are familiar with it, FMEA processes, that when we detect an issue, when the company knows that there is a quality issue, there is a feedback loop to the engineering team to make sure this issue will not happen again. So there is a FMEA documents that the design requirements that the engineer has to satisfy for new designs. And if it's PFMEA, it's process FMEA, then the engineering team, the manufacturing team, they have to make sure that the previous mistakes that we did in previous launch will not happen again. But sometimes when you launch a new product, sometimes you introduce a technology that you did not have before. Especially these days, that every day there are new sensors, every day there are new technologies, things are changing very rapidly. So you have not done it before to know about them. But if there are things that you've been doing before, there is a feedback loop to the engineering community to fix the issues, to make sure we don't repeat them again.
Thank you.
Any more questions?
Hi, Dr. Saman. So I have a very basic question. So as a teacher, I teach statistical quality control, then quality engineering, design of experiments. So the traditional quality control tools like control charts, acceptance sampling plans, how relevant are they in a modern manufacturing plant like you have in Dearborn? So are they still in use, or so that's what I want to know. So my students can also get inspired to pay attention in the class. So yeah.
I think they should. Yeah. Design of experiment, for example, the name changes, you get fancier, we call it A/B testing, and they call it different things, but the concept is the same. The concept of I need to design an experiment to make an engineering conclusion about a new design or new action or new thing that I did. So that concept, it doesn't matter what we call it, is important. And think about design of experiment, let's say you want to test, you build a prototype and you want to do some tests, or let's say you're a calibration engineer and you want to calibrate your engine, or how many times you need to run your experiments, without really, because experiments sometimes are expensive. You cannot just do whatever you want. So there's a lot of surrogate models, a lot of techniques in design of experiment these days that are helpful to make sure that we get to a conclusion as fast as possible. Statistical process control still valid, still used. We are using it. So it's simple, it's fast, and sometimes false positive are high, but again, these days, unfortunately, the environment is either you do deep learning or nothing else. Either you have some, either you are so fancy deep learning models, neural net, or anything else is not sexy and enough and not interesting enough. So learn deep learning, but be problem solvers. Don't be technologists to just learn this library, learn this tool, learn this Python code, learn this whatever. Try to learn how to solve problems. In an SPC chart, solve your problem. In industry, what that matters, not how fancy your Python code is.
Thank you.
Hello, sir. Greetings of the day. Sir, you have mentioned that it is difficult to find the root cause. So when we have sample data. Am I audible, sir?
If you come to the front, next to the flowers, that will be good. I'm sure this.
Okay. Hello, sir. Sir, you have mentioned that it is difficult to find the root cause. So, but when we have the feedback data, so can't it be identified at whether it is in the construction phase of the parts or it is in the assembly phase? So why it is so difficult to find the root cause?
So causality is really a philosophical issue these days. It's causality is what causing an issue. So let me give you an example, a real example at Ford that happened. We had a quality issue, an engine issue, and we ran this model that I showed, the tool. And the tool said, those vehicles that they have snowplow package, probably in India, these trucks here, they have this snowplow in front of them that for moving snow, and it's very popular, especially in the cold area. The model says those vehicles that they have this snowplow feature installed on them are more likely to get this quality issue, this engine issue. And we stopped there. The engineering team went and studied. They said when there is a snowplow, there is a block of air to the engine, and that causes some issue and some failures in the engine. The real cause is really this blockage of air, which me as a machine learning scientist, I don't know that scientific engineering concept, that causality. But I can narrow down the scope for them. I can say, go look at only those vehicles that they have this package, this feature installed. Go look at only those vehicles that the driver, let's say Amazon driver, they have very, very short trips. They drive, they stop, they drive, they stop, like less than 2 minutes. Go look at only the vehicles that they are in Texas, very hot area. What causes it? It's an engineering concept. There are some stuff in the engine or transmission that's happening, and I do not have that knowledge. And they have to go figure it out. What I tell them, what I help them is narrowing down that search space for them. Did I answer your question?
Yes, sir. Thank you.
Sir? Go ahead.
Sir, in case of a new product development, if we don't have enough real-time data, sir, how can we comment on the quality of the product? Do we just depend on computer simulations?
So like every other product, any engineering product, we build prototypes. We do not just release products just first day in the plant. And they're very expensive. The prototypes can be like real prototype, like Harvard prototype. When let's say you are an engineer building the infotainment system, like the the one that interact with the driver. We have boxes that simulate that environment for the driver, and the developers can test it. Sometimes we build the whole vehicle in prototype to test what a new feature, something that we have not tested before. Sometimes we have simulation like engines that they simulate a piece of code or a piece of engine code that we want to try it in real world. So we do not go directly to real world. It's the case for any product that you build prototypes and you build simulations, like either software simulation or real simulation on those prototypes. Did I answer your question?
For us academic researchers, so when there is a cost constraint and we can't build prototypes, so then what to do?
So this is then that's why things happen in real world. You didn't test well, you know, you didn't consider, and that's the thing that your professor for design of experiment, you never have enough budget to test everything. What are the tests that you need to do? That, let's say you have a space, you need to understand that space. You cannot keep sample from everywhere. You can take 5 samples, 10 samples. Which sample should you take to give you that function? So you have some confidence that I understand my surface, my response. So you cannot test everything. That's why things happen on the field. But there are ways to be more efficient in the time and resources that you have to test stuff.
Thank you, sir.
Thank you.
Hello, sir. So I have a question, sir. So how the question is from the detection side. So if there is a new data, so how do you like confer that it is a anomaly or it's an event?
Yeah.
There is no prehistoric record of it.
Yeah.
Yes, sir. And the second question is, if at all you are labeling it, so how are you determining what is the root cause behind it?
Sorry, your second question, what was it? The second one?
So once you are determining that if it is it's an anomaly or an event, so how are you determining what is the root cause behind that anomaly or the event?
Okay. So when your signal is new, then that's always difficult. You know, what is your baseline? What are you comparing against? So for example, we had launches like Mach-E. I don't know if you heard about it. This is our new battery electric vehicle. And this is the first battery electric vehicle that Ford Motor Company produced. So a lot of parts, a lot of components, we had no experience, no signals from them before. Sometimes engineers, they tell you, hey, I expect this part to have similar behavior to another part in another program. Sometimes you have this. Most cases, you just cannot give any evidence until you have enough baseline. So think about in an SPC. You cannot run an SPC day one. You know, you need some history here to create your thresholds. Most of the time you cannot. You probably say in the first 3-4 months, I cannot tell you which one is anomaly or which one is not. But after that, you have a baseline that you can build your model on top of that. Second question. So let's say your anomaly detection engine says something is wrong. Okay. We used to get 10 claims for this vehicle. All of a sudden we got 50 claims last week. So something went wrong. So now up to that point, let's say you have 100 vehicles that they have this quality issue. And you have 10,000 vehicles that they have not have this quality issue. That will be an input to your recommendation system. That will be your 0, 1, those that they have quality issue, and 0 that they do not have the quality issue. And the engine tells you, seems like this 0 and 1, this binary response is associated to X10, X25, and X30. And the engineering will take it from there. Okay. All right.
Any more questions? Thank you so much, sir, for sharing your knowledge with us and enlightening us. Now, I would request Professor Saik Roy Chaudhary to come forward to the dais to propose a vote of thanks to our keynote speaker.
So, thank you, Dr. Saman, for your wonderful talk. And we all got to learn something. And I must tell you that I had the good fortune to work at the Ford GDIA at Dearborn as an intern for 2 months. In
GDIA? You said GDIA?
GDIA, the Global Data Insight.
That's the organization I'm from.
Yeah. So I worked there for 2 months in 2016. And we got to know your insights about the QoS and the steps to do it. So thank you again, and so this has been a wonderful session. So thanks a lot.
Thank you very much. I enjoyed it. Hopefully you guys enjoyed it too. Thank you.
Professor Akhilesh has some words to add.
Sure.
Thank you very much, Saman. I don't know how to show my face, so I will be this side.
No, you're good.
Okay.
Yes.
Thanks, Saman. Very interesting, and the reason I can say very interesting because we have started this graduate research symposium or research scholar day 10 hours ago, and still we got some 6-7 questions, and I think that is maximum for today. So people were still interested, and because they see the value, I believe the real world examples of AI ML, and as you said, fancier the things, because one thing which you have added, and that is a very important thing for you. Most of the time you come to us and so that I have learned this package. What we really expect, first you learn the method and then run the package, because you have seen the effect of imbalanced data, right? Accuracy was high, but the model was bad. So thank you very much for highlighting that. Not in academia, even industry people don't like those people.
No. Yeah.
Okay, thank you very much, Saman. Have a
wonderful
day, and hopefully we'll invite you in person sometime.
I would love that. Yeah, I don't know how far you guys are from Chennai, so we have a big presence in Chennai.
But you guys are pulled out, right?
Say it again.
GDIA office.
Manufacturing, you have pulled out from India, right?
Yeah, manufacturing, but we have a big presence. We have thousands of employees in India. So in Chennai, there is a GDI team and there is other.
You are traveling to your Chennai office, let us know, and we'll arrange everything. Thank you very much.
I'd love to do that. Thank you very much. Thank you, everyone.
And until then,
with this session, we conclude our Research Scholars Day. Thank you all the PG students and research scholars for making this event successful. We will have another certificate distribution session on Monday. Thank you.